You are listening to a piece of the Salasin.10 podcasterium. You are listening to a piece of the Salasin.10 podcasterium.
Business, which I referred to earlier, where third-party retailers can actually store their goods in our fulfillment centers, and we will deliver them on their behalf. And then the third business is the business that Ash and myself represent, which is our IT infrastructure business, Amazon Web Services. But the question that we are still asked, and I'm in my 5th year at Amazon Web Services, the question we're always asked is, well, how did a bookseller get into cloud computing? Well, the fact of the matter is that Amazon has run a highly scalable, fault-tolerant global infrastructure since the beginning. We're now into our 20th year of business. And from the beginning, the goal was always to be the largest, not only the largest bookseller, but the largest retailer in the world. And that presents a lot of different challenges that you've got to be able to address from an IT perspective. So we built up a large amount of core competency around running these highly scalable, fault-tolerant infrastructures. But what that also made us realize is when we would talk to our other customers or our partners about challenges that they ran into, we realized that it was very similar. It was very hard for people to scale. It's very hard for people to be able to scale horizontally as opposed to vertically. It's very hard for people to be able to release assets when they no longer needed them for their infrastructure. So we came out with the Amazon Web Services platform. This has evolved rapidly over the last 8 years. But what I want you to focus on is what our core area of focus is. So we have a global infrastructure platform that provides a variety of different networking technologies. But really the core is around compute, storage, and database offerings. Denny will go into depth into each one of these areas. But that's supplemented by application services and then deployment and administration offerings as well. And for those of you that have been using AWS for a long time, you'll know that we have a rapid pace of innovation. So as you see, we launched in 2006, but that pace of innovation has really ramped up from 2008 to 2013. Last year alone, we came out with 280 new features or enhancements to existing services. Okay? This year, I expect us to get to almost one per day. So just think about that. So we don't expect you to know every single enhancement or innovation that we come out with. But we want you to know that we're coming out and iterating upon the existing services based on what I just talked about earlier, which is that aspect of iterating and learning based on feedback from our customers. We have a global infrastructure base. So as many of you would know, we have infrastructure in Singapore, which we launched in April of 2010. Then we launched infrastructure in Tokyo in March 2011. And then in November 2012 in Sydney. And then we've pre-announced our China region, which will be in Beijing. So currently we have 10 regions globally. 40% of that capacity or infrastructure sits in Asia Pacific. That consists of 25 availability zones. Availability zones are data center clusters that reside in a specific region or geography. And then we also have over 50 edge locations. So edge locations are for our content delivery network, or the service which is called CloudFront. So that allows you to accelerate content closer to end users. So I'll talk about how a Malaysian customer is doing that today for their global user base. We're also trusted by some of the largest enterprises around the world. So Shell has been using Amazon Web Services for a number of years. Shell has these deep sea oil wells that actually they put sensors at the bottom of these deep sea oil wells, and they're pumping petabytes of data out of these oil wells every single day. They put that data up on AWS into S3, and then they process that data to be able to make decisions on what's the best way to move forward with the drilling that they're doing. We've been working with companies like GE for a number of years. So GE has plans globally to reduce their data center footprint and augment their existing infrastructure with Amazon Web Services. We also work with a number of ASEAN enterprises. I'll talk about Astro a little bit later. We work with Tiger Air, who runs a variety of different applications on top of AWS. Jollibee, the largest fast food company in the Philippines, runs a variety of different applications on Amazon Web Services. Every single one of these companies runs mission-critical workloads on the AWS platform. We also power some of the most successful and fast-growing startups across Southeast Asia. Many of them you would be familiar with. And this is supported by a vibrant and diverse partner ecosystem that's specific to AWSome. So what's important to note is AWS will be able to help you and educate you and enable you on how to use our platform. But if you need additional assistance or expertise, we have great amounts of partners that will be able to help you along your cloud journey. This is the latest Gartner Magic Quadrant. It came out last month. What you will notice is that Amazon Web Services is in the upper far right. And those quadrants are based on ability to execute and completeness of vision. If this is the first time you've seen a Gartner Magic Quadrant, it's important to note that being in the upper right-hand corner is where you want to be. And what's interesting to see is that over the last 4 or 5 years that Gartner has had this Magic Quadrant for infrastructure as a service, AWS continues to go up and to the right. And that's based on our ability to execute in a completeness of vision. You can download this report and read through it. It's a fascinating report. So why are companies choosing AWS? Well, first, we're architected for enterprise security requirements. Whatever certifications and accreditations that you require to run your workloads on, we have those certifications for you. Whether it's ISO 27001, whether it's SOC 1, whether it's HIPAA compliance for healthcare applications, PCI compliance, whatever it would be, we provide those certain certifications and accreditations. And those are done by third parties. It's not something that we're certifying ourselves for. Okay? We also provide services like AWS CloudTrail, which allows you to have complete logging for governance and compliance. People that are actually accessing your applications. Lower costs with AWS upfront and increased savings as your usage grows. So there's a number of scenarios that we see for people when it comes to pricing. So you can replace your upfront costs or capital expense with lower variable costs. Okay? So we're replacing CapEx with OpEx, getting economies of scale, which allows us to continually lower costs, and I'll talk about that in a moment. We have different pricing models depending on what your use case is. Okay? So if you're running something that's a short-term, let's say, application for a large event, like the World Cup would be a great example. It only lasts for a month. You would use our on-demand pricing model. But if you're running something in a steady state that's running 24/7, it'd be better for you economically to use what we call reserved instances. That allows you to pay a small upfront fee in exchange for a significantly reduced ongoing hourly rate. And that savings can be as large as 40 to 60% on your ongoing hourly rate. So a number of different pricing models to make sure that you pay the lowest amount possible. And the fourth is you're going to save money as you grow on the platform because we have tiered pricing, we have volume discounts, and we also can provide custom pricing. So talk to us about what your use case is, and we'll give you a recommendation on what would be the best fit for you. Now, reducing or replacing upfront capital expense with lower variable costs. Traditionally, and who here does capacity planning for their businesses? Anyone? No one wants to admit that? It's a very difficult job. All right? One of the challenges that we've heard is that it's very difficult to actually accurately plan on how much capacity you need. And then you also actually have to spend or pay for that capacity up front. But with the cloud, that completely flips that on its head. So you no longer have to worry about the capacity, and you pay for only what you use, just like with your utility. So when you turn on the lights, you pay for that utility. When you turn them off, you no longer pay. It's the same thing with AWS. Our economies of scale allow us to continually lower our costs. So traditionally, you have to go to your vendors and negotiate for each aspect of your business. So you have to negotiate on bandwidth. You have to negotiate on your colo agreements. You have to negotiate on the servers, the storage, everything. Well, with AWS, it's not only pay per use, but as we build higher scale, that allows us to actually create a virtuous circle. So we'll build larger scale as we get more customers. More customers leads us to actually go back to our suppliers and buy more from them at a reduced price. And that then allows us to then turn that cost savings that we receive into lower costs for our customers. You have to also remember the DNA of Amazon. We come from a retail background, so we're extremely comfortable running high volume, low margin businesses. And that's led us to proactively reduce prices 43 times since we launched our business. So if you've been a long-term customer of Amazon, you automatically are receiving these price reductions. So you don't have to come to us and say, Rick, can you please reduce our costs? We are proactively reducing your costs without you even having to ask us. So we had a major price reduction in late March, right Ash? March 27th. Where with storage, we reduced the cost of storage at 8 cents a gig all the way down to 3 cents a gig. So think of that for a second. The bill that you would receive automatically was cut in half. So here's a great example from Astro. So Astro has been working with AWS for quite some time. Okay? They've moved their Astro on the Go application from a private data center to AWS, and that reduced their operating expenditure by over 60%. This allowed them to move on idle testing environments when not in use. That saved an additional 10% in operating expense for their digital side of their business. They're in the process of reserving capacity via reserved instances, and this is going to save an additional 40% over 3 years for Astro. But most important for Astro is this is helping them reduce or increase their time to market, right? Get out their products or services more quickly to the market. So they've been able to reduce that to a 3 or 4 week time period. And one of the big drivers for them is they wanted to evolve their business to become more of an agile development company, which is actually in Southeast Asia a unique aspect. A lot of companies do not take advantage of agile deployment methods. They take traditional waterfall methods. We're not here to tell you one way is better than the other, but what Astro's seeing is this agility is allowing them to be more innovative, to get out into the market more quickly. And in fact, it's not just Astro, but without fail, our customers are telling us the #1 reason that they're moving to the cloud is because of increased agility. Because enterprises can't afford to be slow. In the old world, infrastructure took weeks to deploy. So I have meetings all of the time with traditional enterprises. And without fail, they tell me that it takes between 4 to 6 weeks to get infrastructure. 4 to 6 weeks. So when you have KPIs internally to create a number of products or services that need to get out into the market over the course of the year, or to upgrade your ERP system, or whatever it would be, you're hamstrung if it takes 4 to 6 weeks to get infrastructure. With an AWS, you get infrastructure in minutes. So that allows you to create a new dev environment in minutes, a new production environment in minutes. You want to go global, you can do that in minutes. You want to scale up 1,000 servers, you can do that in minutes. You want to scale down 1,000 servers, you can do that in minutes. That is extremely powerful. And this allows you to create a culture of innovation, because it allows you to experiment often and fail without the risk. Because it's pay per use, it's okay to experiment. And if things don't work out, you just shut down the environment and pay a few dollars. I know of businesses that will take the credits that we'll give out today of $100, and they'll be able to run their environment on AWS for a few months. This should allow you to take off the shackles of what you've had to be constrained with previously, and to be more innovative, to be more agile. A great example of a traditional business that has seen this is the Singapore Post. So they use AWS to expand into e-commerce, which I find is fascinating, that a postal delivery service that has been in business for over 150 years came out with a new line of business to focus on e-commerce. Now, they spoke at our enterprise day in Singapore. what was fascinating to me is that in 18 months, they went from a brand new platform with 0 customers on it to now more than 600 customers, where they build, run, and operate the e-commerce front end for these companies, and the back-end logistics that they're great at, they also run. So a perfect example of this is they run the Southeast Asian web front for Adidas. So think about that. Adidas, global foot brand, based out of Germany, wanted to have a Southeast Asian presence. They didn't build it themselves. They turned to the Singapore Post to do that. And Singpost is not only running the front end, but they're also handling logistics. And they've been using AWS as the platform to do that over the last 18 months. So how do you get started? I want to emphasize, especially for the enterprises in the room, the cloud is not an all or nothing proposition. We understand that you have made investments, and sometimes very significant investments, into infrastructure. And then it's going to take a certain amount of time to sweat those assets. Okay? So don't think that we're just saying move everything to the cloud. What I would say is you need to come up with a cloud strategy. You need to be very pragmatic about how you go about this. If you're a startup, I would love to talk to you outside and understand why you would not move to the cloud, because I've got thousands of examples which show that you should be running the cloud. But if you're an existing mid-market, SME, or enterprise, then let's talk about what an approach looks like. So here's what we think. Okay? You've got new applications. Okay? If they're brand new to your business, then look at building a cloud-ready design. Okay? There's no reason why you can't build a new application and run that in the cloud. Okay? If they're an existing application, say SharePoint or Oracle PeopleSoft or SAP A1 or P1, whatever it would be, you need to determine, are those what we call no-brainer apps to move to the cloud? Or do you need to put together a planned phase migration? So let's walk through some of this. If they're brand new applications, you can move dev test, self-contained web apps, social media marketing campaigns, customer training sites, video portals, etc., etc. Those can all go to the cloud today. There's no reason why they can't. No-brainer apps, when we see batch processing, content management, digital asset management, big data analytics, we're seeing more and more companies moving those to the cloud. But the planned phase migration, that's something that you're going to have to determine. So what are the applications that may have requirements back into the data center? Or maybe you say, hey, we want to use the cloud to process data for us, but then we want to store it back on premise. That's perfectly fine. But let's work together to analyze what's the best thing for you as a business to help you become more agile, help you become more innovative, and allow you to scale more quickly. Okay? With that, thank you very much.
Thanks very much, Rick. Thank you. So guys, a couple of key messages that I just got out of Rick's talk. So firstly, get rid of the undifferentiated heavy lifting. The things that don't add value, let somebody else worry about them. And we'd love to be that somebody else. Okay? Don't focus on the infrastructure. Instead, focus on the things that are going to add value to your customers. And whether they're internal customers or external customers, that's where you want to be focusing your energy. Now, just a quick show of hands, because I know that you guys all love putting your hands up. So, how many of you would classify yourself as a systems administrator or a systems operations person? Come on, got to be more than that. Okay. So one thing that I'd suggest you do is go and read up on agile development and DevOps. And you might be sitting there thinking to yourself, I'm an infrastructure guy. Why do I care about development? You need to care. Because we're seeing the world change. And I come from a very strong infrastructure background, many, many years ago. And I never wanted to have anything to do with the developers that worked within the companies that I was a part of. They were responsible for writing applications, they'd handball it over the fence, and I'd be responsible for running it. It's blending. So if you're a systems admin, systems operations person, you need to learn, not necessarily do, but you need to learn about some of these new development frameworks. And likewise, if you're a developer, you can't just turn the blind eye to infrastructure. You need to understand it. You need to think about how you're going to build an application that will scale, that has availability, and it's going to be cost effective. So you need to start thinking about the infrastructure component as well. Okay, so a little bit of additional homework for you. Okay, ladies and gentlemen, so what we're going to do now is take a quick break. Please, during the break, make sure that you go and interact with the team from AWS, whether it's just walking up to somebody that's got a black AWS shirt on. Rico and myself would love to take questions from you, or
ever was an environment able to support life. However, giving instructions to a Mars rover is more difficult than most people realize. Unfortunately, there's no joystick controller a scientist can use to move the rover around. And even at the speed of light, it still takes between 7 and 20 minutes for a transmission to go from Earth, across space, to the rover on Mars. To make matters even more complicated, there are only short periods of time in which scientists can communicate with the rover at all. This makes for a precious window of time in which NASA JPL engineers must determine the next day of mission for the rover. Sometimes they have just a few hours to download data from the rover, then process and interpret that data in order to send new mission instructions back to Mars. When they can speed up the analysis of the data, it leaves more time for science. That's why the team uses Amazon Web Services to spin up hundreds of Intel Xeon E5 processors when they're needed. With the scale and performance of this on-demand computational cluster, NASA JPL engineers are able to drive 12 teraflops performance for less than $40 an hour. This leaves more time to work on programming Curiosity's next steps. It also enables NASA to get greater utilization of the rover's unique capabilities. Closer to home, NASA JPL scientists also use Amazon Web Services and Intel Xeon E5 processors for other computationally intensive workloads, such as robotic articulation calculations and Arctic climate analysis, all while enabling their researchers to work more productively and cost-effectively. When the team needs more computational power to support these and many other missions, they can easily provision what they need as and when they need it. This on-demand scalability lets NASA scientists and engineers keep their focus on exploring the Earth, the solar system, and the universe beyond.
Ladies and gentlemen, we're very excited to welcome you to AWSome Day Malaysia. Please put your hands together to welcome Ash Willis to the stage.
Great, thanks Ivan, and good morning.
Good morning.
I'm sure we could do a better job than that. We want energy, we want excitement, so let's try one more time. Ladies and gentlemen, good morning.
Good morning.
Much, much better. That's what we want to see. So fantastic to welcome you all here today for AWSome Day Kuala Lumpur. This is our second AWSome Day here, and fantastic to be back. So as Ivan said, my name is Ash Willis. I lead our training and certification group for Amazon Web Services across the Asia Pacific region. And today is all about learning. So I don't think anyone would doubt that cloud computing is changing the IT landscape. It's enabling organisations to do things that we would never have thought possible just a few years ago. Whether it's something as simple as landing a robot on Mars, or maybe deploying web applications globally, backing up huge volumes of data to the cloud, moving workloads out of on-premise data centers to the cloud. All of these things that weren't possible just a few years ago can now be done with just a couple of clicks. Now, as we go and we speak to customers, one of the things that we're constantly asked for is help. People want us to help them understand how they can take those first steps with Amazon Web Services. And that's what today's all about. We want to enable you to get started with Amazon Web Services. So as we go through our materials today, I'd really encourage you to think about how you can take the technologies that we're showing you and apply them when you get back to the office. Okay? So think about that first use case or that second use case. But the other thing that I really encourage you to do today is think about how Amazon Web Services can benefit you personally. You're all IT professionals. I'm sure that you all would like to enjoy a very long and successful career in the information technology segment. So one of the skills that I'd really be encouraging you to add to your CV, your resume, is AWS. And we want to get you started on that learning journey here today. So I hope everyone is pumped up and excited. There's lots of stuff that we want to cover. As you can see, it's an action-packed agenda. And what I'm going to be doing in just a moment is welcoming to the stage the head of our ASEAN region, Mr. Rick Harshman. And Rick's going to be talking to you about how we're seeing businesses adopt Amazon Web Services. And not just on a global scale, but also right here in the ASEAN region, and also some great examples from Malaysia as well. Then after our first break, I'm going to welcome to the stage Mr. Denny Daniel. So Denny is one of our senior technical trainers based out of our office in Singapore, and he's going to be running you through the formal part of today's event, the training. And as you can see from the slide, there's a lot to cover. We're going to step you through the concepts of Amazon Web Services, right from storage to our compute and networking capabilities, some of the managed services and database offerings, and then just before we finish up, he's going to be talking about some of the deployment and management techniques that you can actually use to manage workloads within the AWS cloud. I'm then going to be joining you back up on stage, and we're going to give away some prizes. And I'll talk a little bit more about that in just a moment. Now, as you can see, we have incorporated some breaks so that you can refuel and re-energize, because we want to ensure that you're absolutely absorbing all of the information that we're going to be covering. But also during those breaks, I'd encourage you to interface with the team from Amazon Web Services. So there's a lot of us here today. We love talking to customers and partners. So please, as you walk around and you see somebody in an Amazon Web Services shirt, stop, ask questions. We love to get engaged in those conversations. We also have a couple of booths set up as well. So just out the front, we have our Solution Architect Corner. It's not quite in the corner, but we still call it the Solution Architect Corner. And on there we've got Oyvind, Dhruv and Sean, our key solution architects for the region, that can really dig deep and talk to you about use cases. If you've got technical questions around AWS, you want to know how to get started, please go and have a chat to those guys and they'll provide some fantastic advice. Hands up if you work for a systems integrator or technology partner. A few hands? Okay, great. If you'd like more information on partnering with Amazon Web Services so that you can go and deliver solutions to your customers, please go and speak to Jason. He's on our partner network stand. which is also out the front. Big call out to our partner, Intel. Let's give a big round of applause to Intel. Because if it wasn't for their generous support, we wouldn't be able to be here today. So we're very, very grateful to Intel for supporting today's event. Now, when you registered, you should have received a student guide. Did everyone get a student guide? Sir, student guide? Did anyone not get a student guide? Good. Now, these student guides are very important. And the reason that we went to the trouble of printing them is that we want you to take lots of notes. So remember I was speaking about identifying that first use case, how to get started with AWS. So what I'd encourage you to do is, as Denny goes through his presentation, write down questions, write down use cases, write down things that you want to know more about. It's also important to take notes because before you're allowed to leave here today, we need everyone to pass an exam. Just joking, don't panic. But we still want you to take lots of notes. I love the look of horror. It's like, oh, exam. Normally we start to see people run for the back of the room. So we'd love to get your feedback during the event today. So a couple of Twitter handles that I wanted to bring to your attention. So firstly, AWSome Day KL. We'll have the team from Amazon Web Services monitoring any traffic to that handle. And I'd also encourage you to subscribe to AWS Cloud SE Asia. So this is the communication mechanism that we use to pump out information, market-relevant information to our customers and partners across the ASEAN/Southeast Asia region. Who uses Twitter? Nobody. A few of you. So maybe pull out your phone right now, log into Twitter, and make sure you subscribe. So we're an incredibly customer-centric organisation, and Rick no doubt will talk more about that during his presentation. But we love to get questions and feedback from our customers. And we truly appreciate the time that you're giving us today to come along to AWSome Day. I know that it's incredibly hard to get out of the office for an entire day, that you're all going to be very busy tomorrow when you go back, catching up on all those emails and to-dos that your boss has sent you. So we truly appreciate you taking the time to be here. But we want to ensure that you get maximum benefit from your time investment. So please, as we go through the session, make sure you take the time to fill out your evaluation form. Now, the evaluation forms form another very important purpose. Rather than just providing us with feedback, it's also the mechanism that we're going to use in order to give away some prizes. Who wants to win some prizes? Yeah. Come on, guys. Tough room. So we've got some great prizes to give away, including an Amazon Kindle. So I saw a couple of people walking around this morning already using Kindle, so we'd love to add one more Kindle user to our audience here today. And we also have some gift cards as well for Amazon.com. So you can pretty much go and buy whatever you want from Amazon.com. So some fantastic prizes. But I have a rule when it comes to prizes. Anyone want to hazard a guess as to what that might be? You have to be here to win. So if we get to the end of today and I reach into the barrel and draw out your name and you're not here, what are we going to do? We're not going to pick up the telephone and give you a call. We're not going to send you an email. We're going to redraw another winner. So don't let that be you. And I don't know what it is, but everyone always seems to have a great deal of pleasure in seeing people miss out on prizes. So make sure that's not you. and be here through until the end of today. Now, because we're delivering a formal trading class, we'd also like to reward you with a certificate of attendance. So again, you have to be here for the entire day to be eligible for a certificate. It took Denny and myself a huge amount of time to go through and personally sign all of these. So please make sure you're here at the end of the day to collect your certificate. And as I mentioned at the start, this is a great way for you to demonstrate your expertise with Amazon Web Services. So take this certificate back to the office, hang it up, display it proudly. Now, if that's not enough to encourage you to be here for the entire day, there's more. So if you provide us with your feedback, we'd like to thank you by giving you a $25 credit voucher to use with Amazon Web Services. Now let me make that clear. This is for Amazon Web Services, not Amazon.com. Okay, so keep that in mind. Now it gets even better. What's the best way to learn? What are the fundamentals of learning? Hearing, and then what? Doing, practicing. And we want to make sure that you really learn Amazon Web Services. So in order to do that, after today's event, we're going to give you access to our online lab environment that we use for all of our classes. It's powered by a partner of ours called QuickLab. Now the URL is in your books and the lab instructions are in your books, but please don't go to that website until you see an email from me that'll come out a few days after the event. Because if you try and log in, you're not going to be able to get access to anything. Now what we're going to ask you to do is complete 4 lab exercises. And again, Denny will run you through these today. They're documented in the back of your book. So via Quick Labs, you'll log in and you'll need to complete 4 lab exercises. If you do that, it'll take about maybe 3 hours, 2.5 to 3 hours of your time. We'd like to give you some more credits. So we'll actually give you another $75 worth of AWS credits. How's that sound? Pretty good? Okay. So we really want to make sure that you take the time to learn about Amazon Web Services. So how many labs do you need to complete to get $75 worth of credits? 4. Now what happens if you do those 4 labs 3 times? We don't send you 3 vouchers. We say, well done for learning, but we're not going to send you $225 worth of credits. Believe me, lots of people have tried that before. So I always want to make sure that I reinforce that point. So maths isn't my strong point, but if we take 25 and we add 75, that means we're going to be sending you $100 worth of Amazon Web Services credits. And you can do a lot with $100 US worth of AWS credits. If you already have an account, you can go in and apply the credits and use it against your existing services. If you're new to Amazon Web Services, create an account, apply these credits. It's a great way to help you get started. Sound pretty good?
Yes.
Fantastic. Okay, so just before I hand over to Rick, one other thing that I wanted to bring to your attention. We have some fantastic customers here in Malaysia. Many of you are joining us in the room today, so thank you very much for being here. So I wanted to make sure you're aware of a user group that we run on a regular basis. So in our follow-up email, I'll also send you a link to the site so you can subscribe and get notifications. It's fantastic to see that group really gathering momentum and the user base is growing all the time. So I'd highly encourage you to take the time, go and join the user group, get along to some of the events, It's a fantastic way to stay up to date in terms of what's happening with AWS. So with that, please give a big round of applause to our leader for the ASEAN region, all the way from Singapore, via Seattle last week. Big round of applause for Mr. Richard Harshman.
Good morning. How's everyone doing this morning?
Good.
Thanks, Ash. Well, as Ash mentioned, this is our second AWSome Day here in Malaysia. How many of you or maybe colleagues participated in the first one last October? Just have a show of hands. Okay, a few. Glad that there's not too many. That's important. So again, thank you very much for spending the day with us. There's going to be a lot of great information that you hear and learn. But one thing that Ash talked about, and I want to emphasize as well, is please talk to each and every one of the people that you see from Amazon Web Services. Everyone that's wearing a black AWS polo shirt, they work for AWS, so please go and speak with them. If you're wearing a black polo t-shirt and you don't work for AWS, let us know. Again, I want to thank our sponsor, Intel. We've got a great partnership with Intel, as you saw from the video. But one of the things I want to talk about today, before I get into why are companies choosing AWS and how to get started, I'm going to spend about 20 minutes talking about innovation.
Want some caffeine? Wide awake, ready to go? All right. What did you think of Rick's introduction this morning? He's left the room, by the way, so he can be honest. Pretty good?
Yeah, very good.
Yeah, pretty good. So I think that what we really wanted to do was to provide some thought leadership and to give you an opportunity to think big. There's so much that you can do with Amazon Web Services and so many different technology options and technology directions. We really wanted to paint that vision. But now, it's all about execution and learning how to get started and how to leverage upon some of those services. And in order to do that, we've built this class called AWS Essentials. This is a worldwide official Amazon Web Services course. And we deliver it to thousands and thousands of people every year. And it's been designed in such a way that it builds upon our infrastructure stack. So with that, I'd now like to hand over to our trainer for today. Please give a big round of applause to Mr. Danny Daniel.
Thank you, everybody. Can you hear me clearly all the way at the back? Awesome. All good. Alright, so we're going to get through this content. Before we get started, a couple of things to highlight. All of you should have a courseware, but I was told that some of you didn't receive a courseware. So what we will do is we will mail it to you. All you have to do is leave your contact information at the registration desk. The second important thing is the feedback form. We have enough feedback forms, so if you didn't receive a feedback form, please collect one from the registration desk. The reason is we need that so that you can win the prizes today, right? So if you stay all the way till the end, hand in your feedback forms, alright? We will draw out prizes using those feedback forms. So please don't miss out those things, alright? So those are some gentle reminders before we get started. So the courseware that we've given to you consists of all these slides that I'm going to cover. It's going to take you through all the content also. But what I'm going to do is I'm going to take you through all of these slides. I'm going to show you all of the lab exercises as part of my demos. The lab exercise is actually documented in your lab guide, which is found at the end of that book. Alright? So it comprises of the student guide and the lab guide. So without any further ado, let's get started with the first module, which would be Introduction to AWS. And in this module, we'll talk about the history and the fundamental elements. How did AWS really get started? Alright, what's its relationship with Amazon.com? right? Rick did talk about it. He did mention that AWSome.com is a bookseller, right? They started off with this new service-based architecture, which is about infrastructure-related services, and all of this is offered through AWS. So I'm going to take you through a little bit more details there. I'm going to take you through the global infrastructure that we have set up around the world that you can leverage on it. And I'll also walk you through the security aspects that is put in place on behalf of you. And what is your responsibility here as well. So, end of this module, the key takeaway is these three things. One, you should know how to access the AWS Management Console. The Management Console acts as a one-stop interface for you to access all of the services that we offer, but this is a graphical user interface. And this is something that you would start with, but if you're a developer, you may want to look at other interfaces, and I'll cover those things as I go along. We'll also talk about the global infrastructure and the security mechanisms that AWS provides. So first, let's step back and let's talk about this term, cloud computing. How many of us have heard of this word cloud computing? Those who put up your hands, you are awake and you're listening to me. The rest of you, not sure. Okay. So we all know cloud computing is a term that's very widely used, but when it comes to AWS, through the cloud computing platform, we do offer a range of services. A range of services that would help you to build up your infrastructure ground up on AWS. Alright? Not just build them ground up, but also effectively manage and maintain that infrastructure. So today I'll be taking you through all of these services. Alright? But before we really get started, I want to talk about how do we really get into this business. So if you look at the history, we started AWS back in 2006. Again, Jeff Bezos, who is the founder and the CEO of AWSome.com. He is the one who actually had this thought leadership in building up this new business. And this particular business has grown over years. And today, if you look at it, we offer a wide range of services on the AWS platform. Now, the services include core important services, core services that would be like compute, storage, networking, databases. But in addition to that, there are other services required that will help you to also deploy applications in the cloud so that it can leverage on all the cloud-related features. So we have services that will help you in doing that as well. And also, after you deploy all of this, you have to manage it. So there are various management-related services that we have as well. So we've got a lot of services. We are not going to cover all of them today because it's a one-day course. We will cover some of the core services. But before we get into that, we also need to understand, how do I leverage on these core services? Do I have to sign up a contract? Do I have to call somebody? Alright, so let me take a step back and let me talk about that. All of these services are available to you on demand. You can go into the AWS Management Console, and then you can start using all of these services, and you don't have to ask us anything. And some of you might have already done that. Can I have a quick show of hands? How many of you already have an AWS account? And you have something running on AWS. There you are. So did you have to talk to anybody to do that? No. So it's a service layer where you can go in, you can provision resources when you need it, alright, without going through any red tapes and roadblocks that we face today on on-premise infrastructure. Just like Rick mentioned, across various CIOs and IT managers that we've spoken to, they always tell us that it takes about 4 to 6 weeks to get service. That's a long time. So here it's available on demand. When you need it, it's a matter of minutes. The second important aspect of this particular environment is it's available to you in a uniform manner. It doesn't matter whether you are an enterprise, or you're a startup, or a small and medium-sized company. We treat you the same. You can go into the console and you can start using even the high-end services that an enterprise might be leveraging on. You can go and experiment with it. The cost of experimentation is very low, as Rick did highlight in his presentation. Alright? So you can go and experiment and you can try things out and you can then leverage on those services and you can use it for production. So it's available in a uniform manner. And the payment model is pay as you go. Again, if you're using those services, then you pay for it. If you stop using them, you stop paying for those services. So you have that flexibility of not starting up with a capital expense. Alright? So there is zero capital expense. But when it comes to the operational, the expenses, it's going to be variable as well because you have control over that. You can turn off a server and you stop paying for that server. Alright? You can deprovision a storage and you can say, I don't want that anymore. and you stop paying for that storage. So all of this is in your hands. And not only that, many of our services that we provide to you, they are highly available by nature. What does that mean? We've taken that undifferentiated heavy lifting work that you used to do on a day-to-day basis as part of your maintenance, right? You have to set it up in a highly available way. You have to ensure that if something goes wrong, you have another redundant component that can take over that particular service from the user. So all of this is done on behalf of you as part of our service. So if you take a service like, for example, storage, to be more specific, in storages there are various storage-related services. If you take S3, which is a storage service which is used by Dropbox in the backend, it is a service that is highly available by nature. So when Dropbox or you, when you use those services, you don't have to worry about high availability because it comes with it. So it helps you to focus more on what matters to your business, which is agility in your business, getting better in time to market, going out to the market with new products, right? So all of these things are given to you as part of this platform. Now, as you start thinking about moving your workload from your on-premise environment into AWS, you will start asking yourself this question: does AWS provide all the building blocks that's required? So on the traditional infrastructure, which you see on the left side, you've got different types of storages, you've got different types of servers, different types of networking equipments, security devices, and a lot of other things that you use. Now, as you think of moving a workload, let's say for example, application A, that you want to move from a traditional infrastructure into AWS, the first question would be, does AWS provide all the building blocks? The short answer is yes, and I'll explain all of these services as I go along in today's presentation. So we do offer a range of storage services. Each of them come with a unique feature and a unique property. So you need to kind of understand what these storage services are so that you choose them and use them for the right reasons. Not only that, we have various types of servers. So when you go and buy servers, you buy servers with different specs. We here offer you a range of servers with different specs that you can choose from and you can use them. But what is the biggest challenge that you have today in on-premise environment? Say, for example, if you bought a server with the specs X and Y, say 6 months down the road, if that server specification is no longer meeting your requirement, what do you have to do? Buy another server or find a way to upgrade that? Am I right? But when it comes to AWS, you have the flexibility of just turning off the server, changing the type of the server. So from a small server, you can make it an extra large server. But you don't have to do any data migration, you don't have to restore anything. Everything stays intact. So those are some of the flexibility that is offered here. That's going to make you more productive, take away all of that 80% of maintenance work that you do today in an on-premise environment, and we're going to give you more time to innovate. Alright? So all of these services will be explained as we go along in the coming slides, but this would be my most important slide for the day. I want you to take note of this slide. This kind of captures all the services that we're going to talk about today. So if you look at the bottom part, we have a range of core services that will help you to get started. Starting with compute. Now compute allows you to set up servers. And the name of the service that you would use to set up servers is the Amazon EC2. And then we have storage-related services. As you can see, there are a bunch of storage-related services here, and you use them for the right reasons. We'll cover them in detail in the storage module. And then we have database-related services. Now we all know in databases, we have relational databases. We also have non-relational, NoSQL-based databases. So there are various database offerings here. There is also a data warehouse offering here. And there are also caching offering here. So we'll talk about those services as we go along. And if you look at the next level, there are application-related services. These are services that you would leverage on when you're designing applications on top of AWS. And these applications might have content that needs to be distributed to a wide-scale audience. For example, if you have a website that you set up, and you have a global audience base. So what really happens, what's the biggest challenge with a website that you set up in, say, for example, Singapore, and you've got somebody from Brazil trying to access your website? The round trip time, the latency. So we do offer certain services that would help you to take all of the content, the static content that can be cached, and we can bring that content and cache it in Brazil, closest to the user. so that the user can have a better user experience in terms of accessing that content. And not only that, for you, it will make more sense from a cost-saving perspective. Because the way you distribute it, you cache it, you're not sending the request from the origin all the time. So we'll talk about those things, but in short, it helps you to save money. And not only that, from a distributed company perspective, if you're working on any projects where you have to use multiple servers to get a job done. So think about HPC environments, high performance cluster environments, computing environments. So you need clusters of servers to come together to get a job done, or a big data processing environment. So we do offer various services that will help you to do that as well. You don't have to set up all of those infrastructure yourself. You don't have to manage them yourself. We help you to set it up. We give it to you as a service. In addition to this, there are various networking services that is available that you would use as you want to start building a multi-tier architecture and you want to distribute traffic across multiple nodes and all of that. So we'll talk about those services as well as we go along. Then, towards the end of the day, we will talk about deployment and management tools. These are tools that will help you to deploy all of these different services quickly and in an effective way. And not only that, but also help you to manage all of these services. We don't want it to be a nightmare for you. So what we've done is we've created various tools and services that will help you to manage all of these services in a much effective way. Track them, see what's happening. Be proactively notified when things are about to go wrong. Right? So all of these things are services that fall under the deployment and management category. So this is what we have in store for the day. Sounds exciting? Yeah, it does. A lot of things to cover. Grab a coffee if required. Alright, make sure you keep yourself awake. Alright, I will show some demos as well as I go through across all these services. So all of these services are made available to you across the globe. So let me talk about the global infrastructure that we have set up on your behalf. So first thing is you don't have to go around the globe and set up infrastructures. We've already done that for you. So let's focus on the yellow circles for a minute. So if you look at the yellow circles, these are called the regions. Regions are the places where we have physical data centers set up, which you can use. So you can run a server in those physical locations. Alright? So if you look at the region carefully, if you focus on the Asia side, we have in Sydney, we have in Singapore, we have in Japan, and we have in China. So if you look at this, for example, let's take Singapore. Within a region, we have a concept called availability zones. So let me take you to the next slide and I'll go back in a minute. So within each region, we have many data centers. So if you take Singapore, alright, just for example's sake, so that you can understand this better, on the east coast of Singapore, we have a group of data centers. On the west coast of Singapore, we have another group of data centers. So on the east coast, whatever we have, we call them availability zone A. What's on the west coast, we call it zone B. Now from this itself, you kind of understand, we're kind of separating these data centers from a physical distance perspective. We also build them in two different floodplains, two different earthquake zones. They get two different tier 1 service providers in terms of internet or power. What we're trying to do here is, we're trying to ensure that if availability zone A gets impacted for any reason, zone B does not get impacted. So we are building these data centers keeping fault tolerance in mind and high availability in mind. So what should you be doing? So when you launch a server, you have to launch them in a specific availability zone. Alright? We haven't reached that technology out there in the world where one server can reside across multiple locations yet. So here what we're talking about is when you launch a virtual server, basically you're launching a virtual server in the backend, right? So that virtual server has to be launched in a physical server that runs in one of these availability zones. So what you should be doing is, to make your service highly available to your users, example, the website to be highly available to your user, you should run your web service across multiple availability zones. Which means I will launch one web server in zone A, and I will launch another web server in zone B. I will not put all of them in one basket, like as we call all eggs in one basket. That's too much of a risk. Right? So if zone A gets impacted for any reason, if you run all your servers in zone A, your business gets impacted. So what you want to do is you want to architect it right from day one. So you want to leverage on multiple availability zones. But then comes another important question. If I run a server in each availability zone, how do I direct traffic from my users to the relevant servers? What do you use today? When you have multiple front-end servers, what do you use in the front to distribute traffic to these servers?
CDN.
Come on, guys. Load balancer, exactly. Use a load balancer. So what we do is we provide load balancer as a service as well. The reason is if you look at load balancers that are used today, you will have to have multiple load balancers because we are talking about, again, single point of failures if you have just one. So you need to have multiple load balancers to make sure that, if one goes down, the other one still distributes traffic to the other servers. So there is a lot of challenge around managing and maintaining that load balancer. Am I right? In an on-premise environment. What we are doing is we are taking away all of that maintenance and undifferentiated work that we do, and we provide even load balancer as a service that you can leverage on. And the load balancer can distribute traffic to servers running across multiple zones. And we'll cover load balancer in the networking module more in detail. I just wanted to introduce that here because we're talking about multiple servers across two different locations, physical locations. Going back to this roadmap, other than the yellow circles, as you notice, we have 10 different regions around the world. We also have in Europe, we have in South America, soccer is going on there, and we have in, US region as well. And there is a lot more potential, as you see, for having more regions. So we haven't stopped our journey in setting up these regions. We are constantly iterating, we are constantly listening to your feedbacks, and we are setting up these regions. So if you need one here in Malaysia, what do? Talk to us. Okay? Talk to us. That's the most important thing. Now, the reason why I'm highlighting this is because the way Amazon.com, the culture, the way we work, is very, very tightly fixed with customer feedback. Can someone guess, among the services that I just shared with you, what was the very first service that we launched? EC2? Sounds like a sensible choice, right? Everybody wants servers when you get started with, but sorry, that wasn't the right answer.
S3.
S3 is another guess. Storage, yeah, that's a sensible choice, but no, that wasn't the first service that we released. That wasn't the first service that the customers asked for. I know it's going to be a tough one, so let me give you out the answer. The first service that we released is called the Simple Queue Service. SQS. Now what is a queue service? It's a service that holds messages that you send. So when you have a distributed application, one component in an application A might want to talk to another component in an application B. So what it can do is it can leave a message in a queue so that the other application can pick that message and process that message. And guess what? This was the service that the sellers, other sellers who wanted to advertise their products on Amazon.com asked for. So Amazon.com, if you go to the website today, if you pick a product, you know there are products that are shipped by Amazon.com, sold to you directly by Amazon, but you also have other sellers who advertise their price codes and stuff. So when we started off Amazon.com, it was purely we were selling all the products. But later sellers came to us, other sellers came to us, and they said, we don't have the infrastructure that you have. We don't have the resources that you have to build such a large-scale global infrastructure. Can we leverage on your website? There should be a way to do that, right? That's where the queue service was released. So they can push those price codes there, and we pick that up and process that and show them in the web page. So the way we work is very, very, very customer-centric, and that's why I highlighted. If you need one, talk to us. There are solution architects out there. There are account managers out there. Please go and talk to them. Let them know what you need. So that is the global infrastructure that we set up. Now another important question that comes up is how secure is this infrastructure that is set up? So when we talk about security, it's important to take note. Security is a shared responsibility. So if you look at the bottom part, the one in the orange color, that's AWS. We take care of all of that. The physical infrastructure that we set up around the world, we take care of all of that physical security. We take care of making sure the hardware, the software, all networking changes that has to happen is done in a proper, secured way. And on top of it, we offer various services. So we have to make sure these services are offered in a secure fashion. And as we leverage these services, we have to ensure that these services function properly from a security aspect. Okay? All of that is taken care by us. But there is a line that we draw. Let me give you an example. If you use the compute service, and if you launch a server using the compute service, during the launch process, we ask you to create something called a key pair. How many of us have launched an EC2 instance on AWS? Only a few hands going up. So later I'll show you a demo as well, how to do that. During that process you will see, it requires you to create a key pair. Now what's a key pair? A key pair is made up of a public key and a private key. The public key is stored inside the server. Private key, you download it. It's like a lock and a key mechanism. Okay? You download the key, so only you can access that server. Only you can log into that operating system that's running in that server. Now, if only you can log into that operating system, who's going to take care of the patching then? Yourself. Customer. Who's going to take care of the hardening of the operating system? Who's going to take care of the application deployment and security aspect of that application? Customers told us, right? You told us that we shouldn't have any visibility on what's running inside the server because of privacy reasons. And that's what we do. When you launch your server, we give you the key and you have full access into that server and you manage all of the aspects of that. So operating system, application, data. How do you store data inside that server? Is it encrypted or stored in a non-encrypted way? All of that is your choice. And some of you might say, hey, you know what, I don't have to encrypt it. I don't have any regulations that I have to comply to. But some of you might say, you know what, I've got a regulation to comply to, and I have to make sure the data that is stored stays in an encrypted way. And whenever I retrieve it, I will always retrieve it over an encrypted channel. Example, you will retrieve it over HTTPS. So all of that is your responsibility. So in terms of encrypting your files, we do give you some options here. One is you can either encrypt it yourself using your own applications and upload it and store it in our storage facility. Or what you can do is you can tell our storage facility to encrypt it for you. Alright, so this is what we see. If you notice here, just below the word operating system, you will see a word that says client-side data encryption. That is what you do. You encrypt it and you store it. Then you have server-side encryption, which is what we do. We encrypt it and we store it for you. So there is also a little bit of a managed service there. If you don't want to do it yourself, you don't want to take out all that load, we'll do it for you. And in addition to that, you also have to think about the network aspect. As I gave you an example earlier, interaction over the network, is that happening over a secure tunnel? Is that happening over HTTPS? Is the application server, for example, is that talking to the database server over HTTP or HTTPS or is it SSL? All of that is up to you. So there is a certain level of responsibility that is to be handled by you. So it's not like, hey, AWS, I'm going to run my workload on AWS. I'm going to grab a cup of coffee or nice beer, go to the beach. Where's the nearest beach? Not sure. So you're going to go to the beach and relax and AWS takes care of everything. No, you still have a job to do here. That's the first part that you see at the top. So let me now focus on what we do a little bit more in detail. The physical security, as I mentioned earlier, we take care of it. All our data centers are set up in nondescript locations. What does that mean? We don't put a banner out there saying, hey, this is the AWS data center. Imagine what could happen. So we don't do that. Alright? It's nondescript locations. Even an employee like me who works for AWS full time, we don't have access to the data centers. We don't need to. My CTO does not have access to the data center. He doesn't need to. Right? So it's all need-based access. Role-based access is given. For example, if I go in and if I want to make some changes to, say, the hardware environment, everything has to go through a change management process. And if I am able to change the hard drive, doesn't mean that I can see what's inside the hard drive. Physical, logical. Separation of duties are in place. Now we do all of this not just because customers are asking for it, but also because we have to comply to various audits that happens regularly. And these audits are happening on your behalf, right? Because when we talk about compliance, it's always about first the physical, the data center compliance. Second is the application layer compliance. So we are taking care of the physical layer compliance for you here. Application layer compliance, who has to take care of it? You have to take care of it. Alright? So for example, if you're building a payment gateway on top of AWS, the data centers are all PCI compliant. But you got to make sure your application that you design, it is designed in a PCI compliant way. So other than hardware and software changes that has to happen, we also have various types of attacks coming to our data centers, right? It's a data center. You will have network traffic coming in. So we have perimeter level security. We have monitoring tools that is proactively looking for these attacks and blocking these attacks. We also provide APIs for all of our services. How many developers do I have in the room? Alright, good. Seems like more concentrated on that side. So let me face that area. Just kidding. So when we talk about developers, you would want to talk to these services directly. Not through the management console, but you want to directly talk to the API endpoint. So we provide secure API endpoints for all our services. That means you can talk to these services over an HTTPS channel. Alright? But it's a choice that you have to make. We don't enforce that. It's up to you. As an application developer, how do you interact with S3, for example? Do you do that over HTTPS? Or do you just do that over HTTP? It's your choice. Not only that, from a key management perspective, we provide all the keys that is required for a developer, for example. So if you're talking to the APIs, you have to first authenticate to the APIs. Just like if you want to access your emails, you got to log in first, right? With your laptop. Similarly here, when you want to talk to any of our services, you have to authenticate first. And the authentication at the API level uses something called secret keys and access keys. That is if you're using REST APIs. If you're using SOAP APIs, you have something called X5 and 9 certificates. All of that is given to you from the management console. And not only that, for administrators who are more concerned about things like security, like firewalls, we provide these firewalls as security groups. So you don't have to bring in your own firewall. What you can do is, when you spin a server, you can specify a security group policy saying, I will allow this server to receive traffic on port 80 from the internet. Or allow the server to receive traffic on 443 from the internet. So you get to configure all of those things. And that takes away the need to have a separate firewall. Traditional infrastructure, you have separate firewall layers. Here, security group takes care of that for you. So a quick recap of what we've talked about. One, we offer you SSL endpoints. The API endpoints are all SSL encrypted. You can talk to them over SSL. Then we have security groups, as I mentioned earlier. So let me show you an example of a security group here. So here's an example of a multi-tier architecture. If you look at the first one, all the way at the top, that's a web tier. The web tier is made up of many web servers. Then you have the application tier, which is made up of application servers. Then you have the database tier, which is made up of database servers. And what we're trying to do is, we're trying to create security groups which is relevant to those servers. So for example, if you look at the web server, it receives traffic on port 80 and 443 from the internet. That's all. The rest of the ports are all closed. Alright? Next layer, if you look at the application server, it will receive only traffic from the web server. But if you notice, there seems to be another small rectangle or a server in front of the application server. That's like your terminal server that you have today. You know, if you want to RDP from the outside world, what do? You RDP to one of your terminal server and then you RDP internally. Or if you SSH it, you SSH from the outside world to one of your servers, and from there you SSH in again to your internal servers. That is what we call, that server is what we call a jump server or a terminal server. Technically we call them a bastion host. So that bastion host can talk to the application server. And what you can do is you can remote into that bastion host from the outside world. You can't directly go to the application server from the outside world, but you have to kind of jump from the bastion into the app server. Provides multiple layers of defense. It's much more better this way. And if you look at the database tier, it seems to be receiving traffic from the application servers, also from our base tier host. And also, if you look at the DB sync, it says it is synchronizing to a database running on-prem. Now that's interesting. So let me repeat that. The database server is synchronizing with a database server running on-premise. Why would you do that? Can anyone think of a use case? I heard the voice, yes. Great. Great choice. Disaster recovery. What if something goes wrong with on-prem? At least you have your critical data here in AWS, which is inside the database server. All you have to do is spin up the relevant servers, point to the database. Or if you already have that up and running, we have a web and app server in an active mode, then you can quickly fail over. So from a DR standpoint, this would come in handy. People also do this from a backup standpoint. Let's just take backups and we store it there. When we need it, we'll recover from it. It's like an off-site backup. So security groups just play an important role. They act as firewalls. So just take note of that, please. Now, next is IAM, Identity and Access Management. This is another feature that we give you that would help you to improve security. What it allows you to do is, it allows you to create user accounts that will have access to the management console. So if you have an IT team made up of say 20 people, out of that 20, some of them will be DB folks, some of them will be networking folks, some of them will be server admin folks. So what you can do is in IAM, you can create groups. Server admins, developers, right? And then you can create users for these users or these admins. And you can give them access into the AWS management environment, AWS management console, so they can only access those services that is relevant to them. Example, if I'm a DBA, I can only access the database related services. If I'm a server administrator, I can access the EC2 service and launch servers and manage those servers. So from an access standpoint, right, this IAM tool will come in handy, and we'll cover more of this in the last module today. Because this is to do with management, right? It's about managing our infrastructure. So we'll cover this more in detail with demos in the last module. Another important construct that we have is called VPC. This is part of the networking module. We'll cover more in detail, but I want to talk about it from a security standpoint. So let's go back in time for a minute. All right? Going back in time. When AWS started, all of our services that we offer, especially when you look at EC2 for example, when you launch a server, they used to get launched in what we call a public cloud environment. Have you heard of that term before? Public cloud? So that means any server that you launch is internet facing. Now imagine launching a database server and that's internet facing. How comfortable are you? No way. So customers came to us and they said, you know what? We like your services, but can you give us something more secure? We don't want to launch a database server in the public cloud. So we released a feature called VPC, which stands for Virtual Private Cloud. So what you can do is you can build a virtual private cloud on AWS. And when you build this virtual private cloud, you can define what IP address range you want to use. It's almost like setting up your own LAN network inside the AWS environment. You tell us what IP address range that you want to use. You then divide that into multiple subnets, just like what you do on-prem. And then what you do is some of the subnets can be internet facing, some of them can be internal only. So you can launch your database service in the internal subnets. We call them private subnets. So all of that construct comes under VPC. So if you are about to get started with AWS, the first thing that you would do is you will build a VPC. Even before you launch your servers, you will build a VPC. And then you start launching your servers inside the VPC. Alright? And VPC is the way to go. The reason is, the public cloud that I was talking about is no longer available to anyone who signs up for a new account. So if you've never used AWS before, if you're going to go and sign up for a new AWS account, you will only have access to a VPC environment. Because we are making everything VPC by default now. We want to make sure that everything is secure, ground up. Alright? But for those of you who are already using the public cloud, you may want to start thinking about a strategy of moving all of those workloads inside a VPC. Alright? So that is something, that's a homework for you to take note of. So think about moving those workloads into a VPC. The reason is VPC gives you more control. We kind of give the controls back to you. We let you define your IP addresses. We let you define the rules in terms of which servers will reside in which kind of subnets. Public facing is like DMZ zones that we have today. And the private subnets are like internal subnets. So this is a strategy that you're going to start thinking about, because if you look years down the road, we're going to have purely VPCs. That's what we want to have. Alright? Now all of these data centers and all of these security aspects that we put in place, everything goes through various audits and checks. So what we've done is we've published these reports online on our webpage. You can access them. So AWS is SOC 1, SOC 2, SOC 3 compliant, and those reports are available online. It's PCI compliance, so you can find those reports as well. And also, we maintain various other compliance. Rick did talk about it. He showed you some of the logos as well. ISO 27001 compliance. And there are some other compliance that is relevant to government agencies. Like what you see here, FedRAMP, FISMA, DCAP, ATO. And all of these compliances, the reports, some of these reports are available online, but not all of them are available. If you don't find something that you need, come and talk to us. Alright? So what we do is we take all of these undifferentiated heavy lifting work in ensuring the data center remains compliant all the time, so that you can just focus on your application level compliance. Alright? So having said this, one of the biggest questions that people often ask at the start when they move into the cloud is, how secure is it? And that's what I've tried to highlight. What are the security mechanisms that we have put in place? Now let me just talk about for a minute, who is using AWS? Now this slide that I'm going to show you is not in your books. I just want to highlight this particular URL. You may want to take note of this URL, because this is where you will find case studies from where you can learn how various customers use AWS and how you can learn from those examples and leverage on those things. So once you've taken note of that link, I'm going to show you some examples of enterprises and folks who are using AWS. You might have seen some of this on Rick's slide, but I just want to highlight that again. Because these are folks who also ask the same question, how secure is AWS? So let me start with enterprises. So today, all of these are different enterprises who run on AWS. Take a moment to glance through the different logos. Some of them might be very familiar to you. I just want to pick some of the interesting ones here. I mean, all of them are interesting. But when we talk about security, let's talk about financial institutions for a minute. Banks, right? So how many of us think banks run on AWS? Some of you have already read the case studies. Take a look at this. For example, if you look at the fourth row, and if you look at that yellowish and whitish that you see here, let me just see if you can highlight that one. That's Commonwealth Bank of Australia, running various workloads on AWS. And we also have Suncorp. So we have various other financial institutions who run on AWS. Take a look at the first row, you see NASDAQ listed there. Right? So various financial institutions, oil and gas companies like Shell, pharmaceutical companies like Pfizer and the rest of them as you see here. So various companies, various enterprises, they all started with the same question. And they've gradually moved their workloads into AWS today. Many of them have the strategy of going full on. That means everything runs on AWS. Nothing runs on-prem anymore. Alright? So these are some examples, and you can see also some of the local examples here. Taking a step further, let me show you some public sectors, government agencies. You'll find all of their case studies on our webpage. Right? The link that I just shared with you. There are various government agencies that run on AWS. Take a look at the second line, the fifth one. Can you recognize what that is? The second line, the fifth one. That's Obama's election campaign. Obama's election campaign ran on AWS. And what they've done is they've made all of their architecture available to you on the web page. So please feel free to take a look at that and learn from those examples. Right? So we've got various other public sectors. You can see various educational institutions logos here. various government agencies here. You'll find all of them there on our webpage. SingPost is one of them in Singapore. There you see the logo. Startups. We're also very popular among startups, and you've seen some examples earlier. Here's some more examples. All the way from, the big ones like all the way Workday, LinkedIn, Pinterest, Instagram, Airbnb, Dropbox, Foursquare, Tumblr, all of this as you see. As you go to the third line, you also see gaming companies like Rovio, Angry Bird, Supercell, Clash of Clans, right? And we also have one that we missed in the previous slide, EA, Electronic Arts, right? So there are various startups, various enterprises who are actually leveraging on AWS. And the list is growing. Please take a look at that website that I shared with you earlier, where you'll find all the case studies. Alright? So you can learn from them. So it's time for me to now take you through a demonstration, a demo on the actual console, and how do we go about using that. So what I've done is I've taken a recorded version of that. I've made it like a zoomed version so they can see it from the back. So first thing is, how do I know what are the global infrastructure available? That's the homepage of AWS. And my search keyword here is AWS Global Infrastructure. And that returns a result, global infrastructure, as you see here. And I click on that. It takes me to that page, which shows me that world map. So if you want to know what is the latest list of regions or availability zones, take a look at this. This is where we document all of that for you. So you can see the list of regions in Asia Pacific. And we also list the number of availability zones, when was it launched. The edge locations is the content delivery edge locations. These are caching locations. Remember I gave you an example of caching in Brazil? So these are all the edge locations in Asia. Now if you want to see what other services are available in each region, feel free to click on that link that I just clicked. It will give you the list of all the services available in a specific region. So that's the global infrastructure. Now let me show you the management console. How do I access this global infrastructure? How do I launch a server? So when you click on the management console, it will ask you to sign up if you haven't done that. And then once you log in, this is what you see. This is the home page. This is the management console where you can see all of our services. Right? Now let me take you through the UI. So from the services view, you can also see that services are categorized in different categories. Right? And you can also see on the left side there's a history link that kind of gives you the link to the recently accessed service. And we also allow you to create some shortcuts at the top. So if you are a DBA, if you use a specific service all the time, just drag and drop. And that will create a shortcut for you. So again, ease of use, ease of access. I'm going to click on EC2. Let's say I'm a server admin. When I click on EC2, it takes me to the view which allows me to launch instances or launch servers. And I also get to choose where would I like to launch these servers, as you see on the top right corner. So if you want to launch in a US region, it's a click away. You don't have to take a 20-hour flight. Alright? It's a click away, and then that's all. And you can go back to Singapore immediately. That's how awesome it is. So you can go in and you can launch servers. We'll go through how to launch a server in another module, more in detail. I just want to show you the management console. There are also resources available if you want to just get started. Here's some links. That gives you also access to various guides. Alright, as you see on the left side, we also have documentations. We also have SDKs and tools. So keeping in mind that we also have developers leveraging on these AWS services, we've provided SDKs and tools for them. So if you look at that link, we've got SDKs available, and it's available across various different platforms, which you can leverage on. We provide you IDE toolkits, so you can deploy these SDKs in Visual Studio, or you can deploy it in Eclipse. And from those environments, you can start interacting with the APIs directly. I want to also show you a Trusted Advisor, a very, very important tool that proactively tells you how to save money. Who in this world does that? Alright. So cost optimizations, security optimizations, fault tolerance recommendations, performance recommendations. All of these are provided to you so that you don't have to go and find out what needs to change. They recommend, and you can take a look at those reports. Okay? So take a look at that link. We also make all our service health transparent. So if you click on that service health dashboard link, it tells you all of these services in this particular region is operating normally. We also give you history for the last 35 days. You can actually go in and see which of these services had some downtime or did it have any problems. Everything is transparent, everything is recorded here. Alright? So we want to make sure we are transparent in the services that we offer, and anything goes wrong, we capture it there. AWS Marketplace is a place where other software vendors will come and advertise their softwares that will run on AWS. So for example, if you're using a software from Cisco or F501, what you can do is you can come here and check whether they make it available to you here. So for example, if I search for firewall, you can see in that list, there's a list of firewalls available. F5 is listed here. And if you look at some of them, they have a different pricing model. Some of them will say, bring your own license key. But some will say, you can use it as you go, pay by the hour. You see that? Right? So we have a bring your own license model, and we have the utility style pricing model that you can leverage on as well. If you want to run SAP instances, there it is. SAP instances are made available to you here. You don't have to go through the process of setting it up and managing it and all of that stuff. Try it out. Big data, if you're doing big data processing. So they have different categories. I'm just trying to click through and show you some examples there. So this is the site, which is like Amazon.com for software vendors. Alright? So they come and advertise saying, our products can run on AWS, here's how we leverage on it. So AWS Marketplace, a very important link. It also gives you access to some demos and test drives. So if you click on that link, you notice we do have test drives developed by various consulting and technology partners, which is made available to you free of charge. So you can leverage on these resources also to try things out. These are called test drives, and you can see it's available across various software companies. Alright? So all of these are found in the marketplace link. So please take some time to look through some of these links that I'm showing you, so you know where these resources are. So all of this is found here. Now in terms of help, what if you need to ask some question? So there is access to forums, there's documentations. So here I'm trying to show you the documentations. We have documentation for each and every service. And the documentation is not just for the administrators, it's also for developers. So if you take a look at, for example, S3, you will find API reference guides also available. Now if you need access to forums, you can access the forums from here as well. As you see, there are forums where you can go and post your questions. And we have dedicated folks who answer those questions here. So that's your forum. But what if you want somebody to call you? Or you want to call somebody? That's also found under that. If you notice, there's a link called support. When you click on it, you can open a new case on the right side. Okay? And when you're opening a case, it will ask you, what type of case is it? Is it account related or is it some technical related issue? And based on that, you will have various options as you see there. So feel free to take a look at this, browse through it, right, so that you know what type of support plans are available. I'm going to show you some examples of support plans. So if you notice there, when you click on select a support plan, we do offer various support plans there. One is what we call the basic support. Then we have developer support, business support, and enterprise support. And you will find all of that information here with the relevant SLAs and the response time and who is handling the case. All of that is made available to you. So the trusted advisor tool that I shared with you earlier, that tells you how to save money, how to secure, is available for business support and enterprise support. So please take a look at this website to find more information about the different support plans that we have. So that was a quick walkthrough through the AWS Management Console. I just wanted to give you an overview of what is available. Now please take note, the Management Console is just one of the interfaces. You can also access all of these services from the APIs. You can also access all of these services from the CLIs, command line interfaces. So if you want to kind of batch job it, if you want to script it, the CLIs are available to you as well. So what we have covered in this module is the Management Console, how to access it. We've talked about the global infrastructure that is available to you and the security mechanisms that are put in place. So I hope this was a quick, good introduction on what AWS is offering here. Now it's time for us to dive deeper and talk about the various services. So what we'll do is we'll start with the very first service, which is the storage related service. So when it comes to AWS storages, there are different types of storages that we offer, and we hope to cover here the core service, which is S3 and EC, the EBS volumes, which is used by EC2 instances. So the key takeaway here is to first understand what are the different storage options. Second, what is EBS? When should I use EBS? Third, what is S3? When should I use S3? Apart from these two services, we also have various other storage services that I will touch on so that you know that these services exist for a reason and you know when to use them. So let me start with the very first one, S3. How many of us here use S3? Right. So I do see a lot of hands that hasn't gone up. So let me kind of spend a little bit more time here to explain what S3 is, how you can leverage on it. Right? A quick way to understand what S3 is by looking at the example of an application that you use today. How many of you use Dropbox today? More hands are going up. You know, Dropbox is a place you can store files, retrieve files. Am I right? Dropbox runs on top of S3. So S3 is a storage facility where you can store files and you can retrieve files. Now in the world of storages, let me talk about storages for a minute. In the world of storages, there are two different types of storage level access. One is what we call block level access. That means you can format the block, write a file system over it. Example, if you take a hard drive, that's a block level access. Are we clear with this? Everybody? So the hard drives that you use today, that you format, all of that is block level access. But there is also another type of access which is what we call file level. Have you heard of that before? Where you cannot format, but you can read and write. Can you think of an example? In your organizations, do you have something called a shared drive? Do you connect to shared drives? Do you connect to NFS? Can you format them? You can't. You can only read and write from them. So that is what we call file level access. S3 is a file level access. Are you with me on this? S3 is a file level access. So what is a block level access then? EBS, Elastic Block Store. That is block level access. So keep this in mind as we go through this discussion. Alright? So we're going to talk about file level access first, and then we'll talk about block level access. So S3 is file level access, and the good thing about S3 is it gives you unlimited capacity. There's no limits. So if you did look at some of the slides that were shown during the break, today we are handling more than trillions of objects inside S3. So it's an unlimited capacity. What does that help you to do? Stop worrying about scalability. So we give you unlimited capacity there. Second, what S3 does is, every object that you store in S3 can be accessed using a URL. That's why if you take, for example, in Dropbox, you can right click a file and you can say, I want to share a URL. So every object stored in S3 has a unique URL which is not public by nature. Keep that in mind. It's not public by nature, but you can make it public and share it with somebody. Okay? So every file has a URL, so you can distribute those files to your users. That's why we call this storage service an HTTP based access service, because this storage, when you interact with the storage, if you look at the API level, you can interact using HTTP gets and puts. What is an HTTP get? Download. What is an HTTP put? Upload. So when you're trying to upload a file in S3, it's doing an HTTP put. When you're trying to download it, it's doing an HTTP get. It's natively online, it's accessible over HTTP or HTTPS. It's up to you what you choose. Right? So S3 gives you unlimited capacity. It can be accessed securely over HTTPS. That's another important point to take note. It's highly scalable. It's highly reliable also. From a reliability standpoint, we give you an SLA for the service. And you can find the SLA statement on our webpage. Let me just highlight a couple of things from there. The availability. We give you 4 nines of availability. 99.99% of availability when you store files in S3. So that is taken care. You don't have to worry about availability now. Now another important thing is durability. If I store something in S3, when I retrieve it, it should come in the same size and file type and integrity. It shouldn't get corrupted. So for durability reasons, we ask you How would you like to store this file? How durably do you want to store this file? We give you two options. The default option is standard durability, which is 11 nines of durability. You can start counting 99.99999999999. So total number of nines is 9. Total number of nines in all 99 point all the other nines is 11 nines. Can you imagine? That's like if you have got 1,000,000 objects and you store it for 100,000 years, you may lose one. I won't live to see that. So durability is something that we give you as part of the service so that you don't have to worry about it. How do we do that? You may wonder. When you store something in S3, we copy that file to multiple availability zones. Remember the concept of multi-AZ? When I give you an example. Run your servers across multiple AZs to improve availability. Here, the storage service itself does it in the backend. When you store something in S3, it replicates it across multiple availability zones within a region. Example, Singapore is a region. Whenever you store something in Singapore, it gets replicated across the east and the west coast of Singapore, as an example. But it stays within Singapore. Because customers have come, they've told us, the privacy of data is important. Where exactly is it residing is important. So we store it within the region only. And we replicate it across multi-AZs, and that's why we are able to give you that durability. So one is 11 nines of durability, which is what we call the standard redundancy that we give you. But if you don't want 11 nines of durability, you may choose 4 nines of durability. It's less durable, right? So you may want to choose that, maybe because of cost reasons, or maybe because it's replicated content. So you just want to store it in a low durable way. So that is an option that is given to you as well. So now we know what S3 is. It's a file-based access storage. It gives you all that scalability, availability, and durability. Now let's talk about how things work in S3. In S3, you will have to first create something called an S3 bucket. This is what you start with. So the S3 bucket, inside which is where you will store your files. We call them objects in general terms. So object is comprised of your files. So inside the bucket, if you want, you can create folders so that you can categorize the files properly. So all of these are important concepts to take note. There are some limits that you have to take note also. How many buckets can you create? It's listed here, 100. Now, this limit, people usually run out very quickly if they don't use it the right way. If you're going to start using buckets for every single project that you have, eventually you'll run it out. So what you want to do is you want to create folders inside the bucket and use those folders, because there is no limit in number of folders that you can create. There is no limit in number of files that you can create inside these buckets. Alright? So all of these are aspects that you want to take note of as you start using this service. What you can also do is you can control access, saying that this folder can be only accessed by project A team members. This folder will be only accessed by the marketing team. So you can set permissions, give relevant access to people so they can access their own files. So it kind of resembles a shared drive concept that you have today, right? So that's what people are doing. They are moving away from physical file servers. They are building applications like Dropbox for their internal users, which allows them to interact with S3 in the backend, but it appears like a drive in their machine. Okay? So these are certain things that you want to think about and start exploring, because one, it gives you unlimited capacity. You don't have to think about quotas. No. Those days when you have shared drives, you get only 100 MB. Good old days. Now you get gigs, I think, in new infrastructure. But here, unlimited capacity. But with unlimited capacity comes an important responsibility of making sure you housekeep it properly. So we'll talk about how to housekeep it in the last module today, in the deployment module. What are the services that you can leverage on? I did mention about Trusted Advisor. Trusted Advisor is another tool that also helps you to housekeep. in terms of, oh, these servers are not being utilized at all, let's throw them away. These storages, you've created it, but you've never used it at all. What do you want to do with it? So those recommendations come from Trusted Advisor. Now every file that you store or every object that you store has a unique URL. That's what I mentioned earlier. The URL comprises of the bucket name as the domain name. And then if you have a folder created, that will become part of that URL also. So if you look at this particular URL, the actual file is puppy.jpg. But it is stored in a folder called photos. And it is stored in a bucket called John Smith. Now you know in the world of internet, you cannot have two abc.coms, am I right? It can be only one abc.com. So here, can you have two John Smith, two buckets with the same name? You cannot. So that's another important thing to remember. When you're creating a bucket, you have to make sure the name is globally unique. Because the name of the bucket is used as part of the URL. Right? Now another important thing to notice, when you're interacting with S3, it allows you to create folders, it allows you to create multiple folders, subfolders. But technically speaking, all of these are prefixes inside S3. It resembles an actual storage, like a shared drive, but these are prefixes. So when you access the object, puppy.jpg, you've got to make sure you specify the prefixes also. Inside which folder. I'm saying which folder, but it's prefixes. Alright? So that's how the namespace works. So in terms of uploading and downloading from a price standpoint, we'll talk about it in the coming slides, but I just want to highlight anything that you store here, you can control who has access to it. Alright? Now you can also enable access logs on S3, saying that I want to see how many of them downloaded this file, puppy.jpg. Where did the download request come from? So you can capture access logs and later look through those so that you can make much more better business decisions. Now when you talk about these objects, a couple of things to note. There are some limits also in terms of the object size. Unlimited objects can be stored, but one object, one file can be of a certain size. Can anyone guess how big a file can be in S3? It's 5 terabytes. It's 5 terabytes. Would you do a single upload of a 5 terabyte? You wouldn't, right? Obviously. So what we do is, as part of the APIs in S3, we also give you an API called the multi-part upload API, which you can leverage on. What it basically does is, it breaks that big file into chunks on the client side, uploads them parallelly, and reassembles them. So upload is much more quicker that way. Okay? So take note of that important aspect of an object. S3 object, there is a maximum file size limit, which is 5 terabyte. But when you're uploading this file, you can also add some metadata to this file. Default metadata is what file type it is. If it is a JPEG file, it will detect that as an image. It's a JPEG image. But in addition to that, you can have additional metadata. Like for example, this picture was taken on this event. Alright? You can have additional metadata and S3 can capture and store that for you. Why would you do that? Because later you may want to search across those images based on those metadata. So all of that is made available to you, so you can create custom metadata as well. And all of these is part of the upload request. As part of the HTTP put, you can add these metadata alongside that object. Now S3 is also a great place to store backups. We've got many customers, what they do is they back up their on-premise environment and they store it in S3. So today there are many backup softwares that come with connectors to S3. If you take Oracle RMAN, you can take Oracle backups and dump it into S3. If you take Commvault, Sympana servers, they've got connectors to S3. So there are various vendors who are offering these connectors. Take a look at your existing vendors, talk to them about it. What people do is they take backups and they store it in S3. Not only that, people also store those files that needs to be stored for X number of years. We call them records, right? Records usually have to be stored. So if you take a look at contracts, invoices, financial data, healthcare data, and all of this, log files, for example, you have to store them for X number of years before you discard them. So S3 gives you the capability of storing them for X number of years and discarding them for you. Alright? So if you don't want to store it in S3 all the time, you can also leverage on another service, which I'm going to talk about in a minute, called Glacier, which is our archival storage service. So S3, what happens is whatever you store, you can retrieve it whenever you want to. And there's a price that you pay for that. Am I right? But if you don't access that file anymore, example backups or archives and stuff like that, what you can do is you can create a life cycle policy that says these files that are in S3, move it to Glacier after 30 days or after 180 days. And after 7 years, throw them away, discard them. So you've got all of these policies available. You don't have to be there to do all of this, just need to set it up once and forget about it. So if you take a look at log files, application logs, they have a different time frame to keep. Then we have system related log files, that has a different retention period. So what you can do is you can automate some of these things with the help of these lifecycle policies. Now from a price standpoint, you may be wondering, how much does it cost to use S3? So when it comes to S3, there are certain price points to it. So let me take you to an important tool, which is called the Simple Monthly Calculator, which will allow you to calculate all of these price points. Now this calculator is publicly available. You can always use this. The search keyword will be Simple Monthly Calculator. I'm going to zoom in a little bit here. And I'm going to go to S3. The services are listed on the left side. So when I go to S3, I get to choose the Singapore region. If it's another region, you can choose from that list. And this is where you get to specify how much capacity will you use in S3. Say, for example, if you've got 100 gig stored in S3. Now this is not just 100 gig. It's actually 100 gig stored with 11 nines of durability. Okay? Now if you don't need 11 nines of durability, we have another one called reduced redundancy, which you can leverage on, which is the 4 nines of durability that I mentioned earlier. So for 100 gigs stored in S3, monthly basis, this will be your bill, as you see here. Estimate of your monthly bill is $2.85. Alright? Now it's important to also note, we are not done yet with this calculation. You've stored files in S3, then comes the aspect of retrieving files or uploading files, am I right? So there are certain requests that you make, upload requests or retrieval requests. These requests needs to be processed, and there is a price point to that. So let me give you an example. Put request, what's a put request? Upload request. List request is show me all the files that I have, listing. So let's say you've got 1 million hits that comes in. Got a very popular site set up, all of the content is being served from S3, alright? And all 1 million hits is going to S3. And let's say 1 million gets are also happening. Downloads are also happening here. How much difference does that make to your price here? So you can see here, the put list request is $5. The other request is 40 cents. That's totaling up to $8.23 for the hits. Now these are requests that were processed by the S3 service. So what happens is when somebody says, I want to download a file, that's a request, processed. Now the file has to be transferred out, am I right? So there is a bandwidth cost to it. And that's what you see the next one. Now when it comes to the bandwidth cost, it really depends on the destination. Where is it going? Is the file requested from a user who is sitting in the internet? Like for example, when you use Dropbox, you are requesting directly out. Alright? So that is what we call data transfer out. That you expect to go out from S3 into the internet. Alright? Let's say for example, out of 100 gig, 10 gig goes out every month. Scroll up, you can see data transfer out. It says you're paying $1.71 for that bandwidth that you're using. 100 gig of data comes in. Incoming does not make a difference to your bill because data in is always 0. So please remember this, incoming is always free. Okay? When you're serving it, then you look at the data transfer out if you're serving it directly to a person who's accessing this content from the internet. Now there is a possibility where you may optimize it further, where you will not transfer it directly to the user from S3, but you may leverage on our content caching network. Remember we talked about the user of Brazil, bringing the content closer to the users, to caching it in Brazil. That is done using a service called CloudFront. CloudFront is our CDN service, Content Delivery Network service. What it helps you to do is, it helps you to take your content from the origin. What is the origin here? The S3 bucket. That's where all the content is stored. So it helps you to take it from that content, from the origin, and have that cached in the edge locations. Now that means there is a data transfer happening, right? From S3 to the cache location. Now that pricing is what you will calculate here. So that means you're no longer transferring out directly to the internet, but you're transferring all of that to CloudFront. And you can notice, right? Here it tells you the data transfer out is 90 cents now. Okay? You still have to do the calculation of going to CloudFront, and then you have to think about from the edge location serving it to the user. Technically speaking, when you do the math, you will see yourself, when you have a global customer base, you will see that it makes more sense to use the CDN service to distribute your content. Alright? It saves you money. It also gives your user a better user experience. And there's a lot more optimizations that we do. You may be wondering, oh, so CDN service, is it only for static contents? The answer is no, because the CloudFront service also supports dynamic contents. Now you know dynamic contents, basically contents that has a time to live of 0 cannot be cached, am I right? But what we can do for you is we can proxy those dynamic content requests through the CloudFront service, through the CloudFront network, which is much more optimized. And you can do some TCP optimizations there. You can do some keep alive connection optimizations there to reduce the number of handshakes that has to happen. And that will reduce the round trip time, even for dynamic contents. Okay? So there is a lot of things that you can do here. I just wanted to highlight that you can leverage on CloudFront, not just serve it from S3 all the time. And there it does make a price difference there. So coming back to our slides, we've talked about pricing. A quick overview on what are the things that we have talked about so far. So we've talked about in S3 you can store unlimited objects. Per object size is limited to 5 terabyte maximum. Alright? There's no size limits in terms of how many files you can store. And we talked about the durability that we give you and the availability that we give you. And I did mention you can interact with S3 over HTTPS. So please do leverage on that. And it's highly scalable infrastructure, so you don't have to worry about storage. Alright? S3 also offers encryption capabilities. So what you can do is you can say, hey S3, when you store these files, encrypt it and store it for me. That's what we call server-side encryption. If you do recall, we talked about it earlier this morning. Server-side encryption is a feature that it supports. Logging is a feature that it supports. Lifecycle policy is another feature that it supports. Right? And there are a couple other features that I will share with you when I show you the demo. Alright? Versioning is another feature that it supports. You can enable versioning on S3. So you can have multiple versions of your files. And for developers, you have the REST API and the SOAP API interface available. You can leverage on those things. So I did mention earlier that files that you store in S3, you may not want to keep it there forever because you don't access it. If you don't access it, put it in Glacier. So the next service that I want to talk about is Glacier. This is an extremely low cost. You're paying like 1 cent per gig per month. It's an extremely low cost archival solution with 11 nights of durability. Can you imagine that? So backups, files that you need to keep for X number of years, the most important aspect is durability. So you're going to store it and retrieve it. So storing it, it stores it in a durable way. And these are optimized for data that is infrequently accessed. What does that mean? Archives, you don't access it every day. Backups, from say backups that you've taken, you may keep it in a hot storage for say 30 days or 15 days. and from there you will then move it into tapes and you ship it to an offsite location. Now this Glacier can be that offsite archival storage for you. So it will offload many of your burdens. So it is kind of automated, right? You can back up, store it in S3 inside a specific folder, and you can say, I would like to move the content in this folder into Glacier after 15 days or after 30 days. So it's all automated here. Now a couple of things to highlight here, as I did mention, it is a place where you store files that you don't access that often. But what if you need to access a file suddenly? You have to place a request. Everything is done online. You will place a retrieval request, and that request will get processed, and in 3 to 5 hours, that data will be made available to you in S3. Okay? So it's a cold storage. Now in the world of storages, you can classify storages as hot storages, warm storages, and cold storages. This is like a cold storage. If you need something from that, you have to place a retrieval request, wait for 3 to 5 hours. So please take note, Glacier does not replace S3. S3 is a storage which is hot in nature, you can retrieve it whenever you want, no problem, you don't have to wait. Okay? So this is primarily designed for archival purpose. And what it also does is it automatically encrypts everything using AES 256-bit for all these archives that you store in Glacier. So if you've never explored this before, I would highly encourage you to take a look at it. Moving on, another important storage service, which I did highlight earlier, is elastic block storage. So we talked about S3 as a file-level access. EBS, in short, as we call this, is the block level access. That means what you can do is you can format this volume into whatever file system that you want. And that volume will be attached to your servers, to your EC2 instances, which we will talk about later. Alright? And these volumes will appear as your C drives and your D drives eventually. Now C drives, you don't need to worry about it because it comes with it. Typically you would use this to create additional volumes. The D, E, F, or the other volumes that you want. So let me take a step back and let me talk about EBS. So first, it's a block store. And it's persistent in nature. That means if I store something inside this volume, if I shut down the server and if I bring it up, everything stays intact. Nothing is lost. Okay? So there is a level of persistency that is given to you. Not only that, if you look at EBS volume, it has a life cycle also. So first thing is what you would do is you will say, I want to create a volume. Maybe a server requires a volume. So you will specify, I want a volume, and take note of the maximum capacity there. 1 TB. That's what we're looking at. Maximum is 1 TB. And then what you would do is you would attach this volume to an existing server that is running, or you can, during the launch of the server, you can create these volumes also. Okay? So you have the capability of attaching it to a live running machine. Not just attaching, the opposite, detaching is also possible. But be mindful when you do this in a production environment. You don't want to just attach and detach. It is possible, but at the application level, you want to make sure that it's consistency there. So what you can also do is you can take snapshots. So whatever you store inside this volume, if you want to take a backup of that, you can create a snapshot from it. So these snapshots is a form of a backup, am I right? Where do all the backups get stored in AWS environment? S3. So I told you, it gives you unlimited capacity. That's a popular place to store even backups. Alright? So even the snapshots that you take, they go to S3 automatically. So it's a persistent storage, but there is always a requirement that people come to us with. They say 1 terabyte is not enough. What if you need to create a volume that's like 5 TB? What you can do is you can attach multiple volumes, 1 TB each, say 5 of them. And then you can log into that server, and from the operating system layer, you can strike. So you just need to do rating at the OS layer here. But it's your responsibility, because only you can log into that operating system. So you can create a stripe that will give you more capacity now. So 5 volumes will appear as 1 volume, total of 5 terabyte of space. So striping is something that a lot of our customers also leverage on when they need more capacity in one single volume. So all these volumes, they behave like hard drives. So you can format them, assign a drive delta. So all of that is still your responsibility because all of this happens on the OS layer. Now also to take note, these volumes are often used for the operating system volume, the C drive for example. Today when you launch a server, you don't have to install the operating system because we pre-install it for you. And when we pre-install it on an EBS volume. Okay? So you can launch the server, it will come with the C drive. In addition to that, if you want a D and an E or other volumes, you can always leverage on this to create those volumes. Now let's take for a moment, if you want to create a volume and that volume will be used by a database, do you need certain amount of performance? Performance is an important question, right? When we talk about storage, whenever you go to your storage folks, when you ask for a LUN, for example, you will say, I want with a certain amount of performance. So here what we do is, when you're creating this volume, we ask you this question, how much IOPS do you need? I/O per second do you need on that volume that you're creating? So you get to choose whether you want to create a standard volume with predefined IOPS, which is 100, best effort 100 IOPS, which is good enough for operating system volumes, unless you don't have any other applications installed on it. But in addition to that, what you can do is you can say, I'm going to create a D drive, for example, which will be used by my database. So I want this volume to have, say, 4,000 IOPS. So the application will be able to write to the volume 4,000, read and write. It's I/O, right? So 4,000 IOPS is the maximum per volume. What if you have a database that says, I want 8,000 IOPS? Or an application that says, I want 8,000 IOPS? Same, the striping concept comes in again. So, create two volumes, each with 4,000 IOPS. And the OS layer stripe it. And you get to enjoy 8,000 IOPS now. So all of this sounds nice. But it comes to the responsibility of knowing whether are you fully utilizing those IOPS or not. What exactly does the application need today? And how much are you catering in for the future? So this is an important discussion that you need to have with the application team to understand how much IOPS is the application required. The reason why I'm highlighting that, the reason is, when you create a volume, say with 4,000 IOPS, let me scale it down. Let's say you create it with 3,000 IOPS, and then there is a need for 4,000 IOPS. You can't change the IOPS value on the fly, because it requires hardware changes in the backend. So what you will have to do is you will have to take a snapshot of that volume, that will capture all of the data inside that volume. And from that snapshot, you can create a new volume with this new IOPS value, attach it to the server, detach the old volume away. So it's a merry-go-round process, right? It's a long-winded process. So that's why you need to kind of predict this earlier. But if worst case scenario, you may have to do it during a maintenance period. Okay? Same thing applies for capacity. If you created a volume with 500 gig and you want to scale up to 1 terabyte, same concept. Snapshot, create new volume from that, specify the new capacity, attach, detach. Okay? So please be aware of that part. Now from a pricing standpoint, you can always estimate how much it would cost using the simple monthly calculator. So please take a look at the simple monthly calculator for more details on how you calculate the prices. Alright? Now from an availability standpoint, what we do is we replicate the content or the EBS volume across multiple servers within the same AZ. So it's sort of a mirroring concept that is set up in the backend, but it is still happening within the same AZ. So what you want to do is, you want to still take snapshots. Because when you take snapshots, where do these snapshots get stored again? S3. And when it is stored in S3, does it just use single AZ or multi-AZ? Multi-AZ. So your backups are always available to you, even if one AZ goes down. Okay? So this is something that we do in the backend, but in addition to this, please take snapshots. So let's now compare EBS and S3. So one is a file system oriented, block level access, you can write a file system. The other one is a file level access, we call it on object store, which is S3. From a performance standpoint, EBS can be very fast. The reason is you get to specify how much IOPS you want. And you can have multiple EBS volumes with multiple IOPS, and you can stripe across and you can get a lot of IOPS if you require. But whereas when it comes to S3, it depends on the bandwidth that you have when you connect to the S3 storage facility. Now S3 is not limited. S3 does not throttle incoming bandwidths because we can take all the hits in the world. So it all boils down to what is your bandwidth when you talk to S3. It can be fast, it can be very fast, it all depends on that connectivity part. From a redundancy standpoint, I've already highlighted, EBS volumes are replicated within the same AZ. But whereas in S3, they are replicated across multiple availability zones. So please take a look at that carefully. Take snapshots to improve the redundancy of EBS volumes. Now from a security standpoint, EBS volumes that you create can only be accessed by an EC2 instance. That's how the APIs are designed. The content that is stored inside the EBS volume can be only accessed from the OS layer. That means it has to be mounted to a server. And not only that, it's also important to note, one EBS volume can be attached to only one server at a time. So if you think along those lines, and if you start looking at some of your workloads that you have today, like workloads that use clustering, right? If you take database clustering, there is a concept called quorum disk, right? That has to be a shared volume across multiple servers. So how do we achieve that here? EBS volume can be only attached to one server at a time. This is where you get a little innovative and you start using things like NFS on top of EBS, which allows you to expose this EBS volume as a shared volume, which can be then mounted across multiple nodes. Alright? But EBS by nature is attached to only one server at a time, one volume to one server. So in terms of S3, I've already highlighted that how to access from S3. It's all based on URLs. But whenever you're accessing that URL, you have to authenticate. And the authentication is using various keys, access keys and secret keys, or you may be using certificates, X59 certificates. So S3 you can access from the internet, but EBS you cannot access from the internet. It can be only accessed by the server. But if that server is an FTP server, obviously you can access from the internet. Okay? That's an exception. So you know now the use case. So a quick question here. What among these storages, which one would you use for your servers? EBS. Alright? So please remember that it's a block store. That's what you would mount to your servers, format it, and you would use it. Now, in addition to all of these services, we also have a couple of other value-added services that you can leverage on. Example, storage gateway. So let me kind of tell you a story here. How did we get started with this? Customers came to us and they told us, you know what, we are running out of capacity on our on-premise infrastructure. Storage capacity runs out very quickly because of the data explosion that we have. Second is backups. We're running out of space to store backups. So can you provide us an intermediary tool that allows us to use S3, right, for our on-premise infrastructures? So if you look at Storage Gateway, it is a VM, it's a virtual machine that we have built. It's a pre-configured virtual machine. You will download this and you will run this in your Hyper-V or in your VMware environments. Are you with me on this? So you will run this, it will run as a virtual machine. Okay? And this virtual machine that you see here in the middle, which is called the Gateway VM, it runs on top of a hypervisor. The example that I gave you, hypervisor would be Hyper-V or vSphere. And what you would do is you will connect to your local storages. Local in terms of it could be a SAN, it could be a dash, network attached. You will mount those storages as virtual disks for this server. And then what you would do is you would share that volume with other servers that is running on-prem, like a shared drive. So when you share it, all these servers, the application servers that's running on-prem, can leverage on this storage. And this is what's going to happen in the backend. It's very transparent to users. They don't know what's happening. They just store files in that storage, which is used by that gateway VM. But what really happens is all of that content goes into S3 in the backend. So you are kind of given unlimited capacity because S3 does give you that. So this particular storage gateway can operate in two different modes. Now I'm going to kind of explain this a little, but I want you to go and explore this further. One mode is what we call the cached mode, where all the files that are stored inside the volumes here of the gateway VM, they are not stored there forever. They all go to S3. But the recently accessed files are cached in the storage gateway VM. That means recently accessed files can be accessed quickly. The files that is not accessed that frequently, they go to S3. So that's one way of setting it up. There is another way of setting it up, which is everything is stored locally in that volume which is used by that storage gateway VM. That means you need a big volume. Okay? But what we do in the backend is we take a snapshot of that volume and we store the snapshot in S3. It's a form of backing up those volumes. In case something goes wrong with your on-premise environment, at least you have the snapshots in S3. And from the snapshots you can create a new volume, attach it to a server that you will launch on AWS environment and give users access to that data. So Storage Gateway acts as an intermediary tool that allows you to leverage on cloud-based storages from within your on-premise environment. This is what we call cloud bursting, a type of cloud bursting, but from a storage standpoint. Okay? So take a look at this. There is one other important way of setting it up. Storage Gateway also can act as your virtual tape library. So your backup softwares or backup applications can talk to the Storage Gateway VM and can store virtual tapes, and eventually they will be stored in S3. And tapes, do we access them that frequently? No. So should it be stored in S3 all the time? No, where should it go then? Glacier, exactly. So you can see here, you can archive it to Glacier using a lifecycle policy. And you can retrieve it whenever you want. So it kind of changes the way we do backups today. Okay? So please explore these services. These are value-added services. I want you to take a look at these services and explore further. Now one of the services that I want to talk about is the import-export service. The import-export service allows you to import data quickly into S3. So if you have petabytes of data stored in your storage facility today, and you want to bring all of that data into S3, you can either do that over the internet, or you can send us those hard drives using this service. And you can tell us where should we paste or copy and paste all of this data. So what we can do is we can import it into S3 directly, or we can import it into EBS volumes, or we can import directly into Glacier. Alright? Or we can export it out for you as well. So it's an import-export service. So this is one of the services that you may want to take a look at if you have a large amount of data that you want to store into S3. It's important to understand this because when you move some of the applications to AWS, these applications might be leveraging on some data sets. And these data sets are required on AWS now. So how do I move it quickly? These services would help you there. So it's time for me to take you through a quick demo on some of the core services, which is S3 and EBS. So I've clicked on S3 here. First thing that you create in S3 is an S3 bucket. So if you look at this, when you click on create bucket, it gives you a UI where you can create a bucket name. This has to be globally unique, as I've explained earlier. And you also get to choose in which region will this bucket be created. Where will you store all the files? In Singapore or another location? Okay. So please choose according to your need. And as you see on the left side, the bucket is created. On the right side, it's trying to load the properties of the bucket. So you can see a lot of properties here. We'll go through them as we go along. But before that, I want to show you how to upload a file into the S3 bucket. So you can see there is an option to upload. And you can add a file. So that's what I'm going to do. I'm going to just pick one of the files. It's a PDF file. So the metadata PDF should be captured automatically. Before that, when you upload, you can choose reduce redundancy or store it in an encrypted way. We talked about these things. Permissions can also be set. Do you want to make it publicly available or not? So these are some settings that is available to you. And when you hit start upload, the file gets uploaded into that bucket now. And you can see on the right side, it gives you a confirmation. Now, if you select that file and you go to the properties tab of that particular file, you may notice a URL there. Remember I mentioned earlier, every file has a URL. But if you try clicking on that URL, it won't work because it's a private URL. It's a non-shareable URL right now. But if you want to share it, you can just right-click the file. You can say, for example, make public. Once that is done, if you go back to the properties, and if you click on that URL, you can see at the bottom it adds everyone by default. If you click on the URL, the file is available now using that URL. That's what my early days. I was trying to learn Mac shortcuts. So you can see here the permission gets automatically updated when you just right click and make public. The other options that I talked about, encryption. Here's an example of how I just click an option and I say encrypt it for me. You could have done this while uploading, but you can also do it now. Now at the bucket level, there are various other properties. It has its own permission tab, but it also has something called a bucket policy. You can write a JSON-based policy document, and you can add that in this bucket policy as I'm doing it here. And you can create different types of very granular policy. You can say that I want people to only upload files, not download. So it can be very granular. So bucket policies would help you to do that. You can also host static websites in S3. You don't have to run a server to run a website. You can just host it here. That will save money, because here you only pay for the capacity. You can enable logging, right? Access logs. We talked about lifecycle policies. Here's an example of the lifecycle policy. You can move into Glacier after X number of days, or you can delete it or expire it after X number of days. So all these are lifecycle policies, UIs. All of these are available at the bucket level. You can also enable versioning. Alright? So there is multiple versions of the same file, so that you can go back to the previous version. So all of these are different features that is offered to you by S3. And you can see these are some properties. Now, not all of this stuff is exposed in the console. There are some things that can be only done from the API layer. So please take note of that. Okay? Example, multi-part upload that I talked about can be done from the API layer. The APIs are made available to you. If you want to create a URL that expires automatically after X number of hours, that can be done from the API level. Alright? Let me show you some resources here that would help you to do that. So if you go to the SDK section, we offer you SDK. So if you take the .NET SDK or the Java SDK, for example, or even the Python, what you can do is you can create these different pre-signed URLs using those SDKs also. We have documentations for all of this, so don't be lost. If you need help, just click on the relevant documentation. There's a developer guide. There is also an API reference guide available for you with examples. Okay? So it's very well documented here. Apart from this, let's just move on and let's now talk about the other storage service that we talked about, which was EBS volumes. So EBS is found under EC2 because it's a storage used by the EC2 instance. So you notice on the left side, you can see there is an option called Elastic Block Store. I've clicked on volumes and it allows me to create a new volume. It will give you a button that allows you to create a new volume. So what are the things that you have to take note when you're creating a new volume? Capacity, performance. So do you notice here, volume type? Do you want this to be a standard volume which gives you about 100 IOPS? Or do you want this to be a provisioned IOPS type volume where you can specify how much IOPS you want? So this is the most important aspect of EBS volumes. And then you also get to specify in which availability zone should it be created, and do you want to use an existing snapshot. Maybe you don't want this volume to be an empty volume, you want to restore some data back into that volume. So you can choose those volumes. You can also create snapshots from this volume, as you can see. Right click, give it a name, and where do snapshots get stored? S3. But you don't have to go to S3 to see the snapshots. You can view it right from here. Let me just show you that UI. I've clicked on create a snapshot, and on the left side there's a link called snapshots, and you can see it there. You can also create a new volume from that snapshot. As you see, there is a button up there. You can also kind of create not just a new volume, you can copy this snapshot to another region and create a volume from there. Example, as you see here, I'm trying to copy it to Tokyo. All of these volumes exist in Singapore, but I can copy to Tokyo and spin up a new volume from that and then attach it to a server running in Tokyo. That's how easy it is to, restore, in a way, to restore data into a server running in Tokyo. Okay? So all of these are important aspects of this service, EBS and S3. These are the two important services that we talked about. And in addition, we talked about various other value-added services. That is Glacier, primarily for archival purposes. We talked about import-export service that helps you to move data quickly into S3 that you can leverage on. And we talked about storage gateway service, which allows you to leverage on cloud-based storages right from your on-premise environment. Right? So that's all that we have in this particular module. We've talked about all of these different storage options. Please use the right storage for the right reason. Don't mix it up. Each of them are unique in the way they work. They are unique in the way you interact with them and interface with them. And there is also a price difference across all of these services. Right? So that's all I have from my end. So we're going to pause here for a lunch break. So I want you to take a moment. Make sure that your books, first of all, write your names. Right? If you haven't done that yet. And we will be taking a lunch break.
Okay guys, welcome back.
Yeah.
Fantastic to hear from our friends at AirAsiaGo and Expedia. So, what do you think of this training format? Good? Like it?
Yeah.
Yeah? Learning lots? What's been the biggest, we call these internally aha moments, where you see something and it just clicks and you go, aha, I know what that is. What's been the biggest aha moment so far? Pricing?
Very cheap.
Yeah?
Yeah.
What else? Flexibility, scalability, starting to think about some ways that you can apply AWS within your respective organisation. Fantastic, that's what we want to hear. Now, what we tend to find is after lunch, everyone's probably had a little bit too much to eat. Feels a little bit sleepy. Time for a nap. Who's feeling like that? Who's feeling a little bit lethargic? And Denny gets really upset if people fall asleep within his classes. He takes it personally. So what I need everybody to do before I invite Denny back up on the stage is stand up. If you don't stand up, I'm just going to keep picking on you until you do. Come on, everyone stand up. And we need to do some stretching. So, arms up in the air, to the left, to the right. Feeling good? We've actually got some music to help get warmed up. So if you could just cue the music, hopefully everyone knows this. It's called, does everyone know? The YMCA? YMCA. YMCA. Alright, I think that's enough. Alright, everyone feeling better? Ready to rock and roll? Now, before you sit down, you've got to stand back up. There's one other thing that I've got to do. And that's get a photo. Because you guys all look so good. I want a photo so I can remember this moment. Now I'm going to try this new pan feature. So we need hands up in the air. Like you just don't care. I won't sing that song. And I'm going to go and scan. Hope everyone's smiling. All the way around the room, and we'll even get Danny. Alright, so we're going to put that up on Twitter if you want a copy of the photo. Thank you very much. Hope everyone's energized and ready to go. Please welcome back to the stage Mr. Danny Daniel. Actually, did you do the YMCA? I didn't see you.
I don't need one because I'm kind of doing the YMCA throughout the day.
But I saw you have a big lunch.
It was just a small sandwich. Right?
No, it looked like a big sandwich to me. Should we let him off or should we make him do the YMCA? Okay, we're going to have to cue the music. Are we ready to go again? And I'll just hold this for Danny. Please. Now, Danny, we spoke about enthusiasm and commitment. Right. That didn't look like enthusiasm or commitment as far as I was concerned. What do you reckon? Was that enthusiastic? No. No? Should we make him do it again? Yeah. All right. Now, Danny, just over here so everyone can see. And I suggest you do a good job this time because we don't want to have to try for a third time, okay? Do it with me, mate. All right, we'll go again. No cameras. I can see a few cameras. All right, let's try one more time. You ready? Jingle. All right, that's good enough. You good?
Yeah, I'm good.
All right.
I'm good.
Thanks, guys.
Thanks, everybody. Thanks for being such support. Just a couple of things here. This morning I was talking about feedback forms, so if you haven't received it yet, I'm going to leave some here on the stage. So maybe during the break, just come and pick one up. All right? Cool. Where were we? YMCA. Right, we're going to jump into the next module, which is computer networking, and then we'll also talk about databases. That's what we have in store for this afternoon. And after that, we will go for a short break, and then we'll come back and then we'll do the last module, which is deployment and management. All right? Now, this is the most important piece of AWS. How do you launch a server? So in this module, we'll talk about how to launch servers using compute services. We'll also talk about what are the different networking features that you want to leverage on as you build this architecture or as you bring your workloads into AWS, right? So some of you might have used this before, but I also want to highlight the EBS volumes that we talked about earlier. This is used by EC2 instances. So EC2 instances is what we're going to focus a lot on, and then I will also touch on a couple of other services that falls under the compute category, which also uses EC2 instances in the backend, all right? So EC2 in short refers to Elastic Compute Cloud. In short, we abbreviate it as EC2. So when we use EC2 service, you will see yourself launching an instance. So when we talk about servers, we call them instances. These are virtual servers that are launched. And when you launch them, you can launch them in a certain size, but you can change them later. Alright? It's just like when you buy servers with certain specs. But then 6 months down the road or a year down the road, you want to upgrade that hardware. Here you don't have to go through the physical hardware because it's all abstracted. What you're dealing with is virtual resources. So you just have to change the type of the instance. I'll walk you through the different types of instance in a minute. The most important aspect that our customers told us was the time it takes to provision servers has drastically gone down. So typically it takes about a month or a few weeks to provision servers, but here you're able to do that in minutes. And you're able to change it if you want to. You have that flexibility of doing that because it's all virtual in nature in the backend. So there are different instant types that we offer. These are different specs. Think of it like different servers with different specs that you can choose from. But you can always change that. Just take note of that, please. In addition to that, what you can do is you can turn on the server, pay for them on an hourly basis, turn off the server, stop paying for them. Alright? So you have that flexibility of using them when you need them, when you don't need them, you can turn it off. But having said that, it's easy to say, but not a great practice that is practiced out there. Test dev environments. That's one of the biggest bills that a CIO team receives. Right? Test dev environments. Servers are running, they're not effectively used, they're not productive at all. They are used for certain test and dev environments, but then the servers are always running all the time. So how do you go about ensuring that you do a bit of housekeeping there? So those are some strategies that we talked about this morning. Trusted Advisor is a tool that can help you to do that as well, right? So when it comes to servers, when you want to launch a server, one of the things that you want to first know is what operating system do you want to use? And what version is it? Is it Windows Server 2012 or is it 2008? So you've got different Windows editions available. We also have Linux-based operating systems available. That ranges from Red Hat to SUSE to Ubuntu, and you have CentOS. So all of these are available, different flavors, different editions are available. What you have to do is make the relevant choice, select a particular operating system, and then this wizard will walk you through the process of launching it for you. Alright? I'll walk you through the wizard in a minute as part of my demo, but I just wanted to highlight one important thing. When you launch a server, you have to launch a server inside a specific availability zone. A region is made up of multiple availability zones. I did highlight that this morning. But when you launch a server goes into one specific AZ. It's not designed. When we talk about AZs, we did mention that if an AZ gets impacted for any reason, what happens to your business? So you want to launch your servers across multi-AZs. And this is where you would do. Alright? So first thing that you would start with is, you will use one of the AMIs that we give you. AMI stands for Amazon Machine Image. These are pre-installed images. The OS is already there. Some of the images that we offer has the operating system and applications like SQL databases pre-installed in that. So the deployment time, provisioning time is much shorter. You don't have to deal with the OS installation and stuff. The only thing that you have to do is once you launch a server from this image, you can then further configure it and save it for your own use as another image if you want. Alright? So you can use our base image, launch it, configure it, manage it, and then you save it as your own personalized image. So this is what we call AMIs or Amazon Machine Images. Alright? Technically we call it armies. So if you ever hear somebody saying, use that army or use this army, it's Amazon Machine Image, alright? Now a couple of other things are asked as part of the launch process. It asks you, in which network do you want to launch it in? Do you want to launch it in the public cloud or do you want to launch it inside a private cloud? Now I did mention earlier that if you create a new AWS account today or in future, you will not have access to the public cloud anymore. It's all inside a VPC. Alright? But inside a VPC, a virtual private cloud, I did mention we do that because we want to make sure that everything is launched inside a private environment. They are secure from scratch. And then you decide, inside a VPC, whether you want to have multiple subnets. So some of your subnets can be internet facing, like your DMZ zone, and some of them can be internal only. So you need to have these subnets set up before you launch a server. During the launch process, we will ask you, would you like to choose a subnet? At that time, you can decide, based on the server that you're launching, should it be in a private or an internet-facing or a public subnet. Alright? So VPC is something that we will talk about in this module, in the second section, but we want to have that set up correctly. Because here, in the second point, as you see, you have to configure not just the security group, the firewall, but also decide where will the server run. In addition to this, you can also configure a couple of other settings. That is like, for example, do you want a script to be executed inside the server? So how many of us have used Linux shell scripts? So you all know what a bash script is, right? Or for the rest of the hands that didn't go up, maybe you might have used PowerShell scripts in Windows. So these scripts can be added during the launch process. It can be added to the wizard. What will happen is, at the end of the process, when the server is coming up, at the OS layer, these scripts will get executed. So it's like bootstrapping. The technical term that we here use is bootstrapping. That's like configure the server automatically. If it's a web server, install IIS automatically or Apache automatically. So these are done with the help of those scripts. And I'll show you some examples as I go along in the demo, but that is something that you can do as well during the launch process. In addition to this, you can also configure what would happen when I right-click that server and I say stop. So there are certain terms that you have to take note. When we say stop in AWS, it means a graceful shutdown of that server. When we say terminate, it means delete that server, I don't want that anymore. And then there is a process of resetting the server, which is restarting the server. Okay? So you can configure a couple of these options. You can also define IP addresses for these servers. You can say that this server is going to be my web server and it needs a public IP. And we give it to you instantaneously. You don't have to again wait for requesting for public IPs and all of that weird processes that you have today. So here, IPs can be assigned to the server. The IP belongs to that server during the lifetime of the server. When you decide to throw away the server, you can return that public IP to us. And you know the beauty of this public IP? You don't pay for it when you're using it. Sounds weird. Elastic IP addresses or public IP addresses that we give you, they are available to you at no cost. So when you're using it, you're not paying for it. But if you ask for it and we give it to you, but if you don't assign it to a server, you are paying for it. That means you're underutilizing that resource that we give you. Alright? So be aware of these pricing aspects across various aspects of the service. So we do give you public IPs when you need. We also give you private IPs for your servers automatically, or you can set your own private IPs as well. And we know the pricing model here is pay-as-you-go. But the pay-as-you-go model will align to what instant type do you use. So if you have an instant type that is small, you will obviously pay a lower hourly fee. If you have an instant type that is larger, you will pay a higher hourly fee. But be mindful when you choose the instant type. The reason is the instant type comes in different types of configurations. Some with more memory, some with more CPU, some with SSD-based hard disks, some with non-SSD-based hard disks. So these are certain things that I will just walk you through in the coming slides, but just be aware of this. When you're launching a server, these are certain sensible choices that you have to make. So AMI plays a very important role. They act as your building blocks. It's highly recommended that you use one of the AMIs that we give you, customize it, and then save it as your own personalized AMIs. Now these personalized AMIs can also be shared publicly if you want. Or it can also be shared privately, which means I can share it with another AWS account holder. All I need is the account number of the other person, right? So these are certain things that you can do. And even if you look at our AWS Marketplace, the website that I showed you earlier, AWS Marketplace is a web page where other software vendors come and advertise their softwares. For example, Cisco, or if you look at F5, all these physical appliances you may be using today on-prem. But when you move this application of yours into AWS, you may want to also continue to use some of those appliances. But in AWS, everything is virtual, right? So what they do is they make those virtual version of those appliances available in the marketplace. And these virtual versions are nothing but AMIs. What you do is you launch from the AMI. So you get one of the appliances, one of the virtual version of that appliance, which you can use. So be aware of this. AMIs are available publicly. Alright, community also shares AMIs. Amazon also creates AMIs. So all of that is made available to you under the AMI section. Now coming back to the instant type that I was talking about, I did mention earlier that some of the instant types will have more memory compared to some of the other instant types. So if you notice here, we have a micro instant type that has about 2 ECU units. Now ECU units can be translated as one ECU unit is equivalent to 1 to 1.2 gigahertz of a 2007 Optron or a Xeon processor. Because when you buy servers, you want to know how much CPU you want, right? How many gigahertz you need. So when you look at 1, if you're conservative, you will look at as 1 is equal to 1 gigahertz of a 2007 Gen processor, alright? Or you can, if you're not being conservative, you will say 1.2 gigahertz. That's how you do the math. Okay? So if you look at some of these servers, some of them fall under the 2, some of them fall under 4, 8, some of them fall under the line there. So it could be more or less, but you can see there is a table that tells you exactly how many. And then if you look at the y-axis, you have memory. Some of the servers have more memory. As you go higher up, you get more memory. So you need to decide what instant type would be the best fit, based on the application that you're thinking of running. If your application is memory intensive, you want to go for something that offers you more memory. If your application is CPU intensive, you want to go for some of these servers that has more CPU compared to memory. But the balance, you decide, alright? So we give you a variety of instant types. As you see, there are some high CPU, high memory ones. We also offer cluster-based. So if you are using any cluster environments and you want to use multiple nodes, so these cluster servers are all interconnected over a 10 gig network. And what you can do is, you can use cluster compute based, that means it has more CPU. And then we also have cluster high IO based, that means it offers you more IO. So that means your application is very IO intensive. Alright? And we also have high memory based and high storage based. That means it uses a lot of memory or it uses a lot of storage capacity. So we give you different instant types here, hoping to meet some of the requirements that you have. Because in the UI, you cannot specify, I want X amount of CPU, X amount of memory. You get to choose from one of the instant types. And also be mindful, when you're choosing these instant types, some of the instant types fall under what we call the old generation. That means they're running on older hardwares. And we also have instant types that falls under the current generation. That means they're running on newer hardwares. So when you go to the UI, when you're trying to choose the instant types, it will give you a filter that says, do you want to see current generation only? Or do you also want to see all the old generation along with it? So please again choose the correct filter to choose the instant types. Alright? The newer ones are running on newer hardware, so you can leverage on the newer capabilities. So the most important thing here is understand how many cores do you need, how much memory, how much CPU is required in terms of speed, and also in terms of storage capacity. Are you happy with what comes with it? Or do you need more? Do you attach more? So all of that is part of the process of launching. And also one more important thing is the network performance. When you launch a server, please take note, the server type, every server type has certain specific network performance associated with it. Now usually what happens is the larger the instant type, the more network performance it will get. Some of them will give you 10 gig. It clearly states there it's a 10 gig network. Alright? So be aware of that as well, because if your application is very network intensive, you want to pick the correct type of instant type there. In addition to this, because they're running on newer hardwares, many of our instant types also expose these Intel features. They're running on Intel hardwares, so they expose Intel features like Intel AES, right, which is for encryption for data security purposes. Then we have AVX, which is for better performance in HPC environment, and people often use this in video processing, image processing, in simulations, audio processing, and all of that. These are examples where you can leverage on these CPU level features that will give you a performance boost. So if you have an application that knows how to recognize these features, they can leverage on it. It's like if you have an application that you use to convert video from one format to another format, some of the applications can also use GPUs, am I right? The application has the awareness of that. Similarly, if you write an application and if you leverage on these features, you will have a better performance there. Now, having said that, when I say GPU, that reminds me, we also have some instant types which actually are GPU based. They can leverage on the graphical cards available on physical server where that server is running. Okay? Now, not all instant types are available in all regions. Let me set the expectations right. Okay? So some instant types are not available in Singapore, so you may have to choose another region to leverage on those instant types. So here's a pictorial representation of all these features that I was just talking about, AVX, AES, how they are available, and you can see it's pretty much available across the graph, across different instant types. Now there is another way to look at it. If you look at the table which is given on our website, you can see a table like this that says the instant type is M3 medium, for example, the first one. And if you notice on the extreme right corner, it says it is using a physical processor in the back end, which is a Xeon E5-2670, which exposes these three features, which is AES, AVX, and Turbo. Which means if I run an application inside an M3 medium, not an M1 medium, do you see that? The M3 is trying to tell you which generation does it belong to. It's a newer generation. So the newer generation exposes the processor information and it also exposes these features, which you can leverage on. So please be mindful, make a sensible choice. Instant type choosing is a very important thing. But having said that, there is still room for error. Am I right? You can change instant type. Okay. Now let's take a moment and let's talk about purchasing options for a minute. When we talk about workloads in our on-premise environment, you have workloads that are predictable in nature, that's one type. There are some workloads that are unpredictable, certain times of the year. If you take AWSome.com during the shopping seasons, Christmas and Thanksgiving and those interesting seasons, we see workload going really up. Retail transactions going really up. So if you have a similar workload, you're going to start thinking about, when I buy these instances or when I use these instances, which would be the best option to use? The reason is we give you three different options. One is a reserved instance, the other one is a on-demand instance, and the third one is a spot instance. People always use reserved instances for their critical workloads, for the predictable workloads. That's like basically what you're doing today is, today you're here, you're trying to learn all these things. You go back, have your discussions, and you finally decide to move your workload to AWS. And when you move your workload to AWS, you kind of know how much resources is required, and you provision those servers, and you know that is what is required most of the time throughout the year. But there are times where suddenly there might be a peak workload, right? Sudden peak traffic comes in. So at that time, you can leverage on-demand servers. So let's try to understand how these three works. First, on-demand instances, you pay as you go. There is no contract, there is no upfront fee, there is nothing involved. But if you look at the hourly price of an on-demand instance, it's more expensive than the reserve and the spot. So what is on-demand used for then? On-demand is used for initial evaluation process. You haven't decided to move into AWS yet, you're trying things out, you're testing things out, you don't want to make any commitments yet. Alright? So that's where people use on-demand. And people also use on-demand for those workloads that don't really run maybe more than 5 hours a day. There is a calculator that will exactly tell you, based on the number of hours that you run these servers, it will tell you, should you go for on-demand or should you go for reserve? And I'll show you that example in a minute. Okay? So, reserved instances are the ones that is designed to give you a lower hourly fee. So if you know that this workload is going to run on AWS for the next 1 year, or this application is going to run on AWS for the next 1 or 3 years, you can actually go on a contract. This is where the contract comes in reserved instance. You pay a one-time upfront fee. You choose a contract of either 1 year or 3 year, and because you pay that upfront fee, you're sort of making a commitment that you're going to be with us for 1 year or 3 year, and we are able to give you a lower hourly fee. Because of the lower hourly fee, eventually when you look at your price, total cost of ownership goes down. Alright? And I'll open up the calculator right now. I'm going to show you the example of how much does it cost to run, say for example, an M3 medium server. So here we are. I'm looking at the EC2. I'm going to reset all our previous pricings, calculations that we did. I'm going to go to EC2, Singapore region. So say for example, I want to run one server, which is used hours per day, 24 hours a day. Alright? And here you get to choose what type of server and what operating system will run in it. So let's say if I go with the Linux operating system, M3 medium size, which comes with, as you see, 1 vCPU, 3.7 gig of RAM. It comes with SSDs, alright? And if you close and save, you can see if one server running 24/7 Linux M3 medium size on an on-demand pricing model where there is no contract involved, you are getting about $71.74 per month. Now, if you know that you're going to use this server 24/7, you shouldn't go for on-demand, rather you should go for a reserved instance. Now among reserve there are different types, but it's best to go with the one that is highlighted in green, because the one that is highlighted in green is the one that gives you the highest amount of cost savings. So if I choose the one that is given here, for example, and I say close and save, from $71, you just went down to $18. That's your monthly cost. Alright? So I did also highlight that reserved instance comes with an upfront fee, right? So you've got to take that into consideration. If you look at it from a total cost of ownership, you can actually go to the next tab, estimate of your monthly bill, expand this to actually see what is the one-time fee that you're paying. 370 bucks. That's your initial fee, which is part of your monthly first month bill, and then the subsequent month bill will be only $18.30. So you can do the math based on that. How much does it cost for me to buy a physical server, run it in the data center, with all the maintenance and additional work that comes with it, versus launching one in AWS, right, of this certain type, and then how much does that cost? So you can do the comparison there. So reserved instances are typically cheaper than on-demand instances. That's an understanding that you want to take away with you and go ahead and explore further. Now the third type that we have is a spot instance. Spot instances, these are excess capacity that we have, and we let you bid for that capacity and use that capacity. And we give it to you at a much more cheaper price. But it's important to note, spot instances, it's a bidding mechanism, right? So if you bid higher than the market price, let's say market price is this, and you bid higher than the market price, you won the bid, so you get to use that capacity. But what if the market outbids you? Because every hour, we re-evaluate to see whether did the market outbid you or not, or are you still outbidding the market. If the market outbids you, then that instance will shut down. Thereby we take the capacity away and give it to somebody else who won the bid. So should you be using spot instances for mission critical workloads? How many of us would like to use that? I hope not. Thank you for listening. If I see hands going up, that means you're not listening. Right? So spot instances are primarily used for ad hoc jobs. You've got a big data processing to do, for example, and you need a large amount of compute capacity, but you want to pay a cheaper price there. Okay? So for example, if you say on-demand instance is 10 cents an hour, spot instances could be 1 cent an hour. So you can get 10 of them and get the job done much more quickly, parallel processing. So spot instances will help you to save money that way. But keep in mind, it's more designed for ad hoc jobs. Right? It's a bidding mechanism. Now within on-demand tier, we also have something called a free tier. So if you want to get started, if you want to learn how to use AWS, sign up and start using the free tier. All you have to do is just search for AWS free tier and you would find more details on that. The free tier allows you to use what we call 750 hours of EC2 instance of a T1 micro at no cost. So there's a free tier there, which you can use it for learning purposes and so. Alright? So take a look at that. The free tier does not just apply for EC2, it also applies for other services. Now taking a step further, let's bring all this home now. So you have an AMI. From the AMI, you will launch a server. During the launch process, you will choose the instant types. You will also decide where would you like to launch it. In this case, you will see yourself launching inside a VPC, inside a specific subnet in the VPC. Alright? And then what we will do is we will use EBS volumes for these servers, and EBS volumes we can take snapshots, and these snapshots are stored in S3. This is typically how it will look like from a compute standpoint. All of these services coming together. Now, let's take a moment to look at the VPC example for a minute. So when you're launching a server inside a VPC, you have to choose which subnet in that VPC would you launch the server in. So if you look at this picture here, there are three different subnets. The first one is a public subnet, the second one is a private subnet, and the third one is a VPN subnet. So I'll talk about the first one, the public subnet. As you see, the arrow here points directly to the internet. That means it can go out to the internet. It's like a DMZ zone. But whereas if you look at the private subnet, the servers running in the private subnet, which is database servers, they don't have that arrow pointing out to the internet directly. That means they are private subnets. But if you want a server in a private subnet to talk to something in the internet, you can make it possible. How do you do that today in on-prem environment? If you have an internal server that needs to connect to the internet, do you use a proxy server, NAT, NAT instance? Same concept is applying here. So what we can do is we can run a NAT instance in the public subnet, and database servers, if they want to download a patch or something, they can talk to the NAT instance. NAT can go and fetch it and give it back to the database. So this is an optional setting. If you don't want to have that, you don't have to have it, right? And the third one that you see is a VPN subnet. VPN subnet is interesting because the VPC that you set up in AWS can be interfaced with your on-premise environment over this VPN tunnel. So you can actually set up a site-to-site VPN that is between your on-premise environment and this VPC environment. So what do you use VPN for? To interconnect two different sites, for example, so that all of this looks like one big infrastructure to you. This is the hybrid environment that we talk about. So what you can do is you can set up this VPN connection between your on-prem and AWS, and you can start interacting with those servers over that secure VPN tunnel. For example, it could be one of the database servers trying to replicate with the database server running on-prem over the VPN tunnel. And that VPN tunnel is an IPsec encrypted tunnel. I will talk a little bit more about that in the VPC module, networking module that's coming next. So this concept is something that we have to take note. When you're launching a server inside a VPC, you have to decide which subnet will this server be launched in. Other than this, you also have to decide on the firewall policies. When you're creating a server and when you're launching a server, you have to define what ports would be open on that server. Now here is trying to compare how we used to do it in the old environment, which is the public cloud environment, versus how do we do it in the private cloud environment. If you look at the private cloud, it kind of has more options for you. Like for example, if you look at the first one, you can configure inbound rules, you can also configure outbound rules. Okay? It's a firewall, right? So it's meant to be designed that way. Inbound and outbound rules. You can configure both inside a server or for a server launched inside a VPC. But in the public cloud, you couldn't do that. You could only control inbound connections. If you look further, in VPC, you can configure that for any internet protocols. And you can modify it whenever you want to. You can assign a security group or remove the security group whenever you want to. All of this couldn't be done in the old environment. So this is another reason why you should start thinking about moving into VPC. Right? So security groups, as we discussed this morning, these are firewalls for your servers. So for example, if it's a web server, you will open up port 80 and 443. And you will say receive traffic from the internet. But what you can also do is if you're using a load balancer, you don't have to open these two ports to the internet. You just have to open these two ports for the load balancer. Because the load balancer will receive traffic from the internet and then it will send it down to the web servers. So just by using a load balancer, you just improved your security model there. You just added another layer of defense. And your web servers are no longer exposed to the internet directly. They are exposed only to the ELB. Right? So all these are different options that you have with regards to security groups. This is part of the EC2 service. So this is where I'm going to stop about talking about EC2. Later I'll show you a demo of how to launch a server. But before we do that, there are a couple of other services that I want to talk about that also falls under the compute category. One of them is Elastic MapReduce. How many of us work on big data projects? Use Hadoop, for example. Right, see a few hands going up. So today, if you're using those environments, you may have set up those environments yourself. The physical servers, alright? You might have installed these softwares on top of it, and then you may be configuring and managing it yourself. What we are offering here is a hosted Hadoop environment. It's called EMR in short. What you can do is you can start leveraging on this in a matter of few clicks. Don't deal with any physical hardware environments there. Everything is set up, everything is managed for you. And what you can do is you can all bring this data in from different sources. An example of a source is given to you here. Your data might be stored in S3. S3 gives you unlimited capacity. You may have pumped in all your log files into S3. Say for example, the click logs from your website. Maybe you have tracked all those logs and you've stored that in S3. Now you want to analyze those logs because you want to see what exactly is the people out there, they're buying from your website, assuming you're running a retail site. AWSome.com does that, right? If you go to AWSome.com, if you pick a certain book or any product, do you see recommendations popping up? This product and this was bought by this is recommended. How is it done really in the backend? It's all data analytics. And EMR here helps you in doing those data analytics in a batch processing manner. You can say that let me run this EMR job, alright, maybe every few hours a day, take those results, and based on those results, let me change my website or the way I promote the products on the website. So this EMR cluster is actually made up of a master server and a bunch of slave servers. The master server delegates a job to the slave. And the slave is supposed to complete the job and give it back to the master saying, I'm done with it. So the master node here can be an on-demand instance or it can be a reserved instance. Whereas the slaves that you see, they come and go. They can be spot instances if you want. And you can save money based on that. Right? So you can get hundreds of slaves or hundreds of worker nodes to get the processing done. When you're done with the processing, just release those 100 nodes. You don't need them anymore, right? And you stop paying for them when you release them. So EMR is an important feature or important service that we offer, primarily designed around big data processing. Now when we talk about big data, again there are two different types of data sets that we have. One is structured data, the other one is unstructured data. Unstructured data is an example that I gave you, log files, click streams and all of this. Typically you bring those things inside EMR to process it. So EMR is another feature that I would highly encourage you to explore further if you are interested. If you are already doing big data processing and if you're dealing with all those hardware setups and management, try taking a look at this service. Next is auto-scaling. Auto-scaling is an interesting feature that we have that allows you to add more EC2 instances based on a metric maybe. So for example, ELB is getting all the requests from the internet. Based on an ELB metric, you can say, hey, there's a lot of requests coming in. Let's have more web servers now. Alright? So you can scale up with the help of auto-scaling, and you can also scale down. When you don't need those servers anymore, you can say, let me go back to my original state. So all of that can be done automatically with the help of auto-scaling. You don't have to sleep in the data centers to do this. How many of us have done that? Sleep in data centers. It's okay, you're shy. I've done that. So you don't have to be there watching in that console and trying to see whether everything is going okay or not. Is anyone going red? If red, then you have to alert the system and stuff. Worked in those days when we had pagers. I still remember. So auto-scaling kind of takes away all of that burden. You just have to set it up correctly at the start, saying when do you scale up and when do you scale down, and we'll take care of it for you. So it makes your infrastructure elastic in nature. Elasticity is a fundamental property of the cloud, which you should leverage on. And if you go to the case study section that I showed you this morning, you would find a lot of customers actually using auto-scaling. Other than elasticity, you also get to set it up easily, quickly. Alright? The ease of use. We have an UI now, graphical user interface for it. There was a time where we didn't have a graphical user interface for auto-scaling, but now we have it. So it's much more easier to set it up. It helps you to replace unhealthy servers. How does that do it? When you set up auto-scaling, you can specify, I want minimum 5 servers. If one of the servers in that 5 goes down, it will automatically launch another server. It will ensure there is always 5 servers running. So for your predictable workloads, you can set auto-scaling minimum equals certain numbers. You will always ensure that it's minimum. And on top of it, it can scale up and scale down. But minimum is always fine. So you can also use auto-scaling to save money. The reason is you are about to, if you've just launched a new application and it just went viral, and everybody is coming to your application and they're trying to use it. Or maybe you are running a promotion on your website, and there is a lot of hits coming to your website. You can use auto-scaling to take care of that marketing campaign for a short while. When the marketing campaign is over, you can scale back down. And when you scale back down, you save money. Because you don't have to live with those servers anymore. And when these servers are being launched, auto-scaling can launch it across multiple AZs. Keeping in mind that you want to make sure that it's highly available, right? So you can specify that, say, launch these servers in this AZ and that AZ. It will do that for you automatically. It will try to ensure that there is equal load on both sides. In terms of any servers, we have 5 servers here, let's have 5 servers here. Alright? So all of these things can be done as part of the configuration settings of auto-scaling. And one last thing that I want to highlight, if you know there is an event that's going to happen, like say football, it's going to happen on this day. What you could do is you could actually schedule auto-scaling. You can say, hey, auto-scaling on this day at this time, let me have 10 servers. And at 6 p.m. that day, when the campaign is over or the event is over, let me scale back down to 2 or 3 servers. You can specify all of that as part of the configuration. So here's a pictorial representation of how things work. So you have load balancer, which is distributing traffic to all the servers, the front-end servers. CloudWatch is a tool that will be monitoring the load balancer. It may be looking for latency issues on the load balancer. Alright, and what it will do is, it will based on the metrics that you specify. So if you say latency, if it is greater than this milliseconds, let's execute an auto-scaling policy. So utilization could be another one. So CloudWatch will execute an auto-scaling policy. So if you notice here, these 3 services they play an important role. They work together, but they can also work on their own. Like for example, you may say that I don't want to use a load balancer. Can I still use the auto-scaling? Yes, you can. In that case, you won't be monitoring the load balancer, you will be monitoring the servers. You'll be monitoring maybe the CPU utilization across all the servers. If it goes beyond 90%, let's say you will execute a policy. And what auto-scaling will do is, it will add a server to the tier. And it will notify the load balancer. If you're using a load balancer, it will notify the load balancer we've got a new server. And the job of the load balancer is to do a health check on this newly launched server. To see whether it's ready to receive the requests that's coming from the user. Now if you don't use a load balancer, new server is launched. But you've got to go and update that in your DNS saying, hey, abc.com can also go to that IP address. A manual intervention is required. We don't want manual intervention as much as possible in the cloud environment, so if you use these services, they all work together into one. So let me take a moment here and let me show you a demo of compute, how to go about launching an EC2 instance. So I've clicked on EC2 service. The first thing that you have to choose is the region, the most important thing. Where would you like to launch it? So I'm going to choose Singapore for this example. And then you can see there's a button that says launch instance. That's what you would click on. And that's when the wizard starts. First step, choose an AMI. We'll give you a list of images here. Okay? So you can scroll further down to see Microsoft server based. At the top you have Red Hat based as well. So these are some of the images. I'm going to use one of them. The next step is instant type. This is where you get to see all the different instant types that I talked about earlier. So it shows you all these instant types. You can choose one of those instant types that you need, and then you can go next. Then comes how many servers do you need? Where would you like to launch this server? Inside which VPC? Inside which subnet? Right? So these are the configuration settings. Do you want a public IP automatically associated with that server? So these are certain settings that we have. We also have some advanced settings. This is a script that I was talking about. You can add a shell script that will automatically install Apache for you. Next is add storages. If you need EBS volumes of different types, you can choose all of that here. Next is tagging. You can tag it. You can name the server. Let's say I call it a web server. Next is the security group, the firewall policies. So here what I'm going to do is I'm going to create a new security group. I'm going to call this my web security group. And I'm going to open up port 80 and 443. And in addition to that, I'm going to also open up port 22 just for this demo, because I have to show you how to SSH into that server. It's a Linux server. So I'm going to create HTTP, HTTPS, and SSH. And as you notice here, you can also trigger saying that SSH can only happen from my IP, not from the entire world. Okay. The last step is to create the key pair. This is the lock and the key that I was talking about, right? So it allows you to type a name for a new key pair and allows you to download it. And if you read it carefully, it says you will not be able to download that file again in future. So please download the key pair and keep it somewhere safe. Okay? Because this key pair is required whenever you want to SSH into your Linux server. If it's a Windows server, then you would need this key pair to decrypt the admin password. One-time decryption. After that, you can change the password to something that you remember. So in this case, what's happening is the server is getting launched. You can see this column that says instant state, it says it's pending. The status checks, it says it's initializing. So Linux servers usually take a much shorter time compared to Windows because Windows requires to run sysprep and all of that in the backend. So Windows usually take about 15 minutes. Whereas Linux will take about, say, 3 minutes, 3 to 4 minutes. You can see there is also the monitoring tab, which also shows you CloudWatch. We haven't really talked about CloudWatch, we'll talk about it later. So all those settings that you did, all of that is also captured in that description page. So our server is ready, now let's try connecting to it. So it's a Linux box, so I have to SSH it. So I'm using a Mac, so I'm going to use terminal. So just launch terminal, and then go ahead and just put in that key. Alright, specify where the private key is stored, and log in as EC2 user. So that's a default user account, and there you are, you're connected. So you've successfully logged into the Linux server. How long did it take? How many people did you have to talk to? Right? So launching servers when it comes to EC2 instances is very quick, and you can do all of this from the console. And you can notice here, the script got executed properly, so Apache is already installed. So it's a functional web server right now. So let me show you for those folks who use Windows, how is it done in Windows environment. So I'm going to take you live into EC2. And I've got a Windows server running here. I'm going to zoom out a little. Go to instances, you notice there is a Windows server. Same thing, click on it, click connect. It will say, would you like to get the admin password for the server? When you say get password, it will ask you where is that key that you just created and that you downloaded. So you'll browse, select that key, and it will decrypt that password for you. So by default what we do is, for Windows, we create an administrator account with a password, and this is the password for it. But for Linux, depends on the Linux operating system. If it's going to be Amazon Linux, it's EC2-user. That's a default user account. If it's Red Hat, it will be root. If it's Ubuntu, it will be Ubuntu. Alright? So you need to take note of it. The best way to find that out would be when you click connect, it will tell you what is that username. So in this case, it's Windows, so I have to RDP in. That's the only way of connecting. So when you click on download RDP, and you try to open that, it's going to launch the remote desktop connection. It's trying to negotiate, so it's going to take you to the Windows interface. And you should see the login process. It will give you the admin account. This is where you log in. Now you might be wondering, how did I remember that password, the complex password? What I did was I already logged in first and I changed the password to something that I remember. So once you've changed it, you can start using that password. You don't have to use that complex password anymore. Alright? So there you go. I've successfully logged in. That's my Windows environment. Does it look like Windows? Yes, it does. I see a lot of smiles on your faces, so that means you're happy. I didn't want to disappoint the Windows folks. Right? So that's why. So coming back to the slides. So the launch process of an EC2 instance is much shorter and it's much more quicker. So that is what you get out of the EC2 instance view. So that's what we have in EC2. Let's take a step further and let's now talk about networking. What are the networking features that we have? So one of the important features that I want to spend a lot of time would be on VPC, Virtual Private Cloud. I've already talked about it. And I will also spend a lot of time on ELB, Elastic Load Balancer. If you do notice among all of this, those are the two that are highlighted, boxed up. That means those are the services that we'll focus more on. The rest of the services are value-added services that you can leverage on. And I'll introduce you to those services as well. So VPC is Virtual Private Cloud. It's a private LAN network that you set on top of the AWS cloud. So what do? You say, I want to create a VPC environment with a specific IP address range, and I want to break it into different subnets. Alright? And I want to control where my servers run. Do they run in a DMZ or a public-based subnet, or inside a private subnet? Now, a lot of our customers, what they do is, they look at their current infrastructure, alright, and they ask the question, am I thinking of, in future, interfacing my current on-premise infrastructure with VPC? The reason is, if you, in your on-premise infrastructure, if you're already using some IP address range, you don't want to use the same IP address range inside a VPC. So you ask yourself this question first with a network team. Is there any plans of doing that? If there's any plans, make sure the IP address range that you will use when you build a VPC here, it's unique. Not matching the one that is running on-prem. Because later when you set up a VPN tunnel, you don't want clashing of IP addresses. Right? So that's the most important thing that you have to take note of VPC. IP address range. Then you can go ahead and create your subnets. Okay? So let me jump into this picture and I'm walking through this. First, you create a VPC with a specific private IP address range. So it has to be one of those, which is the 192 series, or the 10.0 series, or the 172 series. You talk to your network team, decide which one would be the most preferred one here, and then choose accordingly. Next, you will then subdivide this big VPC network into multiple subnets, smaller networks. And then what you do is, you specify at the subnet level what we call route table rules and NACLs. So these are networking concepts. Alright? Some of you might not be doing this firsthand. You may be working with the network team and doing this. But please remember, every subnet has a concept called NACLs, which is Network Access Control List. And it also has a concept of route tables. So let me kind of break it down a little. Every subnet has a firewall. And that firewall is called a NACL, Network Access Control List. Alright? And every subnet has a route table which tells the server inside the subnet if they want to go somewhere, who do they talk to? If they want to go to the internet, they have to talk to the internet-facing router. If they want to talk to another server in another subnet, they have to talk to the internal router. These are defined in the route table entries. You can also assign public IPs. You saw that as part of my demo. You can assign a public IP. We call them elastic IP addresses. So you can request for an elastic IP, we'll give it to you, you can associate it with your servers. And there you go, the server just became public server. And as I mentioned earlier, you can also create a VPN connection between this VPC and the AWS environment. Or between VPC and another VPC in another AWS environment, or between VPC and your on-premise environments. There are different network topologies that you can leverage on. Having said that, this VPC and the VPN connection that we are setting up, it's over the internet, right? Do you have dedicated bandwidth? Does the internet belong to you? You wish you could. Not the case, right? So the bandwidth that you get over the internet, it varies. But what if you want dedicated bandwidth? A dedicated connectivity between your on-prem and AWS. Maybe because you are replicating your database from on-prem to AWS. Or maybe you're backing up your on-prem environment and pushing all of those backups into AWS. Or maybe you're using storage gateway on-prem, which helps you to store files there, but it's syncing and storing everything into S3. All of these are dependent on the network connectivity, am I right? The performance of it. So if you want to make it better, take a look at another service. The name of the service is called Direct Connect. What this helps you to do is, it helps you to establish a direct connection between your on-prem environment and AWS environment. So this is where what you do is you set up a lease line. Walk with me here. You will set up a lease line between your environment, the one that you see at the bottom part is your environment there, customer firewall, customer router. So you will set up a lease line between your on-premise environment and a direct connect location. Okay? From on-prem to a direct connect location. The direct connect location that we have in Singapore is Equinix SG2. So you can either set up this MPLS lease line with the help of your service providers, alright? And they can help you set up all of this end-to-end connection. And from the direct connect location, you can then decide whether you want to have a 1 gig or a 10 gig direct fiber into your AWS environment. So one, it is a lease line, it's a private line. Second is the one or a 10 gig option that you can choose. Now, if you are not aware of how to go about doing this, please talk to the local account managers. They can direct you to the local folks, direct connect partners who can help you with this. Alright? There are quite a number of local service providers who are there, direct connect partners who can help you with this all the way end-to-end connection. Alright? You don't have to take all of that undifferentiated work. So direct connect gives you that dedicated connection, and you can use that for all those use cases that I just mentioned. Another important service that I want to talk about in the networking module would be the Route 53. Route 53 is a DNS service. Now traditionally what do you do? When you set up a website, you will go and register your website. For example, if you register with GoDaddy, they will give you a list of name servers, DNS servers. You will have to use that. My question to you is, how much control do you have over those name servers? How much control do you have over the routing of those queries that's coming from the internet? Not a lot, right? So if you want to have more control, so let's talk about what kind of control are we talking about here. Route 53 is a global network of DNS servers. What you can do is you can still register your website at GoDaddy or wherever you register, but you can come to Route 53 and you can specify that, hey Route 53, you're going to handle all my DNS queries. So Route 53 will give you a list of name servers, update that in the GoDaddy's DNS configuration list. So you use these name servers, use the Route 53 name servers, not the GoDaddy's ones. The GoDaddy one will go down in that list. You will have more preferred ones who will be the Route 53 ones. The beauty of this DNS service is it's global in nature. Alright, so it answers these queries in a low latency. It's available across all these edge locations that we talked about, the 51 edge locations around the world. And it has an SLA of 100% availability. There you go, stop worrying about the availability of Route 53 or DNS service. Now, there's a couple more interesting stuff that Route 53 does. It can answer queries. That's what DNS is supposed to do, right? If somebody says abc.com, it has to point to the IP address that will serve the abc.com webpage. So this IP address can be associated with a server that is running on-prem, or it can be a server running inside EC2. So this Route 53 DNS service can also route or answer queries to on-premise servers. Okay? So that's something important to take note of. From a DR standpoint, it comes in very handy. If your on-premise server is receiving all the traffic, if something goes wrong, Route 53 can do a health check on that. If it sees that the server is down, it will redirect all the traffic to another location if you specify. Okay? So it can do round-robin based answering of queries, that's one way. Second is it can do weighted round-robin. In weighted round-robin, you can specify 75% of the traffic goes on-prem, 25% of the traffic goes to AWS infrastructure. Maybe you're running an active-active environment here. Okay? From a DR standpoint. So you can leverage on Route 53 for that purpose. Route 53 can also do latency-based routing. So during the break, we had a question from a gentleman saying that if I have an infrastructure set up in Singapore, which is serving my local user base here, and if I have another infrastructure set up in US with a load balancer, with the EC2 instance, serving that user base, is there a service that can help me to detect where the user request is coming from and send them to the nearest resource point or the nearest load balancer? The answer is Route 53. Route 53 does something called latency-based routing. It can detect where the user request comes from and send the user to the nearest load balancer. For example, somebody from KL will go to Singapore load balancer. Okay? So everything is managed. You don't have to do a thing here. Just have to configure it correctly, that's all. So that's another important service. That's another way to answer queries. You don't get all of these controls in other DNS servers that I've seen. Personally, when I've used it, not much control. But here you have more control over the answering of queries. One more thing that it can do, it can do health checks. So again, take this example of a load balancer set up in Singapore, distributing traffic down to the web servers. Another load balancer in, say, Sydney, distributing traffic to the web servers in Sydney. If the load balancer in Singapore is down for any reason, Route 53 will redirect all traffic to Sydney. You don't have to do a thing. No more sleeping in the data centers again. Right? So we're kind of taking away all that maintenance work. You see, every single service offers you a certain level of availability, certain level of, durability, and here it's trying to do health checks and fade over automatically. So do leverage on it. It's one of those services that is awesome to use. It's just a matter of going and trying it out. There's not a lot of work to be done. It's just taking the name servers that RAW53 gives you, update that in your relevant registration page, the website registration page. So let's now focus on the ELB, which is running in a specific region. So RAW53 is one of those servers that, as you notice, can talk to multiple ELBs around the globe. So it's a global service. It's not restrained to run within a region. RAW53 is a global network of DNS servers. But when you focus on one specific region, Singapore, and if you've got servers running in AZA and AZB, and you want to distribute traffic to those servers, you would see yourself using ELB. ELB, which is Elastic Load Balancer, what it does is also, it does not act as a single point of failure. ELB actually grows and shrinks according to the traffic that comes in. It's a service that we manage for you. You don't have to manage that load balancer. So we scale up and scale down the load balancer. We make sure the load balancer is available to you so that whenever a request comes in, it is sent down to your web servers. So what you need to ensure is, how do I detect if one of my web servers is down? So traditionally you will do different types of health checks, right? But here ELB can do a health check also for you. So you can configure the health check settings in ELB. And you can say that, hey ELB, go and talk to this particular server, do a HTTP ping, for example, and try to ping that index.html page or the index.php page. So go and look for that file. If that file is available, if it's responding to your pings, HTTP request, that means the web server is ready. But that's a very simple way to look at it, right? That means IIS is set up or Apache is set up, everything is okay. But what about your underlying database, underlying application? So what you can do is you can make it a little bit more smarter. Instead of pointing it to a file, the default page, what you can do is you can point it to a file that gets dynamically created after doing a list of health checks internally. So for example, your web service could be running a Python script that will go and check the status health checks of all the application and database tier. If everybody is okay, then it creates a file which the ELB is looking for. So when the file is created, it means everything is okay. And then ELB will start sending traffic to that server. So you can do it in both ways. One requires a bit of an effort, the other one is pretty simple and straightforward, which is just talk to the default page. If the default page is there, it means IIS or Apache is already installed. And then it should be able to receive the request. So ELB can also handle HTTPS traffic. So HTTP traffic can be received and it can be sent as HTTP to the web servers. Another example. It can receive HTTPS packets and send it down as HTTPS to the web servers. But who is going to take care of the decryption part of it here? If it is sending it down as HTTPS to the web servers have to have the SSL certificates to decrypt it. But what you can do here is you can give that SSL certificate to the ELB and you can say, hey ELB, do the SSL termination at your level. So receive traffic on HTTPS port, decrypt the traffic, then send the decrypted packets to my web servers. I don't want my web servers to be busy decrypting those packets. So offloading of SSL can be done here. Okay. So these are additional features that it does. It's not just a simple, see, load balancers are meant to do round robin based, right? They just do round robin based forwarding of traffic. But here it does a little bit more than that. It's just not a simple load balancer. It also supports sticky sessions. So if you have applications, and if your client that connects to that application needs to maintain a sticky session, that can be enabled. That's an option which is available here. In addition to all of this, recently we added ELB logs. You can actually go in and see the logs that is captured by the ELB. You can see where the traffic request came from and all of that is captured at the ELB level. And you can look at the ELB access logs. So that's another feature that we recently added there. So from a user standpoint, the user just connects to the website. He or she doesn't know what's there, what infrastructure component is. Right? They connect to the website, they come to the load balancer then sends that request to one of the EC2 instances running in the backend. The only thing that you have got to make sure is you've got to make sure that you have enough EC2 instances in the backend to handle all of that traffic. And that's where auto-scaling comes in, right? We talked about auto-scaling. It helps you to add more servers or remove servers when you don't need them anymore. And the load balancer can be set up using the GUI interface. It can also be set up using the API interface. All of those are different ways. that you as an administrator or a ELB owner can access the ELB service. So let me take you through a demo from a networking standpoint. I'm going to take you through VPC first. So if you look at the VPC, I've clicked on VPC. This is the UI that you see. Alright, the VPC dashboard. And you can see on the left side, the VPC name is shown here. It belongs to the 172 network, as you see here. Then the subnets that you create inside the VPC, you can see all of those subnets here. If you want to create more subnets, there is a button up there that says create subnets. Alright? And then I did mention earlier that every subnet has something called a route table. And if you scroll down in that description view, you can actually see the route table and you can also see the network ACL. So all of these are configurable options and you can configure all of this on the left side. If you notice, here I'm trying to highlight saying that this is a public subnet. To go to the internet, it is talking to the internet gateway, which is the internet facing router. So this is my public subnet. Alright? So you can go to the route table, you can configure those route table rules here. If you want internet gateway, you would go to internet gateway to request for one. Right? These are internet facing routers. You don't have to manage anything there. It's just a pure internet facing router. If you want to set up your own DNS servers, you can do it here in this UI. You can launch some DNS server, specify the IP address of the DNS server. That means you want to manage your own DNS servers. Right now it's using Amazon DNS. Right? We talked about security groups. You can see here inbound tab and outbound tab. These are the two tabs that shows up for the web security group. If you want to set a VPN connection, the bottom part will help you to do that. Customer gateway is the IP address of your VPN router. Virtual private gateway is the VPN router that we give you. VPN connection is the last step where you connect these two endpoints. Alright, so using these wizard options, you can actually set up VPN connections. You don't have to be a geek, a networking guru, a VPN expert. It's all done from here. A click of a console, right? So I'm going to now show you ELB, how to set up load balancers. I've got two web servers running here. And I want to show you how to create a load balancer to distribute traffic to those two web servers. So when I click on create load balancer, it opens up this UI which allows me to name the web server, name the load balancer. You can specify what port will it receive traffic on, in which VPC will that load balancer be created. So it's going into the default VPC. This is the health check setting. Do an HTTP ping and look for this particular start page. In this case, I'm using a Windows-based web server this time. So it is looking for the IIS start page. You can specify how long will it wait, how many times will it do the health checks. All of these are intervals that you can set here. So I'm setting the healthy threshold as 3. That means do 3 times. Try to talk to the server thrice. And if it responds, declare it as healthy. Okay? The ELB also has a security group. Because you're receiving traffic on port 80, so you can say, hey ELB, I'm going to only open up port 80 for you. And you will receive traffic on port 80 from the internet. Do you see on the right side? You can see 0.0, that's the internet. And then you choose those two web servers. These are the two web servers that you will load balance the traffic to. That's all. Just 3 or 4 steps, and you just created a load balancer. Remember this morning, Ash was saying, the gap between a developer and an administrator is getting thinner. DevOps, please be mindful of this. You don't want to be like, I'm the load balancer expert in this world, and I'll have a job for the next 100 years. Okay? So it's getting very easy to get these things done. So let's take a look at our security groups for our web servers. Currently, if you notice, the security groups are open to the internet. So, but what I want to do is I want to say that my web server security group, inbound traffic, if you notice, port 80 is open to the internet. And RDP is also open. So I'm going to remove all those rules. I don't want them anymore. What I'm going to say is, I'm going to receive traffic on port 80, not from the internet for the web servers, but from the ELB security group. Do you see that? This means only the ELBs can talk to my web servers. The web servers will only receive traffic on port 80 from the ELB, not from the internet. So you just made it a little bit more secure there, right? So moving on to the load balancer, let's check whether the load balancer is working or not. So if you notice, the load balancer does give you a DNS name. The DNS name is given instead of an IP. The reason is it's actually made up of many nodes in the backend, which grows and shrinks depending on the traffic that comes in. And we can see here, it's an internet-facing load balancer. By the way, you can also create a load balancer that you can place between your web tier and app tier. That's called internal load balancer. That is also possible. Okay. So Instances tab will tell you whether your servers are out of service, have they passed the health check yet? Right now, you notice they are still going through the health checks based on these settings that you did. The monitoring tab is the CloudWatch service that is monitoring things like latency and all of that. You can see it from here. Okay. Security group that we selected is listed here. Listener is showing you the ports that is open. So for example, if you want to do SSL termination here, you just choose HTTPS and provide the SSL certificate there. And ELB will take care of the SSL termination for you. Alright? So these are some settings that I wanted to just highlight, which is part of the ELB. And let's now copy that ELB and let's do a quick check whether we are able to reach the load balancer. What we are waiting for is we want our instances to be healthy. If our instances are not healthy yet, that means they haven't passed the health check, then any connections to the load balancer will fail. Alright, because it won't be able to send that request down to the instances. Take a look at this, it's in service now. That means they're ready to receive traffic. So all I have to do is grab that DNS name of that ELB, put that on another browser or another tab, and you should be able to see, can you reach the web server that's running in the backend? Yes, you can. That's a Windows server. That's the IIS start page. Okay. So that's how easy it is to set up your web servers, keep it ready, and then do the necessary configurations, create the ELB, and then point to the web servers. And if you look at the web servers now, look at the security group. You've just secured it, so it will only receive traffic from the security group, which is the ELB security group. So small settings like these will improve the security posture. And that's what I want to highlight in this particular demo as part of the load balancing and all of that. Those are good stuff, but you also want to have things set up in a secure fashion. Okay. So that's what we have in this compute and networking module. So we've talked about compute, EC2. We saw ourselves setting up EC2 instances. Alright, we saw how to connect to a Linux instance. We also saw how to connect to a Windows instance. And then here, we talked about what is a VPC and how do we set up an ELB and distribute traffic to load balancers. So all of these demos that I'm showing you, folks, you can access this firsthand. Right? Ash was mentioning this morning that you will be receiving an email, and once you receive that email, it will give you access to the lab environment. And in those lab environments, you will actually do all of these things that I'm showing you. So don't worry if you don't try the hands-on yet. Just enjoy the show for now. Alright? Alright, it's time for us to take a step further and talk about a couple of other services that fall under the managed services and databases. So in this, I will talk about DynamoDB, which is a NoSQL database offering. I will also talk about RDS, which is a relational database offering. I will compare these two and we will try to learn how different are they. More time will be spent on RDS, so let me start with that first. How many DBAs do I have in the room? Just 1, 2, okay, cool. Now, when we talk about DBA, they really work hard. That's a good question. DBA job is not easy because it's not just about setting up a database. It's also about making sure the database runs optimally. So traditionally what happens when you set up database, day 1, week 1, runs awesome. You're happy, sipping coffee all the time. But then after a month or so, you don't have time to sip coffee also, because usually what happens is databases performance, if they start at this, they eventually kind of go down this way. Unless you optimize it and then bring up to the next level. So there was a lot of work involved from a maintenance standpoint for a database, and customers came to us and they said, can you take away all that maintenance work from us? There are maintenance work like backing up your databases, daily backups. You've got to start thinking about your transaction logs also. Right? You want to capture your transaction log as often as possible, so that when you restore, you're able to restore to a certain point in time. So backup is one. Second is patching. How do you patch the operating system where the database is running? How do you patch the database itself? Right? When minor versions come out or major versions come out. And how do you take care of failovers? If something goes wrong with the master, how do you fail over to the secondary or the slave? So all of these are administrative burdens where customers came to us and they said, yes, we know we can use EC2 and we can launch a database of our own. But what happens is when we launch it using EC2, we have to manage everything ourselves. So can you provide us a service where you take away some of this management work? And that's when we release RDS. So what RDS allows you to do, or relational database service allows you to do, is it allows you to launch 4 types of databases using this service, which is listed in the last bullet there. It's MySQL, PostgreSQL, Microsoft SQL Server, and Oracle. You can launch these 4 types of databases using RDS, and will take away that undifferentiated work of backing up the databases, patching the databases, automatic failovers, right? So all of this can be taken away based on when you're setting it up, you can actually tell us, no, don't take that away, let me do that. If it is, yes, we'll let you do it. So please take note, RDS is an important feature to take note of, and it's very easy to set up. You don't have to be a DBA to set up RDS. You and I can do it, alright? I'll walk you through the demo, you will see that in a minute. But still, the job of a DBA still exists here. If you talk about performance tuning, we can't do it because we don't have access into your database layer. If you talk about schema optimization, we can't do it. You still have to do it. If you want to do sharding of databases, you still have to do it. We can't do it because sharding means we're touching your database. So that's where we draw the line. Alright? So let me talk about what exactly can you do with RDS. So in RDS, you can set up a database, and during the setup process, we'll ask you, should we take backups? Tell us when should we take the backups. We'll do it according to that. When should we do the maintenance work? Things like patching and all of that. You can tell us what time. We will do it according to that time frame. Right? And you can also specify that I want to launch this database in a multi-AZ mode, a master and a slave mode. So what we can do for you is, if the master goes down for any reason, we can make the slave the new master. Failovers. So all of this can be done by us. That's all. Schema optimization, performance tuning, you've got to do it. You've got to log into the database and do all of those things. Right? So a couple of other things to take note of is, when you're launching the database, you also want to think about, am I launching this in a VPC? And in a VPC, in which subnet will I be launching this database? So you need to ensure that these subnets are created and they are ready, so that during the launch process, you just point to the private subnet, for example. So the databases will be launched in a private subnet. Okay? So the basic functionality of VPC subnet that we discussed earlier applies here also. Every subnet can have route tables, every subnet can have rules, NACL rules, and you can configure where does the traffic flow happen. Alright? So all of this is part of the console. One of the interesting things that we have in RDS is, when you buy RDS instances, you can buy them as reserved instances, so that you get that lower hourly fee. Because databases typically run 24/7. And you want to optimize, cost optimize it using reserved instances. So later I'll show you a demo of RDS. Before we go into that demo, let's talk about DynamoDB. So RDS is relational databases. But there is also a new wave of database, which is a NoSQL database. How many of us use NoSQL databases? See more hands going up. Right. Some of them are doing this. That means we don't. Or getting there, swimming there. Alright. So DynamoDB is a NoSQL database offering from AWS. It's a managed NoSQL database. It runs on SSD. Okay, so it's fast. Second is, when you provision a NoSQL database using DynamoDB, the only question that we ask you is, how much read and writes do you want from it? And we'll ensure that we give that to you all the time. You don't have to worry about, oh, where is it stored? Do I have to take backups? The reason is, whatever you store inside DynamoDB gets replicated across multiple AZs automatically. It gives you unlimited capacity. Alright? Think about it. It's a database giving you unlimited capacity, giving you availability by design, alright? Giving you performance as you ask for, predictably. Right? So it kind of takes away all that management work that you used to do with your own NoSQL databases. Today, some of you might have your own NoSQL databases set up on physical servers, and you may be managing it yourself. So here it's going to take away that undifferentiated work. But you need to understand, if you've never used DynamoDB, it's important to understand NoSQL databases typically handle key value pair data. They don't handle complex queries and joins and all of that. Alright? So one is RDS, which is relational databases. Then we have NoSQL databases, which is DynamoDB. What if you are thinking of setting up a database which is like IBM DB2? RDS does not give you that option. You will see yourself using EC2. That's when you will go back to the EC2 instance view, look for an IBM DB2 AMI, and launch an instance from that. Okay, so you can still do that, but it becomes a self-managed option. So let's take a moment here to compare RDS and Dynamo for a minute. So one is a SQL database. So what you can do is you can use that for database applications, business processing centric applications. You have complex joins, queries that you want to do. All of those scenarios will fall very well under relational traditional databases. So where do people use NoSQL databases nowadays? People use that for all these use cases. That example that you see, right? They use for new web scale application where you have to do a large number of small writes and reads. Right? You want it to be very fast. You don't want to go and query the database, wait for all of that round trip and the latency to come back to you. You want to do it way quicker. So example, if you run a website, say for example if iPhone is getting launched, right? And you're going to allow people to come and pre-register for the iPhone. So when people come and say, I want one, I want one, I want one, I want one, are you going to go all the way down to the database and you're going to do that transaction of -1, -1, -1? Or would you rather put that in a NoSQL database where you just have to do a quick update on it? It makes more sense to put it here. Game scores. When you play games, today many games that runs on AWS leverages on DynamoDB in the backend. The game scores can be stored there, and game scores are temporal in nature, right? After you play a game or another level, the game score will increase. So you just need to update that. Another example is if you have a website which allows shopping, right, like Amazon.com. When people add things to the shopping cart, do you want to store that in the database? No. You'd rather store that in a DynamoDB table. And the beauty of this is when you store something in DynamoDB table, it's replicated across multi-AZs. That means web servers running across multi-AZs can talk to the same DynamoDB table. And you can query that data from there. Okay? Having said that, there are some use cases where you may not use DynamoDB, but you may be looking for a much faster option. See, databases, RDS is based on disks that we talked about, right? Here DynamoDB is based on SSDs. Much faster than that is something that is based on memory, which is what we're going to talk about next. Alright? Elastic cache. This is a memory-based caching layer. Reading from memory is way faster, right? So that's what we're going to talk about. But before we go to that, let me go back to this NoSQL discussion that we're having right now. So people use NoSQL database for simple data model where there is no complex transactions involved. It's a simple query that you want to do based on a primary key, or maybe based on a primary key and a range key. Alright, get me all this information based on this values. So NoSQL databases that we offer here, DynamoDB, is fully managed. If you look at the scaling part, it's seamless, on-demand scaling. If you look at performance, automatically optimized. Reliability, availability, fully managed. Durability, fully managed. What else do you need? Right? It's a database, but fully managed for you. So it helps you to kind of focus more on writing newer apps, newer games, leveraging on this storage capability, or this database capability. Right? So I was talking about Elastic Cache a few minutes ago. So if you want to offload, excuse me, sorry, that was bad. That was a wake-up call. Elastic Cache is basically memory-based caching layer. Today, how many of us use Memcached? Yeah, I see your hands going up. 1, 2. Redis? It's like, okay, thank you. You just scared me. Like, no hands went up. Now, people use Redis, Memcached environment to create a memory-based caching layer. What they do is they take multiple servers, they take the memory of those multiple servers, and they create a caching layer. It's way faster to read from a memory compared to reading from a disk. So what we can do is you can use Elastic Cache also here. It's a basically, as you see, Memcached or Redis compliant caching layer. But it's something that we create and we give it to you. And you can put this in front of your databases, for example. So if you've just done a very complex query, the results can be stored here. Next time somebody makes the same query, you can just fetch it from here. You don't have to make that query to the database anymore. Right? If you need a faster, so for example, going back to the shopping cart information. The shopping cart information is added. I was giving an example of DynamoDB. Assuming if you're using Elastic Cache, it will be way faster to retrieve it. Right? So it all boils down to how many transactions are you looking at per second. Alright, what's the byte size that you're looking at? So Elastic Cache is going to be super fast there. And here, as you see here, we manage the patching, we manage the detection of failure, we manage the recovery. It's a managed service. Alright? So all of this can be leveraged on to make that environment much more better. It could be in front of databases, or it could be leveraged by other application services to use or to store a subset of data and retrieve that data. Now please take note, all of these services that we are talking about, they don't replace each other. Each of them have a role to play. I'm trying to explain how they work so that you kind of find the right place to fit that in. These are building blocks. Alright? So you build it according to your need. Now Elasticache can also be set up and configured using command line and APIs. All of these mechanisms are available, so do leverage on it. The relevant documentations are given to you as well for the other services that we've also discussed. Now taking a step further, I also want to talk about Redshift. How many of us deal with data warehouses? I won't ask the next question. It's burning in my head, but I want to ask, how much does it cost you? But no, don't tell me the answer. Customers came to us and they said, it's super expensive to set up data warehousing environments. And it's super expensive to manage it. And then you've got to go through the refresh cycles, right? You have all of that pain. So they came to us and they said, can you provide a data warehousing service? I've got a lot of structured data. Catch this. Not unstructured data. We talk about unstructured data, you can bring that to MapReduce, you can analyze it. Now we're talking about structured data, which is in tables and rows. I've got like petabytes of structured data, or gigabytes of structured data. I want to bring this somewhere so that I can start querying it. And when I query it, I don't want it to take hours and days to come back with the result. I want it to give it to me as quickly as possible. So these are some requirements that they came with, and we said, alright, here's Redshift. Redshift allows you to load your data sets. Your structured data sets could be in petabytes, could be in gigabytes, whatever it is. You load it here. And then when you make queries to Redshift, it's going to use multiple nodes in the backend to parallelly process those queries. That's the beauty of this. So it uses parallelized processing to compute those queries and gets those SQL results to you quickly. And let me share with you an example of where this is used. In one of the organizations, insurance company, when somebody walks in and they want to, file in for insurance, they want to look at credit history and stuff like that. So what they do is they use Redshift, and the gentleman walks in, sits at the table, say hi, hello, get the information, run a query, and these two walk out to the cafeteria, grab a coffee, and they come back. The results are ready. The back officer or the financial officer knows, should I give the insurance or not? Or what are the aspects? So instead of making the customer or telling the customer, alright, we've got your request, please come back within 2 days, or we will contact you. You see, real-time service makes a difference. And a technology like this can do a great impact there. So Redshift helps you to load petabytes of data, query that data quickly, and get those results out. And this is something that I would highly encourage you to leverage on if you are currently using data warehouses. Take a subset of that data, put it into Redshift, try out those queries, see those results for yourself. Alright? So you can start small. Doesn't have to be petabyte. That's why I gave you an example. It can be even gigabytes. Right? Start small, grow big. Now keep in mind, a lot of times what happens is people start thinking about Redshift as a way to replace RDS. It's two different things, right? This is a data warehousing solution. RDS is your database. Alright? In RDS, there is a limit in how much data can it hold. 3 terabytes is what you're looking at. But here, we're talking about petabytes here. So if you have all of this data, you can pump all of that data here. Typically, you will go through a process of what we call ETL, extract, transform, and then you will load it into Redshift, and then you can start making queries on that data set. So again, please take a look at this. It's again a managed service. It automatically monitors the health of all the nodes that's running in the backend, which is processing these queries. And it also takes care of the aspect of availability and all of that. So those are some of the services. I want to take you through a demo of RDS. Because we spent some time on RDS, Relational Database as a Service. I want to take you through a demo of how to launch a RDS-based database. Here we are. I've clicked on RDS. Again, first thing is choose the region, then click Launch Database Instance. Now you can see it gives you a different list of database types with the different editions. You can choose one of them. It will then ask you, would you like to use this database for production? I'll say yes. It automatically selects few things for me. It says, would you like to launch it in a multi-AZ? It is set to yes. That means set up a master, set up a slave, set up synchronous replication between those two automatically. Minor version, do you want us to upgrade that for you? Alright, whenever minor version comes out. How much storage do you need? How much IOPS do you need? So do you see here, we don't deal with EBS volumes. We just ask you how much storage, how much IOPS. We take care of all the EBS attachment and striping and all of that. What's the name of that database instance? What should be the master username? And what should be the password? You can set all of these things. Because you know it, you have full control over that database now. The next is the database name. Earlier was the instance name. Now is the database name. It's an optional setting, you can set that. You can choose other settings like in which VPC would you like to launch it, in which subnet. All of these is part of the settings here. And then comes the management part. Would you want us to take automated backups? How long should we keep those backups? We can also do housekeeping for you. So the backups that we can take, we can keep it for 35 days maximum. Alright? When should we take the backups? When should we do the maintenance work? If there is a patching to be done on the OS layer, if there is a minor version upgrade to be done, when should we do it? So you can tell us all these things. So it's not like we do it when we want to do it. You can tell us when it should be done. And we do it according to that. And that's all you have to do here. Did that require any DBA skills? Except the port number 3306. Alright, there you are. The database is being launched and you can see the status. It says it's in a creating state. When you click on it, you can actually see all those settings that you did. The endpoint name is not available yet. That's what we want. At the end, it will give you the endpoint name. You just need to take that, use that in your SQL Studio or MySQL Workbench or whatever tool that you're using to talk to. There it is. But it's still going through a modification stage. So from creation, now it has to set it up in a multi-AZ mode, so it's doing that. Then it goes through a backup stage. That means it snapshots the database. And when it is done, it is then ready, available to you, for you to use. Now it's not as fast as I've shown you here, because I've paused the video. Alright? It'll take a little bit of time. It's a database, come on. The snapshot that was taken, you can actually find that here under the snapshot view. When you go to automated snapshot, it will show you that snapshot. And you can also restore the snapshot to a point in time if you want to. Okay? So going back to the instances, in this case it's a MySQL instance. What I can do is I can look at the log files for it. So for example, when I click on log and I say view my error running logs, SQL error running logs, it shows me all those InnoDB logs. I can view it from here. If you want, you can also download it. You can see there's an option to download that as well. And if you want to see the database that you created, the IOPS that you gave, is that enough? Or if you want to see how many DB connections are happening, you can actually see that from the monitoring view. When you click show monitoring, it gives you all of that metrics. All of these are CloudWatch metrics. And based on this, you can then take a decision, what should you do next? Alright? You can also create read replicas. If it's a MySQL database, it supports read replicas. It can be created. You can take snapshots, you can restore it to a certain point in time. All of these are different options given to you in the RDS view. Now, please take note, the database that I launched was a MySQL database. So the licensing part was GPL, it was straightforward. But if you're launching SQL Server, the licensing options will show up in that list. It would be either bring your own license, or for some of them, it will give you the utility style pricing model. That means pay as you go. Okay. Similarly for Oracle, it will give you those options as well. So please be aware of that. And in terms of multi-AZ that I shared with you, the multi-AZ option might not be available for some databases. Example, if you take Microsoft SQL Server, the multi-AZ options are only available for some specific regions at the moment. Eventually, it will be available in the rest of the region. So I just want to set the expectation, because I just showed you MySQL. I don't want you to look at it as, oh, that is the same option that's going to apply across all databases. It might vary a little bit. Alright? So when it comes to databases, here we are, we've talked about the different database offerings, which is falling under the RDS section. Now I want to also show you, in the console, some of the other database options that we talked about. So if I go back to the cube, the top left corner, it brings me to the database section, and you can see here, there's DynamoDB, Elastic Cache, RDS, and Redshift. So I talked about Redshift, so let me talk about Redshift for a minute here, show you the UI, how it looks like. So there you are. It says, would you like to launch a cluster of servers? So So this itself tells you there are multiple nodes used in the backend to do the processing work. So I can say launch a cluster, and you can give it a specific name for it. Say for example, I call this my Redshift cluster. You can give it a database name. Master username. And the master password. If you notice here, it also tells you the master password must contain up to 8 or more characters. It has to exclude these. It must contain one uppercase, one lowercase, and one number. Okay, so let's go with that. So continue. Then comes the most important step here. This data warehouse that I'm setting up, what type of node would you like to use? Would you like to use an extra large node? DW stands for data warehouse. Alright? If you notice here also you see old generation and new generation. You see that? 1 and 2. So the extra large gives you about 2 terabyte of hard drive storage per node. And you can actually specify how many nodes do you want. You can say I want 32 nodes maximum. Or you can go with a single node if you need. It's a small data set that you're looking at. You can also go for other types of, as you see, extra large. 8 extra large is 16 terabyte of storage per node. So 16 times 100. That's a lot. Okay. If you need other types, we also have some SSD base here. You can see this a bit better. SSD based, we also have here different types, as you can see. There are other SSD based, which is the new generation ones. So please choose accordingly. And when you're done, it will create this clustered environment. It will take some time to set it up, but once it's done, you will be able to start using it. All you have to do is then go to the cluster view and you're able to upload data and stuff. If you need help, please refer to the documentation link down here. I'll take you to the steps of how to do this. Another important service that I talked about was Elasticache. This is a memory-based service. So it is Memcached or Redis compliant. So if you look at, when I click on Get Started Now, it's asking you first. It's again a clustered environment. So it's asking you for a name for the cluster. So let me just call it EC cluster, Elasticache cluster. The engine type, would you like it to be a Memcached compliant or Redis compliant? You know, the beauty of this is, if you have an application that is currently talking to Memcached environment, if it is using a Memcached, it will be able to talk to it out of box. You don't have to do a lot of changes there in the codes. You just need to point to the relevant endpoints on the Elasticache layer. Okay? And then you can specify how many nodes do you need. Alright? And you can specify what should be each node. Now we are talking about Elasticache, so we are talking about memory, not storage. We're talking about memory per server. And take a look at the list. We've got memory that goes up to like 16 gig, 33 gig, right? 68 gig of memory per server. And then you can specify how many nodes do you need here, right? And you can also choose which version of Memcached you want to use, or which version of Redis that you want to use. So these are certain options that is given to you. And you can also specify aspects like, do you want us to do AutoMiner version upgrades? Should we take snapshots and store it for you somewhere? Managed service, right? You don't have to take snapshot, we can do it for you. So all of these are options which is made available to you as part of the clustering setup of Elasticache. So I did mention we use Elasticache to improve the performance, for example, for the read queries that is happening on the database. You can store the results in the Elasticache layer and you can start querying that layer instead of going all the way down to your database. Another example that I gave you was you can put that for storing your session information. So shopping cart information. All of that can be stored in Elasticache layer as well. So it all boils down to what kind of performance are you looking for. Elasticache is memory based, so it's the fastest of all. Then comes DynamoDB, which is SSD based. And then comes your databases, which could be hard drive based. Alright? So you've got to start looking at your application characteristics, the data, velocity and volume that you're looking at, and then choose the correct type of database. So in the database module, we've covered DynamoDB, RDS, and other databases that I've shared with you. The focus was more around RDS, relational databases as a service. So how many of us think RDS is a great option to have? Yeah. Even the DBAs are smiling now. You don't have to do all that hard work anymore. So I would highly encourage you to go back and explore these services. Alright? take a subset of data, bring it in. For example, if you want to try out Redshift, the data warehouse, take a subset of your existing data, pop it into Redshift and start querying and see the results for yourself, right? So all of these are important services that we've covered in this module. After lunch, we talked about compute services, where we talked about EC2, we talked about EMR, Elastic MapReduce, and we talked about auto-scaling. And then we went into the networking module, where we talked about virtual private cloud and Elastic Load Balancer. And then I also brought up the topic of Route 53, which is a global network of DNS servers that you can leverage on. Alright? And we talked about Direct Connect, which is an important connectivity option that we discussed. Alright? And finally, in database, we talked about DynamoDB, RDS, Elastic Cache, and Redshift. So that's what we have for now. We're going to pause here for a short break. And I hope to see you back in this room in half an hour from now. So let's take a short coffee break. Let's come back refueled, re-energized for the last module of the day. And one gentle reminder, if you haven't received
very good, very reliable.
Welcome back. I'm glad you made it back. See, I still see the folks coming in. Let's get started. Without any further ado, let's do the next module, which is deployment and management. So we've talked about various services today, and we've talked about how to use them, when to use them. Now it's time to reflect back and think about how to deploy these services. So would you deploy this using the management console? Or would you deploy this using the CLI? Or would you deploy this using APIs? Or would you deploy using some other services that we give you? Alright? So we're going to talk about tools that would help us in deployment and also tools that would help us in managing this infrastructure. So the services that I'm going to bring to your attention here would be CloudFormation, CloudWatch, and IAM. So we'll start our discussion by talking about IAM first. Identity and Access Management, that is a service which primarily allows you to create users and put them in relevant groups and give them relevant permissions. So today what we do is, for our administrators, we create a group, maybe an Active Directory, and then you can give them relevant access. Similarly, when we talk about infrastructure resources that is set up on AWS, you should have a way to control who has access to these services, who can do what with these services. We're talking about not business users, we're talking about your IT infra folks, right? The infra, dev, and the DBAs and all of them put together in a network team. So what you can do is, in IAM, you can create a group of users, and then you can give them relevant access. So a part of a group can be the DBA group, can access the database related services, but they cannot touch the rest of the other services. So here there is an effort involved in creating those users, putting them in relevant groups. What if you have these users in Active Directory already? Most of us do, right? In Active Directory or one of the other LDAP sources, you may already have these users. So what you can do is, you can make IAM federate with those sources also. So you can say, hey IAM, Identity and Access Management, I'm going to allow this user to log in. And I've already validated that this user is a valid user in my organization. And because I've validated it, now give them access to these resources. Okay? So it also allows you to do that federation type of setup. Now we'll talk about different types of federation in the next slide. But I also want to highlight IAM does play a very, very important role in ensuring how securely have you set up this environment and how securely do you manage and access this environment. So let's start with the first aspect here. What you can do in IAM, let's start with bullet number 2 there, is you can create users and you can give them individual credentials. For example, you can create a user named John. And for this John, which is a human user, you can create a password. And you can share that username and password with John so that the person John can log in with that username and password. But if you want to make it a bit more secure, you can enable multi-factor authentication for John. So it's not just username, password, but it also requires a token that is generated either on applications like Google Authenticator or AWS Authenticator tools that you will find the apps are available. or you will have to use a physical token, which is a Gemalto token. And you can buy that off Amazon.com, right? So, alright, so it's a Gemalto token. It's a token that generates unique numbers, so you just have to enter that, and that's how you authenticate it. So multi-factor authentication can be enabled for users, alright? So this is an example of a human user. What if you create a user account, which is more of a service level account, which is used by an application to authenticate to maybe one of the AWS services. Like you write an application that is trying to talk to S3 and is trying to upload and download files from S3. But before it does that operation, it has to authenticate first. So you need a user account for that purpose. And that user account does not require a username and password. But that account requires maybe an access key and a secret key. Because you are maybe using the REST APIs. So you may need the access key and secret key. And that can also be generated in IAM. Okay? So you can create a user and you can say generate a pair of access keys and secret keys. And I'm going to use this in my application codes to interact with these services. Alright? So human user, application level user. These are the two types of users that you would see yourself creating in IAM so that you can give them relevant access into the AWS environment. Having said that, if you take a step back and if you look at the codes, as a developer, when you're using an access key and a secret key, what do you usually do with those codes? You bake them in your application, am I right? You specify, use this access key and use this secret key. Is that a great practice? What if the application gets compromised? The access key and secret key is exposed now. So keeping that in mind and hearing these kind of feedbacks from our customers, what we did was we came up with bullet number 1. IAM roles. A concept called IAM roles. So what is an IAM role is what we're trying to understand right now. This is going to be a little tricky to take note, so please listen carefully. IAM role is like a group, right? So you can create a role with a set of permissions. But the role is not assigned to a human user. The role is assigned to a server. So when you're launching an EC2 instance, it allows you to choose an existing role that you've already created. And that role defines what are the privileges. For example, the role might say, you can access that particular S3 bucket. And you can upload and download from there. Alright? Now this role is assigned to a server. Why do you assign it to a server? The reason is because the application running in that server can use the credentials given by these roles. So when you assign a role to a server, the role assigns a temporary credential to that server. And the application running in that server can use that temporary credential to talk to the AWS APIs. For example, it can talk to S3. So you no longer have to bake in a code, an access key and a secret key inside the application anymore. You just have to say, talk to S3. So when the application comes to that line and it says, talk to S3, which is technically called create an S3 connection using the S3 client, it will first look for the access key and the secret key. And obviously it's not going to find it because you didn't put it there. You didn't bake in the codes, right? So it won't find that. Then it will try to look up the environment variables to see find anywhere is the access key or secret key or not. It won't find it there also. The third place that it looks for is inside the server there is a unique URL. And in that unique URL is where this role will leave that temporary access key and secret key. So it will go and look for that information and it will find it in this case and it will use that to authenticate to S3. Now what is that URL that we are talking about? Every server has a URL which is the metadata URL. So please take note of this. The IP address of this URL is the same for every single server. It's like, in Windows, you have the 127.0.0.1 self-pickable IP. Similarly, on all our machines, on all EC2 instances, there is an IP address that you can go to, right? And then that will give you this particular role credentials. Alright? and you would take that credential, or the application will use that credential to authenticate to an AWS service. Now the beauty of this is, the credential is a temporary credential, which means it expires. And when it expires, the role assigns another set of credentials, which can be used by the application again. So in the world of credentials, we always talk about something called rotation of keys. If it's a username and password, we always ask people to change passwords. If it is access key and secret key, we always request people to, or developers to, rotate the keys. It verbally is told, but it never happens. That's a different story. Here, with the help of roles, you are kind of enforcing that. Roles automatically rotates the keys. So it takes care of that security aspect there. Okay. Now what is that URL? It's http://169.254.169.254/latest/IAM/roles. You can actually see that it's in the documentation. So when you look up IAM roles in the documentation, or if you ever search for, this is the search keyword if you want to find the URL, and it will take you directly to the documentation. The search keyword is EC2, alright, metadata, alright, EC2 metadata, and it will give you that URL. If I do a search right now, I can find the URL also. It's there, the first set of results. So it's this 169.254. The URL belongs to each and every server. The content in that URL can be only accessed from within the server. So our application is running within the server, and that's why it's able to use that information to authenticate. Okay? Now this might be fairly new to a lot of us, so I would highly encourage you to take a look at it and explore further, because it helps us to design our applications to be securely deployed on multiple instances, if they are deployed on multiple or even single instances. Alright? So this is another important feature that we have. And the third bullet point that you see here is the federation part that I just talked about. So in IAM, what you can also do is, if you don't want to create user accounts in IAM, you can say, hey, go and look up the Active Directory, or go and look up the LDAP source. Let's validate the user first. If it's a valid user, let's give them access to the particular S3 service or an AWS service. Now the federation is very interesting, because when we started off with support for LDAP and Active Directory kind of sources. But later we added support for web identity federation also. Like for example, if you can log in with a Google account, or a Facebook account, or even Amazon.com account. Now these accounts might not make sense for an enterprise scenario, internal usage. But think about an app that you've designed, and people, when they go to the app, you don't ask them to create an account. You just say, sign in using your Google account. It's like when you go to Dropbox, Dropbox says sign in with your Google account, and they will automatically give you access to your S3 buckets. Okay. So this is another type of federation that is supported. And there is another type of federation that is also added recently. There's support for SAML 2.0. So if you have any SAML 2.0 compliant IDPs, identity providers, this could be Shibboleth or ADFS, for example. You can talk to those sources, validate those users, and you can give them access to the AWS APIs. So federation primarily helps us in not creating users again. Because when you start creating user accounts in multiple locations, then you've got to think about, how do I manage them? What if that employee leaves the organization? Then you've got to go and remove that user from IAM and stuff like that. Okay. So let me take you through the IAM console, a demo on that. So here we are. I've clicked on IAM, and you can see this is the dashboard view. And on the left side, you can see options for groups, users, roles, and all of that. So if you go to groups, you can see there is an option to create a new group. So I'm going to create a group here. Call it administrators. It allows me to set permissions to that group right away. So I'm going to set administrative permissions here. You see, it creates the JSON document automatically. So all our permission documents are in JSON format. So that might be another important thing to take note. If you've never used JSON, you may want to start looking at how to write JSON. Right? So here's an example of that JSON document. So it allows full access in this group. I'm going to create another group called developers. But for developers, I may want to give a different type of access. So you can see there is a list of predefined templates that you can choose from. Alright? So in this case, I want to give them full access to database. So they can access the database view. And they can launch databases. They've got full access on that. So you can use these templates. Later I will show you another way of setting up, which is more granular. Not using a template, but manually choosing one by one. I'm trying to create some users, so I've created the username John. For John, I don't need access keys because it's a human user. So I will uncheck that option. So John is created there. Now if I want to set a password or add John to a group, here we are. That's how we do it. So I've added John to the administrator group. And what would happen is, obviously, if you want to create a new user, for example, an application user, for example, so let's call it an app user. In that case, you would want to generate that access key. An important thing to note here is, this access key and the secret key that gets generated will not be saved on our end. Especially the secret key, we don't store a copy of it. You will have to copy it right now or download that credential from the left side. It's just like the private key that I explained earlier, right? So this is not a private key, it's a text format, but keep that safe somewhere. Because if you want to use this user account, we're talking about application level user account. So then you would need that info. So again, I'm going to add app user to, for example, another group. Just for example, I just want to show it to you. The process of adding is pretty simple and straightforward. Now let's focus on permissions for a minute. So if you look at permissions tab, app user is a member of a group, right? So group level policies apply to that user now. And you can see those permissions set up here, which is full access to RDS. If you look at John, he's an administrator now, so he's got full admin access. And you can see, again, a group level permission applies. Now for John, you can create password. You see on the right side? When I click manage password, you can automatically assign a password, and there you are. This is what you would share with John. And John can change the password. Alright? So this is, in this case, John is a human user, so we've set up a password. We can also enable MFA, as I explained earlier. So the MFA can be a virtual token or it can be a hardware based. And again, those links will give you more info. So as you see here, the virtual based, we have a small table below that talks about what are the different options. And the hardware based, you have to purchase that. So those are the virtual based applications that you can leverage on. Alright? So these apps will generate tokens which will be used by John to further authenticate. So all of that steps is given here. And for application user, we've created an access key and secret key, and you can see the access key, but you can't see the secret key. You can deactivate it, assuming, let's say, it got compromised. You can deactivate it, use another set of access keys and secret keys. Right? So these are certain options that we have. If you're using SOAP APIs, you would need X509 certificates, and you can set up that setting from here as well. So if your application is using SOAP APIs, you would use that information. Now let's say if John wants to access the console, how will we allow? Do you see this URL here in the dashboard? You will have to provide this unique URL to your IT administrators. So I'm giving it an alias name so that it looks more sensible. Earlier the number was representing my account number. So if you notice, when I go to that URL, or when I give John this URL, and when John uses this URL, it won't ask for email address and password. It will ask for username and password. Usually when you go to the management console, it will always ask for email and password. Here, because it's a unique URL, which is connecting directly into my environment, it's asking for username and password. And once entered, John will have admin access here. What I'm trying to show you here is how to create a role. So just now we talked about creating roles. So I'm creating a role for S3. And what I'm doing is I'm trying to assign this to EC2 instance. That's why it says it's going to be used with EC2 service. Then you've got to specify what permissions will this role have. And this is where I'm going to use the granular method. I don't want to give full access to S3, but I want to give specific access. And that's why you can see policy generator. You can use that and you can choose here S3. That's the service that I want to assign policies to. And that's why it gives you all the API calls that can be made with S3. Everything drop down. And here you can granularly choose, saying, I will only allow putting of objects, that is uploading of files. I will only allow getting of objects, that's like downloading of files. So all of that is given to you in the UI. And you also have to specify the bucket name, which is what I did. There's a syntax to follow there. So once you specify this, the role gets created. Now what do you do with this role? You've got to assign this role to a server, right? It's not assigned to any humans or what. So when you go to EC2 view, please take note, the roles are only assigned during the launch of the server. It cannot be assigned later. So if you look at this view, which you are familiar with, when you launch an instance, when you choose the instant type, the next step, if you notice here, there's an option called IAM roles. And that's where you choose that particular role. Alright? So IAM role, which is S3 access, because it's assigned to the server, now the server gets a credential, a temporary credential, which provides all those S3 level access. These credentials can be used by an application running inside that server. Okay? So this is what we have in IAM. So please take a look at it, explore further. There's a lot more here. It's an essentials. What we're doing is a one-day course. So I'm just covering some of the interesting ones, the basic ones that you see in the UI. When you go down to the API layer, there is a lot more things that you can do. You can also generate temporary credentials and assign it to mobile apps. You can assign it to mobile devices. And these are certain things that you should be looking at carefully if you are into the business of developing applications and stuff. And if you want to run that on AWS. So the search keyword for that, if you're interested, if you want to go back and take a look at it, the search keyword for that is security token service. So if you ever search for AWS security token service, you would actually see a document that talks about how to do this, how to create temporary credentials. It's almost like a token vending machine. So instead of vending out Pepsi, it's vending out tokens, credentials. So the reason is in IAM there is a limit of how many accounts you can create. In IAM the limit is we can only create up to 5,000 accounts. So imagine for a minute a customer like Dropbox who's got millions of users. They don't have millions of AWS IAM accounts. What they do is they use security token service to generate temporary credentials on the fly and give it to those apps which is running on phones and different devices. Okay? So that's something that we cover more in detail in other courses, higher level courses like the architecting course. But I just wanted to share it with you so that you can kind of go back and look through it and see how you can leverage on that. Moving on, from a management standpoint, here's another service which is CloudWatch. So IAM is a tool that helps you to manage your environment from a security standpoint. CloudWatch is a tool that helps you to manage from a standpoint of monitoring and proactively taking certain actions. So CloudWatch, what it helps you to do is it allows you to look at and monitor various resources. It could be EC2 instances, it could be load balancers, it could be databases. Alright, we've seen some of the UIs, right? There was a monitoring tab that we saw. So all of that data point is provided by CloudWatch because it monitors it automatically. And the beauty is, it's agentless. Does not run any agent, does not put any load on the server. It monitors and manages all of this at the service level. And you can use CloudWatch to set up alarms. You can say that if it exceeds a certain threshold, and if it remains like that for X number of minutes, let me know. That let me know part could be an email, or it can be an action that it takes automatically. It will shut down the server, for example. You can say shut down that server. Or you can do auto-scaling. So CloudWatch can trigger an auto-scaling policy saying let's add new servers, or let's remove servers. So CloudWatch plays a very important role in kind of proactive monitoring. But in addition to this, if you look at CloudWatch, out of the box, CloudWatch only monitors the service level. It does not look at your applications because it does not have visibility at your application layer. So what if you want to also monitor your applications using CloudWatch and take some more sensible actions? You can create custom metrics. And using custom metrics, you can expose some of those application level metrics. Like, you can look at things like thread, application thread. You can look at memory utilization at the application level. And you can send that data out through CloudWatch and you can take some more actions like auto-scaling based on those information. Right? So these are certain things that you can do. Please take note. It can be done. The documentation does walk you through how to do it. There are examples available as well. So feel free to take a look at those things. And CloudWatch is accessible from the console, from the APIs, from the SDKs and the CLIs. So we've got other partners. What they've done is they've built dashboards on top of CloudWatch. What they do is they take CloudWatch data, present it to you, but they can also talk to the application layer, maybe using agents or custom metrics, and take that data and also they present it to you. And you will find them in the marketplace, the AWS marketplace. Right? If you have the people and the resources, you can build it yourself. So CloudWatch, as I highlighted earlier, keeps this data, all of this monitoring and the metric data. Keep in mind, it only keeps it for 2 weeks. So what should you do with that data? Export it out, store it in S3. Right? So this is one important thing to take note. CloudWatch monitoring data is not stored forever. It is stored only for 2 weeks. So you need to have a process of moving that into S3. And you can do that from the CLI level. Or if you want, go down to the API layer to do that as well. And it also gives you pictorial representations of all these data points. And another interesting aspect of CloudWatch is it can also monitor your bills. How many of us would like to not be surprised by a big bill, a hefty bill? I see a few hands going. The rest of you are easy, huh? Let me call Rick. So obviously you don't want to be surprised by bills, right? So what you can do is in CloudWatch, you can set up billing alarms. You can set up billing alarms to notify you if you exceed a certain amount in terms of your expenses inside AWS. And that's something that I've done. So if I do these demos, for example, and I leave these servers running, over a period of time when it hits a certain amount, it sends me an email, say, hey, you just crossed this limit. Then I remember, oh, I didn't shut off my server. So I go and shut it down. So it's another way of housekeeping. Alright? So do leverage on all these things. So it's all part of CloudWatch. Right, so that's where I stopped talking about management tools. Now let me focus on deployment tools. So there are two services that I want to highlight from a deployment standpoint. The first one is Beanstalk. Elastic Beanstalk is a tool that is in the hands of a developer. So if you have developed an application, say .NET, or Python, or Node.js, right? Or Java, for example, and you want to deploy this application quickly, you don't want to spend time guessing how many servers do you need, how many load balancers do you need to set up auto scaling, do you need this database. So as a developer, you know that you don't want to spend more time on infrastructure guesstimates. You want to focus more on, here's my application, deploy it for me. But Ash did mention this morning, again, the line between a developer and an administrator is growing thin. So as a developer, you should also know now how to deploy these infrastructure components quickly. And keeping that in mind, what we've done is we've provided Elastic Beanstalk, which acts as a platform as a service. So you bring your code, upload it to Beanstalk, and Beanstalk will deploy all the infrastructure components that's required to run this application. Cool? So how many developers do I have in this room again? Do you like this? Yeah. Love it. So take a look at this service. If you've never used this before, take a look at it, because it also allows you to set up different environments. The same application can be deployed in a staging environment, in a test environment, and can be pushed into production. Okay. So Elastic Beanstalk is a service that will help you to deploy your applications quickly without worrying about any of the infrastructure aspects here. Now, developers are happy. The server admins and the network admins are not so happy now. I don't see smiles on your faces. So let me talk about a tool that will help you as well. So CloudFormation is a tool that comes in handy if you are a person who are more focused on setting up infrastructure ground up. You're not looking at what application here, right? But you're looking at more at, oh, I need X number of servers in my web frontend, my app servers, my database servers, I need load balancers, I need auto scaling. All of these things that we talked about today, EBS volumes, S3 buckets, all of these things, I want to do it quickly. I don't want to sit down and click and click and click and do it. I'm getting old. Okay? So, CloudFormation, basically what it does is it allows you to deploy all of these resources in a matter of few clicks. How do we do it? There are two ways to get started. You can either write a JSON-based document, which is what we call a template. And in that JSON document, you can define what are the resources that needs to be deployed. Okay? That's one way to do it. The second way to do it is, you can scan an existing environment that you've already set up in AWS, and it will give you that JSON document out of that. It's like a blueprint of that infrastructure that you've set up. And you can take that blueprint, customize it, and you can use it. Alright? So the concept here is to create a template first. And that template is actually a JSON-based document which defines what resources needs to be created when you deploy this CloudFormation template. So that's one way to write it. Or you can use CloudFormer. That's the name of that tool that can scan an existing environment and it can give you a template out of it. So once you have this template, you can further customize it, and you can have them deployed in multiple environments. So what you can do is you can take the template and you can say, hey, I want to deploy this template in a test environment. Or I want to take the same template but deploy it in a production environment. And you know that when you deploy in these environments, you may want to use different key pairs. You may want to use different sizes of servers. So you can have runtime parameters or runtime modification settings defined in the template as well. So that during deployment, it'll ask you, would you like to use a different key pair? Or would you like to use a different instant type? So all of these options are given to you as part of the CloudFormation deployment view. So what I'm going to do is I'm going to take you through a demo here to show you how it looks like, and I'm going to show you how to deploy it. There is another important resource. We have a list of sample templates available. All right, so you can take those sample templates, modify it, and you can use it for your use as well. So let me take you to the actual demo here. So go to CloudFormation, which is under Deployment and Management. You will notice that in the view, it allows you to create a stack or create a template from an existing resource. So the bottom one is using CloudFormer. The one at the top, what I'm going to do is I'm going to use a sample template that's available here. So I'm going to deploy a LAMP stack. How many of us know what is LAMP? Linux, Apache, MySQL, PHP, right? So instead of spending a lot of time manually deploying all of this, I'm going to use one of the templates that's available here, which is for a LAMP stack. And I'm going to deploy this. You can also write your own template, upload it, browse it as you see here, and choose that. That's another way. In this case, I'm using the template, which is available on the AWS webpage. Now, as you see, it asks you for runtime parameters like passwords in the previous window. Now it is asking you for a name for the stack of resources that is getting deployed. So I'm going to call it LAMP stack. All right. The last step is, do you want to calculate how much would it cost you to run this infrastructure? Do you see estimate cost? If you click on that link, it will open up simple monthly calculator and it will tell you how much it would cost you to deploy this on AWS. I'm not going to do that. I'm going to start deploying this template, and you can see here it says create in progress, and at the bottom part it tells you what's happening. So I'm not going to wait on that. I'm going to deploy another template. Now I want to show you how to deploy a much more complex one, a content management system, for example. Have you used Joomla before? Anyone? Right. Setting up Joomla is not a simple and straightforward process. But let's see how easy it is to do it here. So I've selected Joomla template, specified DB passwords, instant types, those are runtime parameters. I can specify a tag for it. So I'm going to call this Joomla CMS. And I'm going to go to the next step, which is final step, is estimate the price. If I want to do that, it's just a click away. And then click create. And there you are. It's doing the magic work. But what exactly is happening, you can actually see that from the events view. So let's take a look at the old one, the LAMP stack. You can see a web server. A server is getting deployed. A security group just got deployed. And a couple of other aspects that is deployed. So these are resources that you define inside that template. I'll show you how the template looks like now. Where can you find these templates? Remember I was talking about sample templates? It's just a search away. Just search for CloudFormation sample templates. And you will find all of these templates publicly available. So here's the link. I've clicked on it. You can see there are sample templates for Windows servers, for SharePoint servers, for SharePoint implementations. There are also open source applications like Drupal, Golem, Inoshi, Joomla, WordPress, Redmine, Trax. All the sample templates are available. This is the LAMP stack template that I used to deploy the LAMP stack. Now it looks a bit scary, but once you attend the architecting course, you will say, hey, this is nothing this simple. Right? I'm kind of marketing the architecting course, but it's important to spend some time understanding how JSON works. If you know how to write JSON, it will be very easy to write these templates. If not, use a sample template, customize it and use it. And there you are. We're trying to check whether the LAMP stack is ready, and there it is. The server got deployed. The output is the URL that I used, and it allows me to connect to that. Let's take a look at Joomla for a minute. Joomla has two URLs. One is for the user URL, and this is how it looks like. Does that look familiar? Yes, it does. And there's an admin URL for administrator view. And there it is. Did I have to go in and install and configure? I'm not a Joomla guy, but I can deploy Joomla, right? So it's just a matter of setting up the relevant resource aspect in the template and taking that template and using it for deployment. And I did mention earlier, you can scan an existing environment and create a template out of it. And people do that from a DR standpoint as well, right? So if you, for example, if you've set up everything in a single availability zone right now, you attended today's training and you've learned, oh, Denny said, let's implement this across multi-AZ. How do I go about doing that now? Would I go back in the other AZ and set up everything one by one? Or would I just use this tool to scan AZ A and it'll give me a blueprint and I will take that and deploy it in AZ B? Alright? The preferred option would be the easy way to deploy, which is using CloudFormation. So please take a moment to also explore this tool. So that's what we have here. So at the end, deployment and management tools we have talked about. From a deployment standpoint, we have Beanstalk, Elastic Beanstalk, which can be used by developers. And we've talked about CloudFormation, which can be used by any administrators who want to set up infrastructure ground up. And a very good use case for this, before I wrap it up, would be, let's say if the business comes and tells you, we need to set up a test dev environment. Okay? For this project. Would you go and create everything one by one? Or would you have a template ready and use that to deploy a test dev environment? And when you're done with the deployment, once the test dev is complete, from the UI you can say delete this template. And when you delete a template, it will undeploy whatever you deploy. Build ground up, bring it down completely, clean it up. All of that can be done with the help of this. If you ask me the best way to deploy servers, even if it's just one server, you need to have a CloudFormation template for it. Because CloudFormation template also reduces human error. Because in the template you can define what instant type should it be, what key pair should it be, so that people don't type incorrectly. So if a web team comes and says, I want to deploy a web server, here's a template, use this for deployment. Okay? So work towards that. If you ask me, I will learn this first. And then I will start looking at the other services. This is an awesome tool to leverage on. Alright? So that's what we have in this module. Let's do a quick recap of what we've discussed today. When we started off with an introduction to AWS, where I talked about what are the different services that we offer. The global infrastructure that we have set up around the world, which you can leverage on, which is 10 different regions. And we have 51 different edge locations that you can leverage on. And then I also talked about the security mechanisms that we put in place. The most important takeaway there is it's a shared responsibility model, right? So after that, we talked about storage services. And in storage services, we spend more time talking about S3, which is a file-based access. And we talked about EBS, which is a block level access, which you can format, attach it to your servers, which appears as E drives and D drives and stuff. In addition to that, in storage module, we talked about a couple of value-added services. One of them is storage gateway, which you deploy on-prem, and it allows you to leverage on S3-based storages right from on-prem. So it's helping you to burst into cloud, leverage on cloud-based storages. And we also talked about import-export service, which allows you to import your data into S3 quickly. That is by shipping in your hard drives, and we transfer that data from the hard drives using our internal network quickly, and then we send the hard drives back to you. So that's an import-export service. We also talked about Glacier, which is an archival storage service. And I did mention that when you store files in S3, you don't have to keep it there forever. If you're not going to use it, create a lifecycle policy to move it to Glacier. Right? So these are certain services that we talked about in storage. Post-lunch, we talked about compute. And we spent some time talking about how to launch an EC2 instance. We saw how to launch a Linux instance and how to connect or how to SSH into that server. We also saw how to RDP into a Windows server as part of the demo. Then we talked about Elastic MapReduce, which is a big data processing scenario where we give you a hosted Hadoop environment, which you can leverage on. And we talked about auto-scaling, which is primarily for scaling up and scaling down in terms of the number of servers that you need, based on monitoring of various metrics. Then what we did was we talked about networking, where we talked about VPC, how to set up a virtual private cloud inside AWS, how to build different subnets, and launch your servers into relevant subnets. Then we talked about Elastic Load Balancer, which is primarily distributing traffic across multiple servers within a single region, across multi-AZs, right? And then we talked about a DNS service. Do you recall what's the name of the DNS service?
Route 53.
Route 53, exactly. It's a service that helps you to do a lot of things. As far as DNS answering of queries is concerned, it can help you to do round robin, weighted round robin, most interestingly, latency-based routing. Look at where the user is, send them to the nearest resource point. And it also can do health checks All right, it can declare, if it can detect if one of the ELB is down or if one of the servers is down, it can send all the traffic to the other server or the other available endpoint. So those are some of the services that we covered in networking, and not to forget, there's one more connectivity option that we talked about. Do you recall what that is? What is that feature that helps you to connect from on-premise to AWS over a private lease line? Direct Connect, exactly. So you can leverage on Direct Connect as a way to connect your on-prem with AWS. Now, VPC does give you a VPN capability, which you can leverage on, but that is not a dedicated bandwidth. And that's where Direct Connect comes in if you need dedicated bandwidth. So please come and talk to our local folks here so they can refer you to local Direct Connect partners. Alright? Apart from networking, we then moved on to databases. And that's why we talked about relational database. You can use relational database as a service to launch MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. So these are traditional relational databases. And this is a service that we released because customers said we don't want to take care of all the maintenance work, the patching, all right, of the operating system. We don't want to take care of the, daily backups and all of that. Can you take care of all of this for us? So we take care of that for you. We also take care of automatic failover as part of the RDS service. And then we talked about NoSQL database, which is DynamoDB. And I did mention earlier, it runs on SSD. All you have to do is when you create this NoSQL table, you tell us how much reads and writes you need. The rest of it is fully managed. Alright? Unlimited capacity, fully managed in terms of scalability and all of that stuff. So that's another NoSQL database. So if you're currently using NoSQL databases, take a look at the DynamoDB service and see how we can leverage on that as well. It will take away all that undifferentiated work that you do. In addition to that, we talked about Elasticache, which is using multiple servers, taking all of their memory and creating a Memcached compliant or a Redis compliant caching layer. Alright? We also talked about a data warehousing service. Do you recall what was the name of the data warehousing service? Redshift, exactly. So if you have a large amount of data, and I gave you an example of the insurance company. So the best way to remember some of these services are examples. So I told you that you can load petabytes of data in here, and then you can query all of that data using parallelization in the backend. So it will get you those results quickly. So those are the services that we covered in databases. And then we took a break, and then we started talking about deployment and management tools. So a quick recap again of those tools. One is IAM, Identity and Access Management. This is where you create users, you create groups, give them relevant permissions. We also talked about CloudWatch, which is primarily for monitoring this environment. And based on those monitoring, you can take certain actions. One of the actions is to auto-scale. Or you can send an email notification, alright? All these are actions that you can take in CloudWatch. And CloudWatch also allows you to monitor your billing. Alright, not to forget that. And then we talked about tools like Beanstalk and CloudFormation that is primarily helping you in the deployment aspect of things. So Beanstalk will help you in deploying applications quickly without worrying about the infrastructure and the guessing of how many servers and stuff that is required. Versus when you look at CloudFormation, it is primarily helping you to build infrastructure ground up quickly. When you don't need them anymore, you can bring it down. Okay? So these are all the services that we've covered. That's all we have in store for the day. So thank you again for your time. Really appreciate for sitting all the way through, listening to all of this.
Thanks, Danny. Good job. Did he do a good job?
Yes.
Fantastic. Sorry? No? Okay. 2 announcements going on. So another big round of applause for Danny. Now Danny, come back up. Can't leave just yet. YMCA? Yeah. No more YMCA. No more YMCA. But I think you've just set a record. Because you finished 17 minutes and 10 seconds ahead of schedule. So as they say, a fair day's work for a fair day's pay.
Right. Alright, do what do we take?
So I think that you should answer some questions.
Sure.
What do you reckon, guys? Who's got some questions that I'd like to ask Danny? We'll just do a couple. So if you've got a question that you'd like to ask. Sure. Okay, that works well. I know, we do.
Snapshot and what was the last
An
one?
AMI. So the question was, what's the difference between a snapshot and an AMI?
So when it comes to snapshots, if you have an EBS volume, you will take a snapshot from an EBS volume, which is basically backup of the data that is stored in that volume. That's all. What can you do with a volume, or what can you do with a snapshot? You can create a new volume from that snapshot, or you can copy that snapshot to another region, or you can create an AMI out of it. So what's an AMI? AMI is the configuration in terms of what server it is. That's why when you try to launch a server, it gives you an AMI. It does not ask you what snapshot you want to use. AMI is actually made up of snapshots with the OS level configuration in addition to that. So again, one more point to add here. Where are these things stored? AMIs and snapshots.
S3.
They all are stored in S3, exactly. Good one. So question is, how long can I keep the snapshots? Indefinitely. Yes. Right? But it's always recommended that you do a housekeeping there, right? Or else you're going to end up wasting money.
Okay.
For redundancy, the power side, are there two tier 1 providers in Singapore?
Okay, so the question was, for power redundancy, are there two tier 1 providers in Singapore?
So in terms of the hardware aspect of things I did mention earlier, when it comes to the physical security or the physical data center, even we as direct AWS employees, we don't have access to all of that data points. But if you really need that information and it helps you to drive the next step, please come and talk to our local account team. Maybe we can get in touch with the relevant team and give you that info.
Yeah, so with each of our availability zones, we always make sure that they're geographically distributed. So yeah, so we ensure that there's high availability in each of those AZs. And again, we can talk about that in a bit more detail offline if required. Okay. Any more questions?
Question is, how does AWS handle DDoS attacks? In the security module, we talked about various monitoring tools that is set up in the perimeter. And these monitoring tools will proactively look at all these different types of attacks that is happening on the data center, and we prevent these attacks. But in the world of DDoS, there is always a possibility of an anomaly. That's one. Second is, if you have a web server and you go open up port 80 and you are serving these web pages, obviously it's meant to be served, right? So if you see that there is a malicious user who is trying to access that page in a certain fashion, you can always raise a support ticket and we'll work with you in kind of dropping those connections and doing the necessary to prevent those attacks. But at the same time, I will always recommend you to take a look at the architecture aspect of things. So if you do join us for the architecting course, we do talk about the different ways of architecting to mitigate the amount of attacks that's happening and to mitigate the amount of cost that is associated with those attacks. Right? How to reduce that level of expenses.
Yeah.
So let me bring this question to the wider audience. The question here is, when we have a DDoS attack, and if you have an auto-scaling setup at the web tier, auto-scaling will see that, oh, a lot of requests is coming in, so it's going to scale up, right? So if you see that it's going to scale up, but in auto-scaling, you can always set up maximum number of servers. You can say, don't scale beyond this. I have a certain budget. This is my planned budget. This is the number of servers that I can take. I can say maximum number of servers is this. And not only that, whenever auto-scaling is adding new servers, it's actually sending you notifications. You can specify that saying, send me an email notification whenever new servers are added. And based on that notification, you can probably go in and do necessary works. Right? So there are ways to circumvent in a certain level those different types of attacks. But architecting is very, very important. So please, if you can, join us for the architecting course.
Yeah, so I think that's a great segue into talking about some next steps. So great, big round of applause for Jamie. Thanks very much, and great job as always. So I've lost my clicker. No, we've got a separate one. I left it off stage. Fantastic, thank you. Okay, so everyone have a good time.
Yeah.
Learn lots. Ready for the exam that you have to do before you're allowed to leave? Yes? Fantastic. I think there was some great interaction. I know during the breaks, lots of questions coming up. I saw a big line of people at our Solution Architect corner. So for those of you that had the opportunity to visit our essays, I hope that you found that valuable, and we'll make sure that there's some people out there at the end of today as well. So if there's any additional questions that you'd like to ask, please make sure you go and have a chat to the guys on the essay corner. I also noticed quite a few people trying to take pictures of our architecture diagrams on the boards out the front. We'll make sure that in the follow-up email, we'll actually send you a link so that you can download those architectural references. They are available on our website. They can be a little bit tricky to find, so we'll include a direct link to those documents so that you can utilise those. Okay, so quickly, big thanks once again to our friends at Intel for their support today. Really appreciate it. Do we have anyone from Intel in the room? No? Okay. We really appreciate their support. Absolutely critical in ensuring that we can be here today. Now there's time for homework. So a couple of things that I'd really like to enforce. And don't worry, we'll send you an email. So you get an email from me in the next couple of days reinforcing these points. So number one, we need you to complete some hands-on self-paced labs. How many labs do you need to complete? 4 labs. Won't take a huge amount of time. Why is it important that you complete those 4 labs? Not just so you get some credits, but so you get to practice what you've learned here today. Now, if you complete those 4 labs, what are we going to send you?
Credits.
$75 worth of AWS credits. What happens if you complete all 4 labs 3 times? We still only send you $75 worth of credits. But another important reminder, please don't try and log into Quick Labs until you see an email from me in the next couple of days, because we won't have allocated those labs to you. So just hold off until you see that email. And then please go through, complete the labs, and we'll send you $75 worth of credits. Also, it's a good reminder for me, if you haven't already filled out your evaluation form, please do that now and just hold it up in the air, and we've got some of our team members running around grabbing those, so please fill out your evaluation form. Step 2, keep learning. So what we did today was we covered an intro-level class that we offer, AWS Essentials. This is designed to give you a taste of Amazon Web Services. So you've done that. What's next? We have some more advanced classes. Now we do offer these here in Kuala Lumpur on a limited basis. Architecting on AWS, Denny made mention of this class quite a few times during his close. But really, the best practices on building an environment on top of Amazon Web Services. So if you're a solution architect, this is the type of course that you would want to look at. Systems operations on AWS, all about running the environment. More details around things like AMIs and CloudWatch and autoscaling. Really digging down into details around those services. And then our developing class. So if you're a developer and you would like to learn more about building applications on top of Amazon Web Services and how to leverage some of our application services, SQS for example, this is the type of class that you would like to look at, or you should be looking at. We also have a whole bunch of online resources available as well. A couple that I wanted to bring to your attention are some videos that we've created that we call our introduction series. And these are built around all of our core services. We have 8 of these available at the moment, and we're releasing more and more of these every month. These are short, typically 5 to 10 minute introductory videos on a particular service. But the really cool thing is that there is a free hands-on lab included at the end of each one. So taking that concept of hearing, presentation, and then practicing. So you can go to aws.amazon.com/training. Again, the link will be in the email that I send you, and you can go through and have a look at these introductory videos. We also have a whole bunch of other self-paced labs. I think there's about 34 or so in total now, ranging in complexity on a whole bunch of additional topics, and they typically go for about 2 hours. So please go and check out some of these additional training resources that we have available. Okay, oh, there we go. And then number 3 is get certified. So we spoke earlier this morning about not just what AWS can do for your company, but also what impact that it can have on your own career. And I don't think any of you would debate the fact that there's a huge amount of demand for cloud, and in particular Amazon Web Services skills in the market. And what's the best way to demonstrate that you know Amazon Web Services? Go get certified. And we have certification tracks that align to each of those domain areas, so they map to our courses. But you don't have to complete a course. You can self-study for these examinations. You can take the exam right here in KL. We have a number of test centres spread across the city. So you can go to our website. Again, I'll include the link, which is /certification. Read up on these certs. They are quite new. We're seeing a huge amount of traction around people going and becoming AWS certified professionals. And as I said, a lot of resources available on our website that allows you to self-study for these examinations. Who's going to get certified? Come on, guys. We'll keep following you up until you do. You're on our database now. Okay, so just in summary, number 1, what are we going to do? Complete the labs. Number 2, take some more training. And number 3,
certification.
Let's try that last one more time. And number 3? Good job, guys. All right. So just one last reminder. Who hasn't submitted their evaluation form? Hold it in the air.
That was a piece of the Salasin.10 podcast area. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels. That was a piece of the Salasin.10 podcast area. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels.